Hello, hi, namaskar everyone. Just give me a quick response. Am I clearly visible and audible? Students, do write in the comment box if you can hear me properly, if you can see me properly. If it is running smoothly, give me a quick thumbs up in the comment box. Great, great. So good to have you all. Good to have everyone here. Today, we'll be discussing algebra and trigonometry. In the previous session, I sincerely apologize because of the bad health. We are not able to conduct these sessions with the same efficiency, with the kind of efficiency we want to have here, but I'll try to be at my best amid this entire bad health. But still, let's try and revise algebra and trigonometry today. So 3 marathons we are conducting. Yes, I have started, Kevin. Okay, Black Mystery, good to have you all. So today what we'll be doing is, hold on for a while students, let me just see the comments here. Let me just set things a little. Okay, so here we are. Good evening everyone. I repeat my part. 3 marathon sessions for mathematics we are conducting as of now. First one was on calculus, second is on algebra and trigo, and third one will be on coordinate geometry and vectors in 3D. In today's session, our flow will remain very simple. First of all, we'll revise the entire theory of algebra. Then we'll revise entire theory of calculus, that is the identities mostly. And then we'll move towards the questions part. Right? I hope that's perfectly understandable, everyone. Now from here, when I go ahead, what do I see? Let us get started with the algebra part. So we'll be beginning with algebra. So algebra and trigonometry, both low weightage topic, and trigonometry is very hard. Hold on for a while, students. हाँ कंक्षा क्लास में हो बोल जल्दी बोल All right, so let us get started. Just give me a quick update on this, students. Am I clearly visible and audible? Yes. Sushidharan is saying, sir, algebra and trigonometry, both low weightage topic, and trigonometry is very hard. First of all, algebra is not a low weightage topic, and trigonometry is absolutely not. You need to understand everything is equally important. Equally important. Equally important means you may say that trigonometry is not directly asked. Kevin, for that we have already recorded a video, high ROI chapters. There's a short, 1 minute short, you can watch it on our channel. We have recorded a video and released a video on it. And today, I'm trying to justify this point that algebra is not a low weightage topic. Why? Because in algebra, you see matrices, determinants, quadratic, sequence and series. And when you look at them, PNC, probability, statistics, they clearly are not low weightage. I hope you're realizing this. Matrices and determinants, the highest weightage it carries. The maximum number of questions are asked from matrices and determinants and vectors in 3D. So how can you say that this is a low weightage? I hope you are understanding this. I hope everybody is with me now. So first of all, algebra is high weightage, it is high return and high investment. And when you talk about trigonometry, trigonometry is not directly asked, but it is used everywhere. It is used in coordinate geometry, it is used in vectors in 3D, it is used in calculus, and you will be seeing it getting used in algebra as well. So trigonometry is everywhere. Trigonometry is there in the questions of trigo, but it is directly or indirectly used in other sections or chunks as well. So how can you say that trigonometry is something which is having less weightage or less importance? So first of all, please understand, NTA or IIT are intelligent enough to ask everything from your syllabus. So they'll ensure that everything is asked. Everybody got this point? So you got to study everything. Everything is equally important, mind you, equally important. You just cannot say that something is important that needs to be studied and there is something which is less important that can be skipped. No, nothing like that. And if you still want, Kevin, if you want more clarity on which are the most important topics from maximum questions are asked, from where you can generate the maximum output, it will be matrices, determinants, vectors, 3D. Then if I talk about more, then from coordinate geometry, circles and straight lines. And from algebra, a few more topics if I could introduce, sequence and series. And if you talk about calculus, the king of maths, I think I need not highlight application of derivatives, definite integration, area under the curve, and differential equations. Straightforward questions are asked. Everybody got this? So I think everything is equally important, right? So let us get started with the revision part. First of all, we'll be revising everything. Just give me a quick update. Whatever I'm sharing on the screen, I hope it's properly visible to all the participants. First of all, the very basic thing, I hope you know that whenever iota is raised to a certain power, we know that iota follows a cyclicity. For example, if I write iota to the power triple 3. So if I wish to figure out its value, we all know that, sir, just divide it by 4 and check what is the remainder when it is divided by 4. And always remember, when you wish to divide a number by 4, just check its last 2 digits, whether they are divisible by 4 or not. And just divide those last 2 digits and check the remainder. For example, if I wish to check triple 3, when it is divided by 4, what will be the remainder? So just check it for the last 2 digits. 33. So 4 into 8 is 32. So the remainder is 1. So it is equal to iota. Did you get my point, or shall I repeat this? Perfect, that's brilliant. So keep participating, keep interacting. That's how we'll evolve and get better. I repeat my part. Let's say whatever power of iota you're given, whatever power of iota you're given, let's say iota to the power 4, 9, 6, 7, 8, 5, 2, 3 you're given. Now we need to answer what would it be. Don't go for this entire number. Just divide the last 2 digits of this power by 4 and check what is the remainder. So here 23, which means 4 into 5 is 20, remainder is 3. So it is equivalent to iota cube. And do we know iota cube? That is iota into iota square is -1. So it should be minus iota. Something very basic. Sanjana, I think I'm starting from scratch. I'm so weak in maths, it's better to study from your one shots or from the long marathons. Both, Sanjana. This long marathon will help you in covering algebra and of course trigo. And then you can keep watching the one shots. They'll consolidate whatever you have learned and then practice the questions. I hope you got my point. Now from here, if you have understood this iota part, something very crucial you should remember, on which direct application based questions are asked, that if you take 4 consecutive powers, of course integrals, and you take their sums. So 4 consecutive powers of iota and you take their sum. For example, iota to the power 15, iota to the power 16, iota to the power 17, iota to the power 18. The sum is always 0. Please remember that. Whenever you take, Kevin, I cannot make a comment on that. Looking at my situation right now, I'll try to keep it to the point. I'll not stretch it unnecessarily. I'll keep it to the point. So session could go till 8, 9, 10 o'clock, but I'm not sure about that, so I cannot make a comment on that. So I hope you have understood this fact, that remember this, 4 consecutive powers when are raised to iota, and if you take the sum, it is always 0. Something, if you remember and you could use it directly in the exam, then it will save a lot of time. The next result is 1 plus iota upon 1 minus iota, that is always iota. That is always iota. Questions are still asked on it. A lot many times they give you questions like this, 1 plus iota upon 1 minus iota raised to the power, let's say some x, and you are given iota to the power something, let's say, and then they ask you to compare it. So the best thing which you can do first of all is that 1 plus iota upon 1 minus iota, it can save 10 to 15 seconds if you could directly remember this result. Of course, you can get this with the rationalization part. If you multiply 1 plus iota in the numerator and denominator, you get iota. But if you could remember these results, which we are discussing right now, they'll save a lot of time. Because I think Albert Einstein or Abraham Lincoln has said this once, that if you have 6 hours to cut down a tree, spend first 4 hours in sharpening the saw. So we are sharpening our saw. We are sharpening our tools. So if our tools are sharpened, we'll be in a better position to use them in the examination hall and will be more effective and efficient. And our answers will be quick. Our methods will be more optimized. That's what we are trying to do here. So I hope you'll remember this as a result. You wouldn't forget that. And the reciprocal of this will be reciprocal of iota. So 1 upon iota, we all know, is minus iota. So if you have 1 minus iota upon 1 plus iota, that you can always substitute by minus iota. Everybody got that? These are the results which I wouldn't ask you to remember. Something very decent and simple I'll ask you to remember is, let's say if you are given 2 plus 3 iota upon 7 minus 6 iota. So you cannot divide a complex number by a complex number directly, but there to divide it, what we do is 7 plus 6 iotas, conjugate I introduce here. So there, through this, we perform the division. I hope you know that in the denominator we have zz bar, which is mod z square, and in the numerator you know the multiplication of complex numbers. How do we do it? I hope you remember it. 2 into 7, then 2 into 6 iota, then 3 iota into 7, then 3 iota into 6 iota. That you write in the numerator. And in the denominator, it is zz bar, which is mod z square. I hope you remember this result. Please remember this. This is something very prominently used by JEE a lot of times. A lot of questions can directly be done if you could substitute either mod z square by zz bar as per the requirement of the question, or zz bar by mod z square. Thank you so much, Jeevanatham. I hope you have understood this particular part. Can we move ahead from here? Now the next part is, these are some properties of conjugate. What are they? Pay attention to it. I hope they are simple and straightforward ones. What are they? First one, if I could highlight, it is very simple one, that conjugate of a complex number is that original complex number. It's like that transpose only. When you take the transpose of a matrix, you get the original matrix. That's exactly what is happening over here. I hope you remember these two. A complex number, when added to its conjugate, always gives you double of the real part of a complex number. And a complex number, when subtracted from its conjugate, it gives you the double of imaginary part of that complex number. It gives you a very crucial result, another very crucial result. What is that here? If you ever get z plus z bar to be 0, if you ever get z plus z bar to be 0, imagine x plus iota y, x minus iota y. So we get 2x, and if 2x is 0, which means x is 0, x is 0 means the real part is 0, which means the complex number is purely imaginary. The same holds true if z is equals to z bar. Remember this as a fact that in a question, let's say if we are mentioned that there is a complex number which is purely real. I repeat, if in a question it is said that there is a complex number which is purely real, so what will I do? I'll simply do nothing, but I'll take its conjugate and put it equal to the complex number. Did you understand my statement, or shall I repeat that? All I'm saying is that if in a question it is mentioned that a complex number is purely real, if a complex number is purely real, so what I'll do is I'll simply take its conjugate and put it equal to the complex number, and then I'll solve it further, and I'll show you a question based on this particular property. So these are merely not just some simple properties, they are directly used in questions. So we'll be learning their applications through questions, but right now we are seeing or understanding these properties. Everyone comfortably understanding whatever we are explaining here. Now let us move ahead further from here. What do we see next? Pay attention to this, students. The next result is going to be here. Conjugate can be distributed over addition, subtraction, multiplication or division, which means z1 plus z2 conjugate will be z1 conjugate plus z2 conjugate. Same can be done over product and division as well. I hope it is completely understandable. Can I move ahead from here? Now, when I go ahead, what do we see? Something really crucial. I hope you remember when you talk about argument. In simple sense, what is argument? Let's say here, I have a complex number. I have a complex number 2 plus 3 iota. First of all, I need to locate it. So this is clearly going to be in the first quadrant. Now, if it is in the first quadrant, what I'll do is I'll join this complex number with the origin. So this is how you join this complex number with the origin. Now this 2 plus 3 iota is making a certain angle with the positive x-axis in the anti-clockwise direction. So if it is either the first quadrant or second quadrant, it will be measured from 0 to pi. If it is the third or fourth quadrant, it will be measured clockwise. So clockwise means negatively, anti-clockwise means positively. Are you understanding this? Everyone, all the participants. Dubey, are you trying to say something? Because you're constantly putting a lot of dots. I'm not getting it. Now from here, everybody with me on this? I hope there is no confusion on that. So 2 plus 3 iota, if I wish to figure out this angle, I hope basic trigo we all know that this length and this length you can work out. This length is 3, this length is 2. So tan theta will be 3 by 2. So tan inverse will be, theta will be tan inverse 3 by 2. And that theta is the argument of this complex number. So if this is complex number z1, argument of z1 will be tan inverse 3 by 2. Everybody got that? Now these are some basic things which you all should be aware of, that whenever somebody says that two complex numbers are equal, they're like vectors. So if two vectors are equal, what do we know? Sir, their magnitudes are equal, their directions are same. That's exactly what is happening here. So with complex numbers also, what we do is we treat them like vectors. I hope everybody with me on this. Now something very crucial, again, you should remember from here is that whenever somebody says that there is a complex number, its argument is plus minus pi by 2. Either plus pi by 2 or minus pi by 2. So in case of plus pi by 2 or minus pi by 2, do remember it is said to be the purely imaginary complex number. Why? Because if the argument is plus pi by 2, I hope you're understanding, or minus pi by 2, it will lie on the y-axis. And if a complex number lies on the y-axis, that means it is purely imaginary complex number. For example, let's say 0 plus 5 iota, or let's say 0 minus 6 iota. So they'll have their arguments as plus minus pi by 2. If they are positive, this imaginary part is positive, plus pi by 2. Their imaginary part is negative, they are minus pi by 2, the argument. And if the argument of a complex number is either 0 or pi, I repeat, if the argument of a complex number is either 0 or pi, in that case, we say that the complex number is purely real. Everybody getting that? Can I move ahead from here? Now, the next conclusion from this is the properties based on modulus. First of all, I hope you know what is the meaning of modulus. I need not give you clarity on that. Hold on for a while, students. I hope you remember this particular result very profoundly and very clearly, that here, when you get back to this, what is modulus? Let's say z is a complex number x plus iota y. So the distance of this point x comma y from origin is the modulus of this complex number. So modulus is technically the distance, and we all know the distance formula is clearly under root over x square plus y square. Everybody got that? So from here, a few more things come into picture. We all know that modulus will always be non-negative. Since it is distance, it has to be. Then what do we know is, sir, modulus of a complex number, modulus of its conjugate, modulus of its negative, and modulus of its negative conjugate, they all are going to be equal. All of them are going to be equal. Are you understanding this as a fact? Or shall I re-explain this part? All the participants, give me a quick update on this. Everybody got this? Or shall I repeat this line? Because see, if you have x plus iota y, if you have x plus iota y here, then you'll have x minus iota y here. You'll have minus x minus iota y here and its conjugate here. So all of them will be equidistant from origin. If z is here, you'll have z bar here, you'll have minus z here, and you'll have minus z bar here. So they all will be equidistant from origin. Are we going to cover geometry of complex numbers also? Yes, Jivanatham will be covering everything. Don't worry about that. Now, I hope everybody got this. So with that, if I go and move ahead, I hope this particular result we have already discussed. ZZ bar is mod z square. I hope you wouldn't forget that. You clearly would not forget that. Everybody with me on this? ZZ bar is mod z square. Always remember this. This is something very crucial, which is very widely used by JEE. A lot many times in a question, I'll be either substituting mod z square by ZZ bar or ZZ bar by mod z square, depending on the requirement. Then, of course, the way we could distribute conjugate over product or division, same is true for modulus. It can be distributed over product or division. But I hope you remember, modulus cannot be distributed over addition or subtraction. And that's where what does get introduced? The triangle inequality. Do you remember that? So here, if I ask you something very crucial to remember again, this is a triangle inequality which you must not forget. This is another version of it, and the final version of it is this one. We'll be sharing this PDF. All the notes will be shared with you once the session. Definitely, Jivanatham, but it will be in a very crisp, in a very quick manner. I'll not be covering it in a very detailed manner since it is a marathon. If you want it to be covered in a more detailed manner, you still have to wait for the one shot to be released, because here I'll not be going into the depth in detail, coming up with a lot of explanations, the reasoning part, that why is it there, why are we having this like this. So that part I'll not be covering here. I hope you have gotten my point, Jivanatham. Now from here, all I'm saying is that this result you should carry with you. This entire PDF with this entire theory and questions and their solutions will be shared with you on our WhatsApp channel. You can follow it. Its link is given in the description. But I come back to this. This is a property which you got to remember, because this property helps you in finding the maximum and the minimum value of expressions based on complex numbers. What does it say? It says Z1 plus Z2. Modulus of Z1 plus Z2 is always less than sum of their individual modulus, and it is always greater than difference of their individual modulus. Are you listening and understanding? Shall I repeat this line? All I'm saying is that sum or difference of two complex number, and then you take its modulus. So modulus of sum or difference of two complex number will always be less than the sum of their individual modulus, and it will always be greater than the difference of their individual modulus. Please remember that. I repeat, this is something very crucial. You got to remember it. It will be used a lot many times. Whenever you are asked a question based on maximum or minimum value of a complex number, apart from geometry, you can always use this inequality, and this will always help you in getting the answer very quickly. One of the methods is using geometry. The second method is using this inequality whenever maxima and minima based questions are asked from complex number. Can I move ahead from here? Now the next result is, result, remember that this is what we have already discussed. I think I need not tell you. This is like, a vector upon its magnitude, unit vector. So something like that only. I hope you remember that. So with that, when I go ahead, there are certain properties based on argument as well. So from arguments, what I can tell you is, just give me a second. You can treat argument as logarithm. I personally remember the properties. Pranav Sharma is saying sign ND. Pranav, are you talking about the formula for the summation of sine alpha plus beta plus sine alpha plus 2 beta, something like that? Don't worry, we'll be covering that formula as well. Don't worry about that. Now, if I come back to this, I repeat, argument can be treated as logarithm. So the properties of argument are clearly replica of logarithm. How? Have a look at that. Argument of z1 into z2 is equal to argument of z1 plus argument of z2. Sir, then why do we have this 2k pi? That 2k pi is kept deliberately to ensure that argument takes its principal value. Because see, whenever you talk about argument, then argument is either from 0 to pi, or from minus pi to 0, But of course, it can be either pi or minus pi. So we include pi, we don't include minus pi. I hope you got it. So minus pi to pi. So to have your principal argument, we do this adjustment. Similarly, argument of z1 upon z2, argument of z1 minus argument of z2. I hope you remember that. Log m upon n, log m minus log n. Same properties. Similarly, argument of z to the power n can be written as n argument of z. Log m to the power n, n log m. I hope you remember that. In the same fashion, you can remember all of these results. Something which you can keep with you is that if argument of a complex number is theta, then argument of its conjugate will be minus theta. Because if it is theta anti-clockwise, then it will be minus theta clockwise. Everybody understanding and relating this? Can I move ahead from here? Now, when I go further, then we talk about these things as well. Something very crucial you got to remember is this polar form. We all discuss it a lot many times. E to the power iota theta, which is cis, which is CIS, which is cos theta plus iota sin theta. I hope you remember that. Because polar and Euler form simplify your complex number to a great extent. Do you remember that? Now from here, when we go ahead, what do we see? We see few more results. You can directly keep this with you. The only thing which I could ask you to remember at this stage is this, that z is equals to r e iota theta is your Euler form, where I hope you remember, if you are given z is equals to r e to the power iota theta, then I hope you remember very clearly that here the r is called the magnitude or the modulus of that complex number. Theta is called the argument of that complex number, where e is that irrational number, the Nepier's constant, and iota is your imaginary number. Everybody with me on this? Now from here, there is something very crucial. This is a short technique. This is a short trick to find the square root of a complex number. Now what is that? Let me try and tell you that. Let's say there is a complex number. Any complex number you can take. Let's say I am taking a complex number 3 plus 4 iota. So that's a complex number. Everybody listening and understanding that? And I am asked to write its square root. So sir, first of all, are there square roots of complex numbers as well? Yes. So one of the methods is you follow this standard approach, or the second method is if you could remember this formula, you will get the answer within seconds. Now what is this formula? Of course, when you are talking about square root, there should be plus minus, because either when that plus is squared or minus is squared, both will give me 3 plus 4 iota. Now, how do we find the square root? To find the square root, just help me with one thing. Can you help me with its magnitude? So sir, its modulus is going to be 3 square plus 4 square inside an under root. That is going to be 5. So mod z is going to be 5. Now the job is done. Why? Pay attention. So the square root of 3 plus 4 iota as per this shortcut is, pay attention to this, mod z plus real part of z by 2. Just remember this expression, that will help you. Mod z is what? 5. 5 plus real part of z. So 5 plus 3 is 8. 8 by 2. That is 4. Take square root of it. So square root of 4 is 2. So there will be 2 here. Then look at the sign of its imaginary part. So the imaginary part is having positive sign, so use that same sign here. If the imaginary part had a negative sign, use a negative sign. If the imaginary part has a positive sign, use a positive sign. Then, what about the imaginary part? Sir, imaginary part is pretty simple. What you do is under root over modulus of z minus real of z by 2. That means 5 minus 3. That is 2. 2 by 2 is 1. Square root of 1 is 1. So it should be 1 iota. It should be 1 iota. So 2 plus iota with this plus minus is nothing but square root of 3 plus 4 iota. That means when you square this, you will get 3 plus 4 iota. Isn't it interesting? Are you not finding this short technique to be very helpful? Will you be using it? So I hope the only thing you got to remember is this formula. And if you could remember this formula, you can crack the square roots of complex numbers very easily. Can I move ahead from here, students? Then what do we see? These are few more formulae. Basically, they are De Moivre's theorem, which you need not remember like this. I'll definitely give you more clarity. The De Moivre theorem in a simpler sense is given by this, that if you have cos theta plus iota sine theta to the power n, I can always write it as cos n theta plus iota sine n theta, where n should be an integer. But if n is a fraction or a rational number, in that case, this is one of the values, which lays the foundation for cube root of unity or nth root of unity. Do you remember that? And from here, when I go ahead towards cube root of unity, I hope you remember that. So when I wish to solve this equation, x cube is equal to 1. Technically, the real root is 1, but since it is a cubic, it should have 3 roots. So the other 2 roots are omega and omega square. Omega and omega square, we assume them to be conventionally as omega and omega square, but technically, I hope you remember, when you solve them, you get 2 values, 2 imaginary numbers. They are omega and omega square. So with that, I hope you remember a few more results, that omega and omega square are pairwise conjugate of each other. I hope you remember minus 1 plus root 3 iota by 2 and minus 1 minus root 3 iota by 2. If I take omega as minus 1 plus root 3 iota by 2, then we take omega square as the conjugate one. So minus 1 minus root 3 iota by 2. And I hope you remember, imaginary roots, the complex roots, always exist pairwise for a real polynomial equation. So it is a real polynomial equation, cubic, which should have 3 roots. One is one real root. So the other 2 roots will be imaginary and they'll be conjugate. Everybody got this? The second learning from here would be that whenever you take the magnitude of either omega or omega square, that will be 1. It has to be 1. And the next result is very crucial, that 1 upon omega is equal to omega square and 1 upon omega square is omega, which means they are not just conjugate, they are reciprocal of each other. Are you listening and understanding? Not just that, the third result is this, that they are square root of each other. We have just learned the square root of complex number. So if you work out the square root of omega, can you believe that it is omega square? And when you work out the square root of omega square, it is omega. So how beautiful it is. The complex world is amazing. In real world, square root of 4 is 2. So square root of 2 is root 2. But in complex world, can you imagine that square root of omega is omega square and square root of omega square is omega? How can it be possible in the world of real numbers, but in the world of complex numbers, anything is possible. It's like Ant-Man you must have seen in the Marvels. So whenever they wish to justify anything, what they say is that in that world, when particles are so small, anything can happen. Quantum physics they use, right? So the same logic, same theory I'm using here with the complex numbers. The law of algebra are totally different. They don't follow the standard law of algebra. Are you seeing and understanding? All I'm saying is that square root of omega is omega square and square root of omega square is omega. In real world, in the world of algebra, with the real numbers, it does not happen. So it is something really amazing. Complex numbers is one of the best branches of mathematics. If you explore it, you will love it. So it's not just something hypothetical when somebody came up with a thought that sir, under root over minus 1 should be iota, and then he just kept on exploring things. He kept on exploring things and he brought a lot of substantial results. Lot of substantial results means this chapter, complex number, is very widely used in vectors in 3D. It is used in coordinate geometry, the entire coordinate geometry. Straight lines, points, circle, parabola, ellipse, hyperbola, all of these chapters can be clubbed or handled by one single chapter alone, which is complex numbers. Can you believe that? This is the power of this chapter. Amazing it. is, isn't it? Now with that, when I go ahead, the way we have talked about the powers of iota, it should be a multiple of 4 to be 1, otherwise we find the remainder. The same logic we follow for omega as well. So for omega to the power n, we'll talk about its power being divisible by 3. So whatever remainder it gives you, because omega follows the cyclicity of 3. And something very crucial we keep on exploring is 1 plus omega square is 0. And we all know that omega cube is 1. Without any hesitation, we know that, right? Now from here, all I'll say is something very, 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 very important, this result. Please remember this. Please take a note of it. I hope you're carrying a pen and paper along with you. So I'll be making you see the entire theory of algebra and we'll be revising entire algebra. So whenever I'm highlighting something, do take a note of it. In January attempt this year and previously as well, whatever is something really important or on which questions can be asked or framed, I'm highlighting those parts specifically. On this, questions are formed. I repeat, let's say you're given 1 plus omega to the power, let's say 18, plus omega to the power 18 into 2, that's 36, let's say. And I'm asked its value. So just look at this. Where am I having am I having r into r, this 18 and 36, this r, which is what? Here 18. So just look at that 18. Is this 18 either a multiple of 3 or it is not a multiple of 3? I think 18 is a multiple of 3. You can directly state that the answer will be 3. If it is not a multiple of 3, the answer will always be 0. Are you getting it? For example, if it is 1 plus omega to the power 17 plus omega to the power 34, you can without any hesitation say the answer will be 0. You need not even explore this. Jivanatham is saying when you are talking about complex number, your face is just glowing. Yes, I am in love with complex numbers. If you ask me the most favorite, chapter of your entire JEE, I'll say complex numbers. It is amazing. It is amazing. When you get into the details of it, you will see the beauty of complex numbers. And the best part is something absolutely hypothetical. Asif, I'll take the complete theory first, then we'll do the revision with questions. That's the intent of this marathon, which I have already given or taken. Yes, Asif, I'll bring more problems, but first we'll cover the entire theory. I hope that's okay. Now, with that, when I go ahead, few more things we'll discuss. I hope you remember, when you try to plot these cube roots of unity, they always give you an equilateral triangle, where I hope you remember that here, 1 is plotted here, omega is plotted here, and omega square is plotted here. Let's say I'm talking about what is n. N, where n? Where did you see n? Which n are you talking about? Oh, it's not n, it should be r. I'm really sorry. There should be a small correction. Thank you so much for asking that. This should be r. This is not n. So 1 plus omega to the power r plus omega to the power 2r is either 3 or 0 when r is a multiple of 3 or if r is not a multiple of 3. Everybody got that? Now, from here, when I go ahead, what do we see next is this, when you plot these nth roots of unity. For example, let's say I'm solving an equation z to the power 4 is equals to 1. So that will give me 4 roots, out of which 2 will be real and 2 will be imaginary. So 1 will be 1, other will be minus 1, let's say third is alpha and the fourth one is beta. So when you plot these 4 roots of unity, they will be forming a quadrilateral. And it will be a regular polygon, which means a regular quadrilateral, which means a square. And that square will have 2 of its vertices at 1 and minus 1. So if you plot the 4 roots of unity, 1 will be here, minus 1 will be here, alpha will be here, and beta will be here. So this is how you'll get a square formed. And they all will be at a unit distance. They all will be at a unit distance from origin. So their magnitudes will be 1, this, and this. The way we were saying it to be an equilateral triangle for cube roots of unity. So what if I ask you fifth roots of unity? Pentagon, regular pentagon. And everywhere you will see 1 is going to be a fixed root. So with that, you can bring a lot of results or conclusions into picture. Can I move ahead from here? These are few things which we'll discuss. This is something somebody was writing in the comment. I think it was Pranav Sharma. Pranav Sharma, I think this is exactly what you were asking for. Now, here, please understand cos theta, cos 2 theta, cos 3 theta until cos n theta. And similarly here, sin theta, sin 2 theta, sin 3 theta, sin n theta. That's good, Kevin. That's good for highlighting it. It will be iota and minus iota, brilliant and perfect. Now, when I talk about this, this is clearly an AP. But these terms are not in AP, the angles are in AP. So if angles are in AP, it is given by sin n theta by 2 by sin theta by 2 times cos n plus 1 theta by 2. Can we say even roots are symmetric about x-axis? Not always. Joel, not always. Joel Salve, it will not happen. Because please understand, if it is pentagon, so one will be lying on the x-axis, the other two will be there, they'll be conjugate. So yes, they'll be symmetrical, but with some things in mind. Because if something is lying on the x-axis, it can be said to be symmetrical about x-axis, but yes, you need to be more specific in that case. But yes, your statement is absolutely correct, Joel. Good observation. Similarly, when you're talking about these angles being in AP and you take sine ratio, this part remains identical except for this cos. Here you get this sign, but the entire formula remains same. Again, I'll say this is something, if you could remember, please remember this. This is going to be used in your examination. And if you remember these results, you can directly apply them and get the answers within seconds. Sir, why are we learning them? Can we not derive them in the examination? I hope you have the answer to this question. If you're investing time in deriving them in the examination hall, you're wasting your time, right? So you got to remember this, that if you can now learn these formulae, because you have some time, there you'll be having only 3 hours, out of which only 1 hour 15 minutes you'll be devoting to maths. If you like solving maths, then in that case, you won't be having time to derive them. So if you right now have the time to memorize them, why should you not, right? Now from here, when I go ahead, what do we have? This is something very amazing. We all enjoy solving. I think Jivanatham was asking about this as well. Coni method, rotation formula. I personally remember it in a very simple manner. How do I remember it? Let me show it to you. Very decently I keep it remembered. How? Pay attention to this part, students. Just look at this part. Let's say I'll begin with this simple result. Let's say there is a complex number Z2, Z1. So they are treated like vectors. So how I treat it? Z2 minus Z1, that's a vector. I hope you remember it, Z2 minus Z1, that's a vector. And if it is rotated by theta degree in the anti-clockwise direction, and then it becomes Z3 minus Z1, then this vector or complex number becomes Z3 minus Z1. So first of all, I have not merely rotated it, possibly I have changed its magnitude as well. Previously, it may had a length 5, now it may have a length 10. Diagrammatically, it may not look like, but it could have been a possibility. First of all, are you understanding this statement? So how I personally remember it, pay attention to this part. What is the output? What is the output? So the output is Z3 minus Z1. So I write Z3 minus Z1. What was the input? Sir, the input was Z2 minus Z1. So the input was Z2 minus Z1. And how did you get it? Sir, if their magnitudes are same, let's consider the first case, if their magnitudes are same. So if their magnitudes are same, which means I have simply rotated it. I am not making any transformation to their magnitudes. For example, if this is having length 2, this vector is also having length 2. So this is the output, this is the input. So output is Z3 minus Z1. The input is Z2 minus Z1. And what was the operation? Sir, input was rotated by theta degrees in the anti-clockwise direction, anti-clockwise. So when it is anti-clockwise, we take it positively. If it is clockwise, we'll take it negatively. So sir, if Z2 minus Z1 is rotated by theta degrees in the anti-clockwise direction, all you got to do is multiply input, that is Z2 minus Z1, by e to the power iota theta. Now what is the beauty of e to the power iota theta? The beauty of e to the power iota theta is that with the multiplication of e to the power iota theta, you rotate a complex number by theta degree in the anti-clockwise direction. Did you listen to that part? Whenever you wish to rotate a complex number by theta degree in the anti-clockwise direction, then just multiply it by e to the power iota theta. The modulus, the magnitude does not change, but it is rotated by theta in the anti-clockwise direction. Everybody got that? So that's what I'm trying to say here, the basic result. So here, the output upon input should be equal to e to the power iota theta. Or in simple sense, the argument of this complex number will be theta. Everybody listening and understanding this? What will be the change if their magnitudes are also changed? The change will be pretty simple. Let's say this will be the change. What is that? Pay attention to this part. I'll try and show it to you here on the other page. Let me try and do it here on this page. Let's say there is this complex number Z2, Z1, right? Everybody with me on this? And this is rotated and made Z3, Z1. rotated by an angle theta degree in the anti-clockwise direction. Thank you so much, student friend G8U. I really appreciate it. Now, if I get back to the discussion we all are having, all I'm saying is that now, if I want to talk about Z3, Z1, that's the output. So the output Z3, Z1 will be equal to the input, which is what? Z2, Z1, rotated by theta degrees in the anti-clockwise direction. So e to the power iota theta should be multiplied, but the magnitude is also changing. So I need to introduce the proportion of that magnitude. So the output is Z3 minus Z1 upon input is Z2 minus Z1. We can justify, learn or remember this through some other method as well. What is that method? I can write Z3 minus Z1 upon Z2 minus Z1 as Z3 minus Z1 upon Z2 minus Z1 times e to the power iota theta. Now, why are we discussing this? A complex number Z is equal to R e iota theta. So, this is the complex number. This is its magnitude and theta is its argument. I hope you are understanding this Coni method, the rotation formula. Specifically, Jivanatham, you were constantly requesting for it. So, did you get that? Shall I repeat it or have you gotten this? Can I move ahead from here? Now, with that, if I go ahead with this conclusion, I think now we'll talk about some geometry of complex numbers. Not in a very detailed format. Yes, no problem with that. Thank you so much for correcting it. Although it is not covered properly, as far as I can remember, I tried covering a lot of or some algebra, coordinate, calculus. I think that part was covered. Calculus was also left in between. I'm really sorry for that, but let's cover everything here now. So here, I hope the basic idea is that with complex number, you figure out the distance formula as well. Let's say there are two complex numbers, Z1 and Z2. And if I wish to have the distance between them, then all I'll do is mod of Z2 minus Z1. That will give me the distance. So if I now wish to have or prove that 3 points are collinear, we know a slope method, we know the distance formula. The third is complex numbers. How? Z1, Z2, Z3, let's say are collinear. Then Z2 minus Z1 mod of Z3 minus Z2, their sum will be equal to mod of Z3 minus Z1. Basic principle of collinearity, or the area of the triangle made by them will be 0. Great, perfect, brilliant. Now with that, let's talk about few more things. Please remember, with complex numbers, it's really simple and easy. If a triangle has vertices Z1, Z2, Z3, then its centroid is given by Z1 plus Z2 plus Z3 by 3. I hope no confusion on that. And there is something very important. 9-point center will not talk about that, but yes, something very important will talk about this, that except for equilateral triangle, because in equilateral triangle, circumcenter, incenter, centroid, orthocenter, they all coincide. They all are single 1 point. But if they are other triangles, scalene, right angle, or any other triangle, isosceles or something like that, then you have these points to be collinear. Which points, students? HGO. I repeat, HGO. HGO. What are H, G and O? H is your orthocenter. Orthocenter is the point of intersection of all the altitudes. G is your centroid. G is your centroid. Centroid is the point of intersection of all the medians. And O is the circumcenter. O is the circumcenter. Circumcenter is the point of intersection of all the perpendicular bisectors. And remember this, that centroid always divides this line joining H and O in the ratio 2:1. So this ratio is always 2:1. Please don't forget that. Questions are asked on it and it is directly used and applied. So I hope you wouldn't forget that. You will definitely remember it because it is something which is very widely used. Good, that is 2:1. Brilliant, perfect. Now from here, when I go ahead, what do we see? Now let's talk about questions based on or theory based on this chapter, theory of equations. We'll do the theory first and then we'll do the questions. I hope that's okay. Now here, if I get back to this, sum of roots, product of roots, difference of roots. Jivanatham will be talking a lot of theory of geometry of complex numbers in that one shot, right? Because here it will take a lot of time for me to prove them, because if I directly show you the results, it will not be very useful. So I'll give them with the decent valid proofs in the one shot. And before your April attempt, all the one shots of mathematics will get released. You have my shots. I have recorded all the one shots from my end. They're just getting edited and released every day. Okay. Now, I hope you know that sum of the roots is always minus b upon a, product of the roots is c upon a. And if I talk about the difference of the roots, so here it should be modulus, of course, under root d by mod a. Please remember this, don't forget this. Please remember this. Now similarly, then when I move ahead, this is called the converting a quadratic into a perfect square. You all know that. And that's where I say that, let's say this is a quadratic where a is positive. So without even converting into how long till probability? I did not get this, Joel Salve. How long till probability means what? Are you asking that probability will be released when? So unfortunately, probability is the last one shot which I have recorded. I'm really sorry for that, Joel. So the last one shot which will get released will be probability. I hope that's okay. Now, I hope you remember there are three methods. You convert it into a perfect square to find the maximum or minimum of a quadratic, or you differentiate it through AOD, or the third method which you should always use is that the vertex of a parabola, the parabola will be minus b by 2a, comma, minus d by 4a. It could be either upward facing parabola or a downward facing parabola, depending on A. If A is positive, upward. If A is negative, downward. So in that case, this will be the vertex. In that case, the same coordinate will be there on the vertex. So at this point, you get the minima, and this will be the minimum value. If A is negative, at this point, you will get the maxima, and this will be the maximum value. Everybody got that? I hope you are clearly understanding everything clearly. Now, I hope you remember this particular result as well, that whenever I'm given a, let's say, power 4 polynomial, which is biquadratic, it will have 4 roots, alpha, beta, gamma, delta. So sum of the roots taken one at a time is given by minus b by sum of the roots taken two at a time. Sum of the roots taken two at a time is given by plus c by sum of the roots taken 3 at a time, minus d by sum of the roots taken 4 at a time, plus e by, so minus, plus, minus, plus. That's how you keep on doing it. So you need not remember a generalized formula for that. Just understand the method, pattern. Through that you can always develop it. And do you remember in the last session, which we conducted yesterday in the evening, the rank boosted tens analysis, I think, there was a question, a very amazing question based on this property. 2 questions were amazingly good in the last paper, yesterday's paper. And one of them used this. Not just this, a lot of things other than this as well, but they were amazing. Do you remember that? Great. Now from here, when I go ahead, what do we see? Yes. This is something you should remember. This is something you use in calculus. This is something you use. Yes, but student friend, you do that whenever you have the extreme terms same. I repeat this part. What student friend is saying that you can take x square common. Not always. Let's say you are given something like 8x to the power 4. Let's say you are given something like 8x to the power 4 plus, let's say, 6x cube plus, let's say, anything, let's say 2x square plus, let's say, again 6x plus, let's say, 8. Right? So that's a biquadratic. In this kind of quadratic, you can take x square common and work what you're saying, because here the highest degree term and the lowest degree term have the same coefficient. The second highest degree term and the second lowest degree term have the same coefficient. So that's what you do. WSG, what is that? Why are you using acronyms? Why can you not be more specific with your language, your generation? I hope everybody got that. Now, all I'm saying is that here, this will be profoundly useful for you whenever they ask you the number of solutions. They give you a quadratic or cubic or biquadratic or pentic, and then they ask you number of solutions. So always remember, cubic will have curvature like this or this, and biquadratic will always have a curvature like this or this. And then the curvature depends on a lot of other things as well. The highest degree terms, that is the coefficient of x cube. If it is positive, it will come from minus infinity and it will go till infinity. If the coefficient of x cube is negative, it will come from infinity and it will go till minus infinity. Now, all about its root, that will be decided where does x-axis lie. Let's say, if you see x-axis to be lying here, it will have 3 roots. Let's say if x-axis goes through here, it will have 2 repeated roots here and 1 root here. Let's say if x-axis goes here, then 2 imaginary roots and 1 real root. So this all depends on this. WSG is a slang for what's good. I think life is good. Ekaf, fake, Mishal. Sir, can you draw x axis and y axis on that graph? No, you cannot. Unless you are given more information, you cannot. Priyanshu will be doing questions, but as per my method we are following here for these marathons, we'll be doing the entire theory first, and in the end we'll be doing questions. So through marathons, we are ensuring that you do revise the entire theory, the formulae, and then you do the questions. I hope you understood it. The same will be true if the coefficient of x to the power 4 is positive. It will come from infinity and it will go back to infinity. So it will have a certain minima here. And here, if the coefficient of x to the power 4 is negative, it will come from minus infinity and go back to minus infinity, and it will have a maxima in that case. So x-axis could either go like this, or x-axis could go either like this, or x-axis could either go like this. So depending on that, the number of roots will be there. And for that, more information will be given in the question. But do remember 2 things, that if it is cubic, this will be the curvature, and if it is biquadratic, this will be the curvature. Everybody got that? Now from here, when I go ahead, the next part, this can be skipped right now. Sequence and series will be now talking about. Few decent basic things I would like to make you remember is few direct results. Let's say I'm given an AP. I hope I need not tell you what is an AP, what is the formula. Those are some basic things. I'm trying to give you some more detailed, some more hidden facts which you may not have learnt, which you may have missed, which are not highlighted very much, which you should take care of, so that if you could apply them directly in the examination hall, you get the results very quickly. That kind of theory we are revising. I'm not making you revise that cliche theory, that redundant theory, which you have been learning. The basics we are not revising, right? I hope you got the intent. So theory we are doing, but not from the basic, not from the scratch. The kind of theory which is generally missed by you, which you generally forget, which is more prominently used in the questions. And then we'll do the questions. Now if I get back to this, please remember, whenever somebody says that here there is a sequence and the sum of n terms of this sequence is given by an square plus bn, then always remember this, that this is going to be an AP. Did you understand my statement? All I'm saying is that here, let's say I'm saying that there is a sequence, sum of n terms is given by 6n square plus, let's say, 3n. So this will always represent that this is an AP, and you can also figure out its first term, second term, common difference from this expression only. Yes. Good. Everybody got this? Can I move ahead from here? Good. Hello, hi, evening, Radhika and everyone. I understood your point, everybody. So everybody got this? I hope no confusion on that. And few things which you should remember is that the nth term you can directly work out by a times 2n minus 1 plus b. The common difference will be 2a. Or you can simply say that if we know that this, we know this fact that this is an AP. If sum of n terms of a sequence is given by an square plus bn, then always take it as an AP. And I hope S1 means what? Sum of first terms, which means T1. So if you replace n by 1, you get the first term. Then you find S2, that will be sum of first 2 terms. So from S2, if I subtract S1, I'll get second term. And from T2, if I subtract T1, I'll get the common difference. So it's a matter of putting these values of n, finding S2, S1, then from S2 and S1, T2 and T1, from T2 and T1, common difference, and then depending on whatever is asked in the question, we work out the result. So I hope you're getting it, and you will remember this as a result, that whenever you're given an square plus bn, then it always represents an AP, if the sum of n terms of a sequence is given by that. Few basic things you all must be aware of, that let's say there is an AP, and all of its terms are increased or decreased by a fixed number, then also it remains an AP, and the common difference does not change. If all the terms of that AP are multiplied or divided by a fixed number, then also it remains in that AP, but with the updated common difference KD or D by K. Are you listening and understanding? And if, let's say, I'm adding the corresponding terms of two APs, then also it remains an AP. I hope there is no confusion on that. Everybody got these results? Now, GP of n terms, the product of kth term from the beginning and the kth term from the end, is independent of k and it is equal to the product of first and last term. This property based question we did yesterday. All I'm saying is that, let's say, first of all, let's talk about AP. So an AP has terms, let's say a plus d, a plus 2d, a plus 3d, a plus 4d, and let's say a plus 5d. These are 6 terms, right? Now what does it mean? All I'm saying is, let's say I'm taking the sum of first term and the 6th term. What would that be? That will be 2a plus 5d. If I'm taking the sum of second term and the second last term, that will also be 2a plus 5d. If I take the sum of third term and the third last term, that will also be 2a plus 5d. Are you understanding it? So for AP, the sum of equidistant terms is always constant. The same is true for GP in terms of product, which means if you have AR square, AR cube, AR to the power 4, let's say these are the 5 terms. These are the 5 terms. So here, when you say that the product of first and last term, that is a square r to the power 4, second and second last term, a square r to the power 4, third and third last term, which means ar square multiplied with ar square, so that is a square r to the power 4. That's exactly what they are saying. Everybody got this? Can I move ahead from here? Few more properties or results are there based on GP, which means if certain terms are in GP, and if you multiply all the terms by a non-zero value, then also it remains a GP with the same common ratio R. But if you add or subtract a number, then it will not be a GP. Next result is, if there is a GP and if you take reciprocal of those numbers, then also it remains a GP. The common ratio is also the reciprocal of that ratio. And here, if you raise all the terms to a certain power, then also it remains a GP. Are you all listening and understanding it? And something very crucial and very important on which every year, JEE asks a question is this particular property. Please take a note of it. Don't forget this one. What is this property saying? This property is saying that if there are certain terms in AP, I think this is not written properly. Log A1, log A2, log A3 are in AP, where, see, the property I'll explain. Let's say A1, A2, A3 are in GP. Let's say these are the terms. A1, A2, A3 are in GP. In that case, if I take logarithm of them, which means log of A1, whatever base I'm taking, log of A2, log of A3, then they'll be in AP. And the converse is also true, which means if terms are there in AP, given in AP, and if I take their anti-logs, then the sequence which I get will be in GP. Please remember this as a fact. Questions are asked based on that. Everybody got this? Can I move ahead from here? Now, the next result which we discuss will be this. Something incorrectly students do is that if I ask you the geometric mean of 4 and 9, it will be definitely 6. But the geometric mean of -4 and -9, is not 6. It is going to be -6. All you need to understand is geometric mean means the number which is kept between -4 and -9 so that it becomes a GP. So if I put a minus sign here, -6 here, so -4, -6, -9 will not form a GP. But if I put a 6 here, it will be forming a GP. So do take care of it. I hope you wouldn't forget this. Everybody with me on this? Yes, there will be a lot of things which we'll be discussing. This is something which is very basic and easy, and based on this, questions are also framed. Let's say if I'm given 2 numbers and their aim we know is given by a plus b by 2. Let's say there are 2 numbers. There are 2 numbers alpha and beta. So we know their aim is given by alpha plus beta by 2. And if their aim is given by a, then alpha plus beta will be 2a. And the product of those 2 numbers will be what? Their GM is under root over alpha beta. So under root over alpha beta will be g. So alpha beta will be g square. Listening and understanding this? So if I talk about a quadratic whose roots are alpha and beta, we say given by x square minus sum of the roots times x plus product of the roots. So in case, instead of giving you sum of the roots and product of the roots, let's say you're given AM and GM, and then you're supposed to write the quadratic. This is how you do it. Give me a quick confirmation in the comment box. Have you all understood this? Is everyone with me on this, or shall I re-explain this part? All the participants. Now from here, when I go further, these are few results based on sequence and series, which you all know. I'll just be highlighting them. The first one is sum of first n natural numbers must be mugged up by you. You all have it at fingertips, and n plus 1 by 2. Sum of first n odd natural numbers 1, 3, 5, 7, that is always given by n square. Sum of the squares of the first n natural numbers 1 square, 2 square, 3 square, that is n plus 1, 2n plus 1 by 6. Then sum of cubes, you all know, that is n plus 1 by 2 whole square. So that is the square of the sum of first n natural numbers. Great, that's good Shivani. Shiva Nithi, that's good Jivanatham, that's good student friend. Perfect, brilliant. Great, great. Sushi Dhiran. I hope I'm pronouncing your names correctly. If I don't, apologies. This is something which is based on method of difference. Please don't try to mug up this. This is called a short trick, but this is terribly confusing. All I'll say is that instead of this, you can always use method of difference in sequence and series. This is something very interesting. I personally like it very much. All I'm suggesting here is a very simple idea that, let's say, here is a question. Telescoping sum can be applied directly to this category of questions, because a lot many times they give you questions based on that. What is it? Let's say 1 upon 1, 3, 5, 7, 9. So they are in AP. 1, 3, 5, 7, 9. Then 3, 5, 7, 9. So the second term of this is the first term here. Then second term of this is first term here. They all have the same number of terms, 5 terms, 5 terms, 5 terms. And all these terms are also in AP with a certain common difference. And it is going till this term. So this to this sum is needed to be found. What is the short trick? The short trick for this is, of course, it is based on telescoping sum, but the short trick is pretty simple. First of all, take this difference, 9 and 1, the difference here, any of these. So this difference is 8. So introduce this 1 by 8 first of all. Is this PPT available? Yes, student friend. After the session, we'll be uploading this PPT on our WhatsApp channel. You will have all the hard work done by me available to you with just one click. Now, we'll make you do one thing in that case. We'll make you follow our WhatsApp channel. How will you ask you to follow our WhatsApp channel? The link will be given in the description. So we'll ask you to see the description. There you will find the link to follow our WhatsApp channel. And after the session gets over, we'll upload the link to the PDF. And with that, all the notes, all the short notes of entire Algebra and Trigo will be yours. Okay, now can we study? Getting back to the discussion we were having, I was trying to tell you the short technique. The short technique says, okay, Sarfaraz, good to have you. So the short technique says that here, now take the first term and the last term and forget all the remaining terms. But put a negative sign between them, the first term and the last term, and then remove the last factor from the first term and the first factor from the last term. I repeat, keep this 1, 3, 5, 7 here and keep these 4 terms here, exclude this. That will be your final answer. Did you understand this? That's okay. Jivanantham. I don't have WhatsApp any alternate. That's a good choice. First of all, Sushin Dhiran, brilliant. I'm really appreciating this, that you don't have WhatsApp. Good, very good. In that case, ask any of your friends to follow our channel, make him download this, and then you can ask him to email it to you. Not on PW app, Shivanithi, it is on our WhatsApp channel. Okay, can I get back to the discussion we all were having? These are the properties of, so can you take an example? Yes, I can. Definitely I can. All I'm saying is a very basic idea here I'm giving. Let's say this sequence, instead of this, we can take any other sequence as well. Let's say you are given 1 into 3 into 5 plus 1 upon 3 into 5 into 7 plus 1 upon 5 into 7 into 9 and so on until there is a term, let's say, there is a term 101, 103 and 105. So this sequence sum is what we are asked to find out. And then the short technique is pretty simple. What did I say in the beginning? The short technique says that first of all, take, I hope you can recognize the pattern, 1, 3, 5, they are in AP. 3, 5, 7, they are in AP. And it is not necessary that the common difference should be 2. The common difference can be anything. It should be in AP, that's it. And its second term should be the first term here. The second term here should be the first term here. That's the pattern. If that pattern is found, then you can apply this logic. And with that, what is the technique here? First of all, 1 upon this 5 minus 1. You do here, 5 minus 1, that's 4. You write that here. And then forget all the terms in between. Just write the first term and the last term first. Okay. So I'll write the first term, which is 1 upon 1, 3. And then from the first term, exclude the last factor. So remove that 5. And then minus, write the last term, which is this. But from the last term, remove the first factor, which is 101. So I'll be left with 103.105. Everybody got that? And I hope you can simplify this. You know how to solve this. That's your final answer. Within seconds, you got this. Technically, internally, it is a telescoping sum, but this is the generalized result because JEE has been asking questions based on it. So you need not follow the entire process time and again. You can write that direct answer within seconds if you know this trick. Everybody got this? Can I move ahead from here? Now, let's talk about few more results. We know this, that log of x is greater than log of y. Now, it all depends on A. If the base is greater than 1, the same relationship stays there between x and y. But if the base is less than 1, the sign changes. The same logic will be followed here when you take the anti-log. That's good, Arpan. That's good, student friends. That's brilliant. Can I move ahead from here, all the participants? I hope this is understandable. Shall I explain this particular slide or can we move ahead from here? Now we'll talk about the basics of PNC. What are they? I hope I need not tell you that you can always write 6 factorial as 6 into 5 factorial or even 6 into 5 into 4 factorial depending on the need of the question. We all know 0 factorial is 1. Which last step? So she, Dhiran, all this particular one, are you asking for this one? I'll say that here 5 minus 1, I'll write 1 by 4, then I'll write this and this with the difference in between. All the remaining terms will not be there because of the telescoping sum is there in the picture, in the background. But from this, I'll remove the last factor 5 and from this, I'll remove the first factor and that will be the answer. Now, getting back to the discussion we all were having, I think these are the properties we were discussing. Something very crucial out of this, if I ask you to remember, is this one. Remember this, whenever somebody says that x factorial is equal to y factorial, then don't be in a rush to conclude that x is equal to y. The problem here is 0 factorial and 1 factorial is also 1. So x and y could be 0 and 1 as well. So this is how JEE tricks you. Let's say in a question, very subtly, they'll give you something like this information, x factorial is equal to y factorial. In that case, we are in a rush to conclude very quickly that x is equal to y. Had it been like this, why would they not give you same number? Why would they give you something like this in this manner? Because they're trying to confuse you. They're trying to check your basics. They're trying to check these kind of insights. Everybody getting this? So you should stay aware of these results. I hope you wouldn't forget that. From here, something very decent, simple and easy. I hope you remember this. I'll directly explain it with this simple example here only, that if let's say I'm asked to figure out the highest power 3 and 100 factorial, the best practice I do is divide 100 by 3. So 100 when divided by 3, just take the integral part, 33. Then divide 33 by 3, that is 11. Then divide 11 by 3. 11 by 3 is 3, integral part. Then divide 3 by 3, that is 1. And until you get 1 or 0, stop there. You'll be getting 1 in the end. And add all these values. So this is turning out to be 48, which means when you write 100 factorial, it will have 48 3's in it. 48 3's in it means it will have 3 to the power 48 in it, which means the highest power of 3 which can divide it will be 48. Are you listening and watching and understanding? But let's say in case if I ask you what is the highest power of 24 which is there in this, what will be your answer in that case? If you are thinking that, sir, in that case I'll divide it by 24, then you are wrong. It should be prime numbers. So I'll do the prime factorization of 24. So 24 for us is 8 into 3. 24 for us is 8 into 3. What is 8? Sir, it is 2 cube and it is 3. So with a combination of 3 2's and 1 3, I get a 24. So if I'm asked to figure out the number of 24's in it, I'll first of all find how many 2s and 3s are there. So 3s we have already concluded 48. If I talk about 2s, so I'll divide 100 by 2. How much is that? Sir, that is 50. Then 50 by 2, that is 25. 25 by 2, that is 12. 12 by 2, that is 6. 6 by 2, that is 3. 3 by 2, that is 1. So I'll stop here. Now I'll do this sum. How much is that? Sir, 50 plus 25, that is 75. 75 plus 10, that is 85. Correct me if I'm wrong. 85 plus 12. 85 plus 12 is how much? 97. Right? So this sum turns out to be 97. 97 means there will be 97 2's present. No, it's not Lagrange's formula. Lagrange, I think, has not given this. So 97 2's will be there. But I'm not interested in 2's. I'm interested in triplets of 2's. Because with 3 2's, I'll be getting an 8. And with that 8 clubbed with 3, I'll get a 24. So I'm interested in number of 24's, right? So with that, what I'll do next is, I'll check how many triplets of 2's are there. Yes, Satyam, but it will be difficult for you. The part which we have covered in 11th will be understandable, but the part which is there in 12th may not be understandable. Yes, Jivanantham. I think in that case also there could be a slight change here. You need to be aware of that. I'm taking you through that only. So with this 97, if I check it 2 to the power 3, and when 3 divides 97, I think 96. How much is 96? 3 and 2, right? And then I'll be left with 1, 2. So there are 32 triplets of 2. So I have 32 triplets of 2, but I have 48 3's. So I'll say that I need to be very careful that there will be 38 8's and there will be 48 3's. So out of this, the combinations of 8 and 3, the pairs of 8 and 3 will be 32 only, because remaining 3's won't have 8's for them. Are you understanding my language? So with this combination of 8 and 3, I'll be having only 32 such combinations. So if I ask you the highest power of 24 which can divide this, it will be 32. Everybody got this? This is simply the principle of inclusion-exclusion, which we have already discovered and explored. I think it need not be discussed. Now, if I get back to these two formulae, which you all have been learning and memorizing since the very beginning of your 11th and 12th standard, NPR is always n factorial upon n minus r factorial. And here only if I write NCR, then it is given by n factorial upon r factorial into n minus r factorial. Now I hope I need not explain this particular part, that NPR is always NCR into r factorial. What is permutation? It's selection and then arrangement. So if you are simply selecting, it's NCR. But if you are selecting and then arranging, then it is NPR, permutation. I hope you will remember this. This is something very crucial. You got to remember it. So every permutation is a combination first and then arrangement. Sushi Dhiran, why not 48? Because you cannot have 48 pairs. There are 48 3's, but there are only 32 8's. So we have abundance of this 8. To make a pair, to make a 24, you need 8 and 3. So there are only 32 8's. It's like a pairing is needed to be formed, but there are only 32 males and 48 females. How can you make 48 marriages happen? Polygamy is not allowed. So you need to have, so if 48 girls, females and 32 males are there, and a marriage can happen between a male and female, let's say for a while. So in that case, there will be 32 marriages happening in this marriage hall. I hope you are understanding my concern here. You cannot have 48 marriages because two females cannot marry a one person. That's the violation here. Did you get my point here? Sushidharan, or shall I explain it with some other example? Are we clear on this? Now from here, when I go ahead, what do we see is, I hope this particular thing is very well understood by you all, something very decent and basic. What is that? All I'm saying is that, let's say there are n objects which are to be arranged, out of which p are alike, q are alike, r are alike, then it should be divided by p factorial, q factorial and r factorial. Everybody with me on this? And here, let's say I have 8 fingers to our thumb, right? So I have 8 fingers in my hand. So let's say I have 8 fingers, and let's say I have let's say 4 rings. And in any finger, I can wear any number of rings. So let's say in this finger, I can have either 1 ring or 2 rings or 3 rings or 4 rings. So if I ask you in how many ways, and the 4 rings are distinct, they are not identical. So in how many ways can I wear these 4 rings in my 8 fingers, not in thumbs? Thumbs are keeping excluded. So your answer could be either 8 to the power 4 or 4 to the power 8. I also used to get confused. So my teacher in Kota told me a trick which I'm sharing right now. And someday one of you could be sharing it with some other people as well. What is that trick? You approach one of these and ask them. And wherever you get stuck, that's not the right approach. What do I mean by that? Let's say I go to a finger and ask it how many choices do you have. So let's say I go to the first finger and ask it how many choices do you have. So it may say that, sir, you can give me 1 ring or 2 ring or 3 ring or 4 ring, but if you give me 1 ring, then how many choices the second finger has? Then depending on this, the third finger will have the number of choices. So a lot of complexity will get arised, and that's where I'm getting stuck. So I'll not go and ask fingers, I'll ask rings. What do I mean by that? I'll go to the first ring, I'll go to the ring 1 and I'll ask it how many choices do you have. So ring 1 will say I have 8 choices. You can make me wear, you can wear me here or 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 here. So there are 8 choices. So ring 1 has 8 choices. In the same fashion, ring 2 also had 8 choices. Are you understanding it? And I'm not getting stuck. It is very flexible. So ring 1 has 8, ring 2 has 8, ring 3 has 8, ring 4 has 8. 8 into 8 into 8 into 8. That is 8 multiplied 4 times. 8 to the power 4. 4 power 8 or 8 raised to the power 4. I hope you understood it. So a lot many times we get confused. We often get, I do get confused between deciding whether it will be 8 to the power 4 or 4 to the power 8. So this is how I decide. I approach them and ask them, and then they tell me. Everybody got this? Now from here, the next few more results which we'll be discussing is this one. NCR, I think we have already covered. I need not give you clarity on this. These are few more, formally based on that. Let's quickly revise them very quickly. We know NCR is 0 if R is greater than N, because it's basically what? Out of N objects, R objects can be selected in how many ways? So let's say I have 4 friends and I want to select 5 friends out of 4 friends. That can be done in 0 ways, right? Then I hope you know NC0 is equals to NCN, because we know NCR is always NCN minus R, something very basic. We'll keep using it. And there, this is exactly what we have just discussed. I hope there is no confusion on that. And here we remember it that NC1 is N, but NC0 and NCN is 1. For class 12th, any batch will come on YouTube. I think we'll be doing a lot of videos, but I'm not sure about any batch, Satya. Jeevanantham, salute to Kota teachers example, yes. Student friend, I also confused, but I don't give attention to it. No, give attention to it. You are not mature when you talk big things. You are considered to be a mature person or a sound person when you pay attention to the details. So minute details are most important things. You cannot just ignore the nuances. You've got to take care of them. Now from here, if I move ahead, few things which you should remember or by heart is, I hope this is again one of the results which you must not forget. Again, NCN is NCY. Then you cannot say x is equal to y. The other possibility is x plus y could be n. Because of this, the next result is NCR plus NCR minus 1. We all know when this n and this n is same, and this R and R are consecutive, how I personally remember it, increase n by 1 and take the greater R. Satyam is saying, sir, 2027 के लिए कुछ नहीं आएगा क्या? There will be a lot of things. Don't worry, my friend. But right now, we are trying to do a lot of things on YouTube for these kids. Right before coming to this lecture, I have recorded a short for you guys, for those who are in 2027. We are launching and revealing something very soon. Every time, why do you guys get it revealed in these live classes? Satyam, for the students who are moving from 11th to 12th standard, we are bringing the bridge course for you. I was not supposed to reveal it right now. It would get revealed through some, short or video, but I'm making this announcement for you because you're saying, will there be anything for us or not? There will be. First of all, we'll be releasing a bridge course for you. Bridge course means a bridging will do from 11th to 12th, the basics which you might not have covered in the kind of manner you're supposed to, that will do. Okay? Okay, this chapter is harder than calculus. No, it is not. My teacher, again in Kota, told me that if you know PNC, you are intelligent. If you can handle the questions of PNC, then he always used to say, I'll call you an intelligent person. So this chapter is all about IQ. This chapter is all about, looking at the right approach. Because to solve a question, you may think or you may get the wrong idea, and that wrong idea may look right to you or sound right to you. But if you get the right idea, you are having a good IQ. In PNC, he used to say that. With PNC and probability, all the teachers of maths, those who have taught me in 11th, 12th, those who have taught me in my drop years or even in engineering, with probability and PNC, they used to say this: if somebody is good at PNC and probability, you should call them people with high IQ. Okay, now, I hope no confusion on that. And here, this is something very crucial and important. What is this result here, students? Let's say I'm having NCR, which is, let's say, 15 C12. So don't hesitate in writing it as per the requirement of the question, as 15 by 12, and then 15 minus 1, that is 14 C11, as per the requirement. As per the requirement. Are you all there, listening, watching, and understanding this? Another result is, I hope this is what we have just explored. Another result is this one, which is basically an extension of this only. So these two results are simply ones which we'll be using. But if you could remember NCR upon NCR minus 1 as n minus r plus 1 by r, then please, because in one question today, we'll be using this. Not just this, all what we have studied, we'll be discussing. Yes, student friend, I took a drop. Yet I couldn't crack IIT-JEE, and that's fine. Now, I'm still doing good today. I have good food, I sleep well, and I'm teaching to kids like you. That's happiness for me, and I'm very happy with my life. So these are few more properties. Let us take a 10 minutes break and then we'll resume. Will that be okay? So we'll resume in 10 minutes. It is 5:25, so we'll resume at 5:35. Okay? So let us take a break. So that 5:35. Will that be okay? Let me put the first slide so that somebody comes up, should see this. So we'll resume at 5:35. There is a break for 10 minutes. Is that okay, everyone? Students, just give me a quick confirmation. Am I clearly audible, everyone? I hope I am. I am. Can we get started? Okay, so we are resuming again. So far, I think we had a discussion on PNC, most probably. Now let's continue our discussion with some more concepts on it. This is where we were. So, okay, so we all are back. Good to have you all. Come back, everyone. Now, I did my engineering in CSE from IPS Academy, Indore. Now, here if I begin with this particular part, pay attention to this part, students here. If n is even, I hope you remember NC0, NC1, NC2 until NCn. If I ask you the greatest value will happen at the mid value. So the mid value for n is even, the total number of terms will be odd, NC0, NC1, NC2 until NCn. So the middlemost term will be NCn by 2. This is what we use in binomial as well. Similarly, if n is odd, the number of terms will be even. In that case, there will be two middle terms, n minus 1 by 2 and n plus 1 by 2. They will be same. So NC n minus 1 by 2 or NC n plus 1 by 2, they will be same. Did you get that? Now from here, this is something you all have been studying, that NC0 plus NC1 until NCn, it is always 2 to the power n. Similarly, if I take only the even terms, NC0, NC2, NC4, or all the odd terms, NC1, NC3, NC5, they'll have the sum as 2 to the power n by 2, that is 2 to the power n minus 1. Similarly, few more results are there, but I think at least these ones you should keep with you for JEE Mains, at least. Everybody got this? From here, this particular part. The number of ways or combinations of n different things, selecting at least one of them is 2 to the power n minus 1. What does it mean? Let's say there are total n objects. Now in how many ways can I have them? Any number of them. And those n are clearly identical, let's say. Or let's say they are, first of all, not identical. Let's talk about the case. There are n objects. So there is object 1, there is object 2, there is object 3, and so on, and there are n objects, right? Now, if I have any number of choices, any number of scenarios, how will I calculate it? I'll say that for this first object, I have two choices. I can either have it or I cannot have it. So with this object, I have two choices. With this object, I have two choices. So there are two choices for these n objects. So there are total 2 to the power n choices. But I am considering the case where I'm having at least one object with me. So at least one means I should exclude that one case where I'm having none of the objects. Because if I take the cases where this is not taken, this is not taken, this is not taken, this is not taken. So if all the n objects are not taken, that is one case. So that one case is excluded. So all minus none is at least one. So this is how you get this formula derived. Everybody got that? But if in case, let's say, there are identical objects. There are n identical objects. So what is that scenario here? If n identical objects are there, which means, let's say, there is a shopkeeper, a vendor, a fruit seller, and on his cart, let's say there are, 100 oranges kept. So there are 100 oranges are there. There are 100 oranges are there on his cart. Now, out of these 100 oranges, let's say I wish to have any number of oranges. So how can I have them? I'm not putting a constraint. I'm just talking about any case when I can have oranges. In how many ways can I have oranges? Since I'm not defining the number of oranges, it can be anything, which means I can have 0 oranges, I can have 1 orange, or I can have 2 oranges, or I can have 3 oranges. But the problem here is that all the oranges are identical. So if all the oranges are identical, which means whether I take 0 oranges, that can be done in one way, because I'm not taking any orange, that is one way. I'm taking 1 orange, that can be done in only one way. You will say, sir, if you take any other orange, then also that's a different case. No. Since all the oranges are identical, you cannot distinguish, you cannot define which is different. So when you are taking 1 orange out of 100 oranges, that can be done in only one way. Everybody getting this? Let's say I'm taking 2 oranges out of 100 identical oranges. Then it can be done in only one way. You don't say 100C2. So this is one way, this is one way, this is one way. Even 100 oranges out of 100 oranges can be picked in one way. So these are 1 plus 1 plus 1, not 100 times, 101 times. So this is total 101 ways. That is nothing but what? 100 plus 1 ways. Are you getting it? Because this time these 100 oranges were identical. Give me a quick update on this. Everybody understood this? Can I move ahead from here? Now that's exactly what I was trying to make you understand. Now the third scenario, let's say you go to a marriage, a party, let's say. So in that party, what happens is, let's say there are certain types of dishes. Let's say there are 3 types of dals. Let's say dal 1 and dal 2 and dal 3. There are 2 types of chapatis, let's say. So let's say C1 and C2. And there are, let's say, 4 types of sweets. 4 types of sweets. Let's call them S1, S2, S3, S4. Pay attention to what I'm saying here. Yes, brilliant, good Satyam. Now if I ask you, if you go to that party, in that party, in how many ways can you feed yourself? Let's say you're having a thali. So in how many ways can you feed yourself? So you will say, sir, I can have first type of dal, first type of chapati and second type of sweet. So this kind of combinations I can make. So how will I calculate all of this? So all I'll suggest is pay attention to this part. I'll use the basic principle of counting. I go to this dal one and ask it, how many choices do you have? Either I will have it or I will not have it. Of course, you will have at least one dal, at least one chapati and at least one sweet. You call it a proper meal when you have one dal, one chapati and one sweet. That's when you call it a proper thali. So I need to have at least one dal. So first of all, dals can be taken in 2 to the power 3 ways. I take either this, not this, not this. I take this and this, not this. So there are 8 ways. But out of these 8 ways, there is one way in which none of the dals is being taken. And chapatis can be taken in 2 to the power 2 ways. But out of them, there will be one way when none of these chapatis are being taken. Are you understanding it? And sweets can be taken in 2 to the power 4 ways. This can be taken or not taken 2 into 2 into 2 into 2. So that is 2 to the power 4 minus 1. So I can have my thali prepared in such a manner that I have at least one dal, at least one chapati and at least one sweet in these many number of ways. But let's say they change the question. They change the question and they make it like this, that now in this case, you can have chapati only. It is not necessary that you should mandatorily have at least one dal, at least one sweet, at least one chapati. In that case, in how many ways can you feed yourself? In that case, I'll say I have 3 choices for dal, so I have 2 to the power 3 choices, and 2 choices for chapatis, that is 2 to the power 2, and 4 choices for sweets, that is 2 to the power 4, minus 1. Now, why am I excluding this one? You can have all, good, have everything. So, why am I doing that minus 1? Because there will be one case where I'm having none of the dals, none of the chapatis and none of the sweets. In that case, I'm having nothing. And we were discussing about the cases when you have something. So, having something can be done in these minus 1 ways. Instead of learning these formulae, I hope you're understanding them with these party kind of examples. I hope it is understandable. Everybody with me on this? Now, with that, few more things are there. This is something very basic and easy. I'll again explain it with an example. You can keep it with you so that once you have understood the example, you can learn these generalized formulae. Let's say there is a number n. Questions are asked based on this. So let's say there is a number n, and that number n is given by, let's say, 2 to the power 3 into 3 to the power 4 into 5 to the power 7, let's say. Now this number will be a huge number, but I am writing it in its prime factorized form. Prime factorized form means 2, 3, 5 are the prime numbers and they are raised to a certain power, and then, sir, slowly, Arpan, am I going very fast? I repeat, there is a number n. Which part did you not understand, Satyam? The previous part? This part? This particular one? See, the only difference here is, in this case, the condition which was mandatory is that in your thali, there should be at least one dal, at least one chapati and at least one sweet. So that can be done in all minus none, 1. I hope at least 1, all minus none, at least 1, all minus none, at least 1. So at least one dal, at least one chapati and at least one sweet can be taken in these many ways. But let's say that constraint is removed, all you need to do is feed. You can have only chapatis, you can have only sweets, you can have only dals, that is also how you can eat. You can have only sweet and dal, that is also you can eat. So in that case, if there is no constraint on at least one chapati, at least one dal or at least one sweet, I'll say I have total 4 plus 2 plus 3. That is 9 choices in front of me. So I'll have 2 to the power 9 ways Minus 1, I did it because Satyam, if I have none of the dals, none of the chapatis and none of the sweets, then I'm having an empty thali in front of me. And having an empty thali is not considered a way where you are feeding yourself. When you feed yourself, that means you have something substantial, right? You are not eating air. Got my point? So that one way was there where you did not have anything. None of the dals, none of the chapatis and none of the sweets. So that one way we have subtracted. Laksh is saying, why are you teaching in pure English? Read the channel name. Now, I get back to this. There is a number which is defined by this. Now, if I ask you that how many prime factors this number can have, I think if I ask you the number of prime factors it can have will be 2, 3 and 5. So there are 3 prime factors this number has. Everybody got this? Now from here, the next conclusion or the next result which I can ask is, let me take a simpler or a shorter example. Let's say 2 to the power 2 and 3 to the power 3 and 5 to the power, let's say 4. Now let's say if somebody says, how many total number of divisors this number can have? So total number of divisors means all the possible combinations. For example, if I take only 2, then 2 will divide this number. If I take 2 2s and 1 3, that will also divide this number. Let's say if I take 2 2s, 1 3 and 2 5s, that will also divide this number. So in a simple language, all I'm asking is that how do I write all the possible divisors of this number? So in very simple language, with the PNC, you crack this code in this manner, that this 2 has 3 choices. What do I mean by that? This 2 can have power 0 or 1 or 2. Similarly, this 3 has 4 choices. The power could be either 0, 1, 2 or 3. This 5 has 5 choices. Power could be 0, 1, 2, 3 or 4. Which means the total number of divisors. Yes, Aditya Chavan, thank you so much for highlighting it. Here, the total number of divisors will be 3 into 4 into 5. Did you get that? 3 into 4 into 5. Because 2 can be taken in 3 ways. One way when you don't take 2. Second way when you take 1, 2. And third way when you take 2 2s. Similarly, 3 can be taken in 4 ways. 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 3. Similarly, 5 can be taken in 5 ways. 5 into 4, 20 into 3, 60. So if I am asked that how many numbers are there which can divide this number, I'll say there are 60 divisors. Everybody got that? I hope it is understandable. So this is how you develop the logic for it. The same can be verified or validated with this slide which we are giving you. This is called dearrangement. Now what is dearrangement, students? Pay attention. Dearrangement means if something can be done in a specific manner, then how many ways can you do it in an incorrect manner? Which means, let's say there are 5 friends of yours, friend 1, friend 2, friend 3, let's say 3 friends are there. And there are 3 letters, letter 1, letter 2, letter 3. So friend 1 should receive letter 1, friend 2 should receive letter 2 and friend 3 should receive letter 3. Now, if I'll get him blocked, don't worry about that. So here, if I am asking you that in how many ways can I send these 3 letters to these 3 friends so that I can ensure that none of the friends receives its correct letter, its destined letter, which means F1 should receive either L2 or L3, F2 should receive either L1 and L3, or F3 should receive either L1 or L2. In that case, you don't calculate with the simple PNC, you apply dearrangement formula. And dearrangement formula goes like this: if there are 3 friends, so for 3 objects, dearrangement is given by formula up till here. If there are 5 friends, up till 5 factorial. Okay. Now from here, if I go ahead with this conclusion, all I'm saying is for 3 friends, dearrangement can be done in 3 factorial into, I hope you can see this formula, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. Even its approach is pretty simple. 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. So alternatively plus minus, and this is how it goes on. And you can push this 3 factorial inside now. So it will be 3 factorial minus 3. So this basically is 0. So you need not write this. But for the sake of simplicity of remembering the formula, we keep it written like this. Ultimately, this 3 factorial gets multiplied to 1 by 2 factorial. That is 3 factorial by 2 factorial minus 1. And this is clearly 3 because 3 by 2 factorial. I hope you're understanding. So 3 minus 1 is 2. So there are two ways in which you can ensure that none of the letter reaches to its destined location. Dearrangement. Did you understand this concept, or shall I re-explain this part, all the participants? From here, when we go ahead, this is something really important. Again, I'll explain it with an example. Let's say there are 20 students in a class. There are 20 students in a class. And we have to form 3 groups. We have to form, let's say, 3 groups. So I am forming a group of, let's say, 8 students, then let's say 7 students, and then 5 students. So I'm forming 3 groups and I'm labeling them. So group 1 will have 8 students, group 2 will have 7 students, and group 3 will have 5 students. First of all, let's say labeling is not being done. Labeling I'll do later. So in how many ways can these 20 students can be, divided into 3 groups, where first group is of 8, second group is of 7 students, and third group is of 5 students. The very simple idea or approach which can be used here in this case will be really simple here, students, that all you need to do is the direct result I'm saying. Write 20 factorial in the numerator divided by the size of the first group into the size of the second group into the size of the third group. Did you get that? Sir, what if the sizes are identical? What does it mean? It means, let's say, there are 20 students in a class, and now you are framing the groups of 8 students, 6 students, and 6 students. Right? Now, with that, again, the logic remains same. The size of the class divided by the size of the first group into size of the second group into size of the third group. But now pay attention to this. This and this group is appearing twice. Our group of same size is appearing twice. So that count is happening double. So this I'll divide by 2 factorial. So the actual division is this one. So this becomes 20 factorial divided by 8 factorial into 6 factorial into 6 factorial into 2 factorial. Did you get that, or shall I repeat this part, all the participants? If you have gotten confused with this, I'll again share a short technique. What does it mean? Let's say there are students where 3 groups of 5, 5 and 2 groups of 7 and 7 are to be made. So total how many students are there? 15 and 14, 29. So there are 29 total students. And 29 students are to be formed or divided into 5 groups, where 3 groups of 5 each and 2 groups of 7 each are there. Now how do I do this? Pay attention to this part, everyone. I'll have 29 factorial in the numerator, listening and understanding this, everyone, divided by the group sizes 5 factorial, 5 factorial, 5 factorial, 7 factorial, 7 factorial. Now this size is appearing thrice. So I'll divide this further by 3 factorial. So when you divide it, it comes in the numerator. Sorry, it comes in the denominator. And this 7 factorial is also divided further by, I'm really sorry, am I making a mistake here? Yes, I'm making a mistake here. This whole result, I'm really sorry, I need a correction. This whole result is divided by 2 factorial. So this is a number of division, but in that division, this is appearing twice, which is getting counted additionally. So I'll divide it by 2 factorial further, so it comes here. So again, this whole result will be divided by 3 factorial, and 2 factorial further, that will come here in multiplication. So it will be 3 factorial into 2 factorial. Are you able to digest and understand this, or shall I re-explain this part? This is division. Now what is distribution? Distribution means, let's say now I am given a group size, let's say 20 students are there, and they are sent to 3 different cities, let's say Agra, Bombay, and Calcutta, right? And any group can be sent anywhere. I mean, it is not fixed, but the 3 divisions which will happen will be, let's say 8, and then 7, and then 5. So one group will be of size 8, other group will be of size 7, and the third group will be of size 5. And they'll be divided. First of all, these 20 students will be divided into these 3 groups, and then they are distributed. And it is not mandatory that Agra will have this 8 people's group, Bombay will have this 7 people's group, and Calcutta will have this 5 people's group. No, any city can have any number, any kind of group. So first of all here, 20 people can be divided into 3 groups of 8, 7 and 5 in these ways. And now these 3 groups can be shuffled at these three places in 3 factorial ways. So this is division and this is distribution. Are we clear on this? Everybody with me on this? I hope there is no confusion on that now. Now from here, few more things. This is, I think, what we have already covered. These are basics of geometry which you can keep with yourselves and you can apply them as per the need of the question. Now let's talk about binomial. Everybody with me so far? I hope there is no confusion on whatever we have discussed or studied so far. Give me a second, students. Now here, when I go ahead from here, binomial is what we'll be looking at. Just hold on for a while. Okay, going great. So we know the expansion of x plus a to the power n. Distribution कैसे आया है sir? Distribution, let's say I have 3 people are to be supposed, seated on 3 chairs. So 3 persons on 3 chairs can be arranged in 3 factorial ways. That's how we distributed it. So 3 groups were created and they were distributed to 3 cities, 3 factorial ways. Now, I hope you know the expansion of x plus a to the power n. It is something simple and easy, absolutely doable, which begins with nc0, x to the power difference of n and 0, a to the power this 0. How I personally remember it, I always follow this pattern. I write nc1, then I'll take the difference of n and 1, that is the power of x, and then I take this 1 here, which is the power of a, and so on. So if I wish to write the r plus 1th term, I hope you're understanding why are we deliberately saying r plus 1th term. So it is given by NCR, x to the power n minus r and a to the power r. Can you see that? And with that, a lot of things come into binomial as well, which means if x plus a, instead of x plus a, if I talk about 1 plus x, the expansion is more simpler. It is always nc0 x to the power 0, nc1 x to the power 1, nc2 x to the power 2, and so on. Everybody with me on this? I hope there is no confusion on that. Something very important which you should remember here is this one. Questions are being asked on this. How do you use this short technique to solve this? Let's say if somebody asks you, let's say x plus y or anything like that, I'm just giving a very simple expression, to the power 10. In its expansion, give the third term from the end. Give the third term from the end. So instead of looking for third term from the end, the best thing will be write y plus x to the power 10 and write the third term from the beginning. Third term from the beginning, that will be same. Shushant Chandra is saying, sir, questions. Once we are done with the entire theory of algebra and trigo, we'll start solving questions. Don't worry about that. We'll be solving PYQs only. A lot of PYQs will be solving, through which we'll be revising entire algebra and trigo. But I'm still making you do few things which we may not be able to cover through the questions. Questions are there, but questions don't cover everything, through which we might miss something. So first of all, ensuring that entire theory is delivered to you, and then we'll do the questions. Is that okay? Now, when I move ahead from here, this is something we all know, that how to define the rational terms or irrational terms. We'll have a discussion on this with a question. Don't worry about that. We'll take a question on this so that you understand it. This is again a short technique which you must keep with yourself. What is that short technique? Let's learn this short technique. This is again a short technique or trick, whatever you wish to call, to figure out the greatest term numerically. Yes, we'll be solving easy PYQs. Now, for revision, it's advised that we solve decent PYQs, because motive is to revise concepts, to learn the concepts, not to show off the heaviness of the questions, or to bore you, or to make you puzzled or confused. So here the idea is really simple. Let's say I'm asked the numerically greatest term in the expansion of x plus a to the power n. So first of all, what you do is you make it like 1 plus x by a to the power n, which means a to the power n you take common. And then you evaluate this expression. Which expression? You evaluate m. M is given by mod of x by a times n plus 1 whole divided by mod of x by a plus 1. And this expression gives you value of m. Now m could be either an integer or a fraction. If it is an integer, then tm and tm plus 1 are the greatest term numerically. And if m is not an integer, then t gif of m plus 1 is the greatest term. I will take an example on it. A very simple example if I could take, let's say I give you an example somewhat like what? 1 plus, let's say, x by 3 to the power, let's say, 7, where x is, let's say, 5 by 2. So what will be the greatest term, numerically greatest term? Did you understand the question? The question is, find the numerically greatest term in the expansion of 1 plus x by 3 to the power 7, where x is 5 by 2. How do we solve this? Again, just work on calculating this m. Now, how do we calculate this m? This m is given by mod x by a. So mod x by a means what? I hope you're understanding a is 3 here. Are you understanding this? A is 3 here. So it should be mod x by a, which means mod 5 by 2 by 3. Are you understanding it? That is clearly, I hope you are clearly seeing it to be 5 by 6. I hope you all are there. So I can write it as directly 5 by 6 into n plus 1. N plus 1 means what? 7 plus 1, that is 8. Divided by mod x by a plus 1, that is what? That is 5 by 6 plus 1. Correct me if I'm wrong. All the participants are here. Now with that, when I try and simplify m, what do I get m as? We get m as 5 into 8, right? 5 into 8 in the numerator divided by 6, and 5 plus 6, that's 11 divided by 6. So that 6 gets cancelled by this 6. So is there any separate lecture for trigonometry? No. Sonia, we'll be covering it here in this session only. Once we are done with algebra theory part, we'll do the theory part of trigo, and then we'll solve the questions. Everybody with me on this? Now 5 into 8, 40. 40 by 11 is somewhere around 4 point something, sorry, 3 point something, right? Because if it is 44, then it would have been 4. So if it is less than 40, it is around 3 point something, because 33, it is greater than 33. So 3 point something. So I think m is not an integer. So do I have GIF of m? Yes. What is the GIF of m? So GIF of m is clearly 3. So the numerically greatest term will be Tm plus 1. That is T4. So fourth term here will be the greatest term numerically. Did you understand the whole approach, the short technique as well? Are we clear on this? Can I move ahead from here? Now when I go ahead from here, what do we see? The next few more results. We have discussed this one, this one. This is something I want you to put focus upon. Remember this? This is something very crucial. Dubey, why do you keep putting dots in between? I don't get this. X to the power n minus a to the power n. It will always be divisible by x minus a. But x to the power n plus a to the power n is divisible by x plus a only when n is odd. Please remember these two results. They are very highly used in your questions. Multinomial, let's not talk about. It is not something very useful. Now let's talk about expansion of a determinant using Sarah's rule. How do we expand a determinant? I hope you remember. Let's say if you are given a determinant whose elements are a1, b1, c1, a2, b2, c2, a3, b3, c3. I hope you remember this short technique of expanding a determinant. So the short trick to expand a determinant is really simple. What do we do? All Tamil Nadu students, give more content in depth, more questions for JEE Main and Advanced. We love your content, sir, mainly maths. Please, I want to move from 86 percentile to 90 percentile, I think. Kamlesh, thank you so much for that trust, that faith. It's definitely possible, first of all. How to prepare for JEE Advanced after clearing mains. We'll talk about that as well, UT, don't worry about that. But right now, let's focus on this session. Let's do one thing at a time, one ball at a time. And that's how we learn and grow, right? So let's focus on Algebra and Trigo right now. Let's learn the hidden concepts, the techniques, the methods through which you will be optimizing your time, the approaches, so that you get best out of you. You'll be more efficient and effective in the examination hall. That's what we are trying to do here. Of course, we'll consolidate all of this with a lot of questions as well. Don't worry about that. I hope I have answered your query, Kamlesh. Now, from here, we repeat the first two rows. So A1, B1, C1 I write again, and then A2, B2, C2 I write again. Then what we do is, we take the product along the principal diagonal. So A1, B2, C3, A2, B3, C1, and A3, B1, C2. This product we take, and with this product I take that sum and I call it P. Then I take the product along the non-principal diagonal elements. A3, B2, C1, A1, B3, C2, and A2, B1, C3. And then I take their sum as well and I call it n. And from P, if I subtract n, I get delta. That's the value of the determinant. This is also one of the methods. So Sridharan, I totally understand this concern, but I truly don't know Tamil. So the best thing which we can do is, we study in English. I think that's the common language between us. I totally get this. Sir, there is no channel in Tamil. Sir, will you give 20 hours content? No. I am totally not in favor of teaching somebody for 20 hours, not even in for 8 to 10 hours. That's a bad idea, first of all. Something like that cannot be done. Unnecessary, you should not stretch yourself. Because if you stretch yourself today, tomorrow you may not be able to do the average of yours. So keep it decent, keep it simple. Don't stretch it unnecessarily. Because today when you stretch it, tomorrow you flunk. And that's what it should not be done. It should be balanced. Great, I totally get this, all the participants. I totally understand your concern. Now from here, I hope this expansion is very well understood by you all. Minor and cofactor, I hope you all understand very easily. When you talk about minor, you simply take the determinant. But when you introduce cofactor, you use the sign as well. Sign depending on the elements. For example, if I'm talking about cofactor of 1, 1, so minus 1 to the power 1 plus 1 is needed to be appended to the minor here. Everybody with me on this? I hope there is no confusion on that. From here, we know one thing, that if any row's element are multiplied to their corresponding cofactors, we get the value of the determinant. But there is another property, that if any row's element are multiplied to any other row's cofactor, let's say A11 C21, A12 C22, and A13 C23 if I do, then its value will be 0. Do you remember that? Or shall I repeat this property? So let's say I multiply any column's element with the other column's cofactors. It will give me 0. Direct questions are based on this statement as well by JEE. Although there were some more information, some more data, there were some more calculations were supposed to be performed, but these basic minute details, they keep on asking. This is something you should not forget. Please remember this as a direct result, and you will be getting a lot out of this. What does it mean? It means if the value of n order determinant is delta, so there is a determinant whose value is delta, then the value of the determinant formed by the cofactors of corresponding elements of the given determinant is given by delta c, which is delta to the power n minus 1. Shall I repeat this part? Let's say if there is a determinant whose value is delta, and there is another determinant which is found by the cofactors of that determinant. So determinant of the cofactor is given by the same determinant raised to the power n minus 1. PW has so many good Hindi channel which has some many guys, but we are completely dependent on English channel. I totally understand your completion. What's wrong in learning it from here? I hope that's also fine, right? I repeat this part in a more clearer manner. For example, let's say there is a determinant. Its value is delta. It has certain elements A, B, C and all. But there is another determinant, let's call it delta C, which is cofactors of these. So cofactor of A, cofactor of B and all. So I need not find out it explicitly. This delta C will be nothing but that delta to the power order minus 1. So this is third order. So 3 minus 1, that is 2. So it will be delta square. Please remember this property. A lot many times when you are willing to deal with the determinants of the cofactor, you can directly find it with the determinant of the original determinant with this formula. Everybody got this? Now from here, when I go ahead about this particular part, where how do we use determinants in some other parts? There I say that one of the areas where determinants should be used is that when I wish to check whether three lines are concurrent or not. Concurrency means, let's say they are passing through one single point. So I'll take A1, B1, C1, A2, B2, C2 and A3, B3, C3. A1x, B1 by C1, A2x, B2 by C2, A3x, B3 by C3. And if this determinant is found to be 0, then the lines are said to be concurrent. Similarly, if there is a second degree equation, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c, it could represent either a conic, parabola, circle, ellipse or hyperbola, or a pair of straight lines. So how do we distinguish which one is it? It's not about coplanarity. I'm not saying coplanarity, Kamlesh. I'm saying concurrency. Coplanarity you discuss in vectors. I'm still discussing about concurrency. Concurrency when all the three lines are passing through one point. Now I get back to this discussion. The second degree equation is representing a pair of straight lines if ABC, HGF, HGF. the determinant made by this in this manner gives you a value 0. If it is non-zero, it will be either a circle, parabola, hyperbola, or an ellipse. Then depending on the eccentricity, you conclude what will it be. Are we clear on this? Similarly, we have discussed the Kramer's rule as well. If I could simply give you the basic idea, first of all, we define delta. Now, delta is either 0 or it is not 0. So if it is not 0, we always say it has unique solutions. But if delta is 0, then there are two possibilities. It will have no solutions or infinite solutions. So if delta is 0, delta 1, delta 2, delta 3, they all are also 0, then we say it has infinite solutions. But if any of delta 1, delta 2 is non-zero, which means let's say two of them are 0, but still at least one of them is non-zero, in that case we say no solutions. Questions are asked on it. They merge trigo and logarithm as well with this kind of Kramer's rule, and every year they ask a question from Kramer's rule, right? So remember that is also what they keep on asking. This is what we have just discussed. Now these are some standard expansions which you should remember, which you should not forget. The moment you see 1a square, 1b square, 1c square, straight away replace it by a minus b minus c minus a. Remember these results. Why? Because if you remember these results, you'll be getting the conclusions very quickly and you'll save a lot of time. For example, another is ABC, a square, b square, c square, bc, c, a, b. It is first of all equal to 1, 1, 1, a square, b square, c square, a cube, b cube, c cube, which I'm not proving right now. And then you write it as again a minus b minus c minus a, then ab plus bc plus ca. I will Aditya, but again it will unnecessarily deteriorate the quality. So I'll ensure that everybody understands everything. And the same you learn with this. Will you remember that? I hope there is no confusion. Something very crucial, which is very highly asked, ABC, BCA and CAB. There with this cyclicity, it is always a cube plus b cube plus c cube minus 3abc whole negative. And I hope you remember a cube plus b cube plus c cube minus 3abc is 0 if a plus b plus c is 0. I hope you remember that, which means a cube plus b cube plus c cube is equal to 3abc. I hope you haven't forgotten that. We all know that any matrix can be written as a sum of two matrices where one is symmetric and other is skew-symmetric. Do you remember symmetric and skew-symmetric? I hope you do. Symmetric and skew-symmetric means what? If there is a matrix X and if you take its transpose and you get the same matrix, it is said to be the symmetric one. And if there is a matrix Y and if you take its transpose and if you get the negative of it, that means it is a skew-symmetric matrix. So I hope this property you'll remember because questions are asked on this one as well. Now, few things are related to it. I'll simply tell you the logical part. How do you prove it? Then you can remember it by yourself. First of all, this one. Let's say A is a skew-symmetric matrix. Then A to the power 2n is always symmetric. A to the power 2n plus 1 is always skew-symmetric. K into A, where K is a scalar, is again skew-symmetric. And this is how you can generalize these results. Sir, are we going to remember all of them? No. But sir, how do we generate any of these? For example, let's say I wish to check this one, AV minus BA. How do I check it? Questions are asked on this. Let's say, what are we told? A and B are two symmetric matrices. So A is symmetric means AT is A. B is symmetric means what? BT is B. Now, I need to check AB minus BA. What will it be? Symmetric or skew-symmetric? So I'm checking AB minus BA. How do I check it? I take the transpose of AB minus BA. So we know on addition and subtraction, why is it 0? I'll explain that. Don't worry about that. I repeat this part first. AB minus BA, the transpose can be distributed over addition or subtraction. So I can write it as AB transpose minus BA transpose. Now we know over product, transpose and inverse, if it is taken, the order swaps, the order reverses, which means here I'll be writing it as A transpose B transpose. No, it should be B transpose A transpose minus A transpose B transpose, and we know they were symmetric matrices. So here I'll be writing it as BA minus AB. Now if I take negative sign common, it will be AB minus BA. So if I call this matrix as X, when I took the transpose of X, I got minus of X, which means X was a skew-symmetric matrix. So this is how you can derive any of these. I have written all the results, but even if you forget them, this is how you can give the final conclusion. And of course, you cannot remember all of them, but you can remember this method, this technique, and if you apply these simple ones, you can directly generate these results. Few more things based on that. Remember this. When we talk about determinants, then we say that only square matrices determinants can be taken. And with that, we know determinant can be splitted over product, which means first I multiply two matrices and then take their determinant, or simply take their individual determinants and then multiply that value. It gives me the same output. Are you listening and understanding this? Similarly here, this particular part, if A is a skew-symmetric matrix of odd order, then determinant of A will be 0. You can see its proof at a lot of places. You can find 1 minute shorts given on it, so let's not waste our time here. I'll directly say that for a skew-symmetric matrix, the determinant is always 0 if and only if its order is odd. If the order is not odd, it will not be 0, right? A skew-symmetric matrix of even order, if you see a skew-symmetric matrix of even order, then its determinant will always be a perfect square. You can create algebraically a skew-symmetric matrix of an even order ones and then odd order ones, and then you find its determinant. You will see for any value algebraically A, B, C, D, E, F if you take, then also you'll find for odd order it will be 0 and for even order it will be a perfect square. Everybody got this? You will see it happening right there in front of you. Few things which are constantly, prominently, widely and repeatedly used are these, that for a scalar into a matrix, if you take its determinant, that scalar comes out as power n times determinant of that matrix. What is n? N is the order of that matrix. Very widely it is used, right? Conic, yes, 2 to 3 questions, 1 to 2 depending on the paper. So 2 to 3 questions are asked. And conic section is not tough, understand this. Once you have understood parabola and ellipse, hyperbola will come to you. They are not very tough. And remember, if a matrix is multiplied by itself n times and then you take its determinant, or you simply take its determinant and then raise it to power n, will give the same value. Please remember these results. Similarly, if A is a diagonal matrix, we'll be solving a question based on this today. If A is a diagonal matrix, for example here, diagonal means let's say 2, 3, 5 and all the other entries are 0. Then its determinant is always very simple. The product of the diagonal elements 2, 3, 5. Did you get that? Its determinant will be the product of its diagonal elements. Please remember that. Very basic, I think. It's not very tough. Now from here, the most important slide from matrices and determinants, you should simply take a screenshot of it and keep a screenshot. If you say or think that matrices and determinants is the most important chapter from which maximum number of questions are asked by IIT JEE, then those questions are majorly from this particular slide. The first one, if I could begin with, that is A times adjoint of A or adjoint of A into A. Sir, मैंने matrix अभी नहीं पढ़ा है. Yes, I totally get that. Yes, they are very important. So first of all, this lays the foundation for the A inverse, because if this is divided by determinant of A, it gives you the identity matrix where we define the inverse of a matrix. So inverse of A will be given by adjoint of A upon determinant of A. Again, this is the most crucial one on which every year they ask you one question. So one short question will be asked on this property. You will see a question based on this in your paper. Yes. So this property where adjoint of A determinant is needed to be taken, then first of all count the number of times adjoint is appearing. Determinant of A to the power n minus 1, where n is the order, n minus 1 to the power m. This is not whole raised to the power m. This power m is raised as the power of n minus 1. Are you there listening, understanding, watching and clearly getting all of this? Can I move ahead from here? Then adjoint of A, again remember this, determinant of A to the power n minus 2 times matrix A. I repeat, adjoint of A. Please remember this property, determinant of A to the power n minus 2 times matrix A. Then Adjoint of K, as we have just discussed, this K comes out with power n minus 1, the scalar part, and then you take adjoint of A. No confusion on that, I believe so. And A inverse we have just discussed, and inverse, the order reverses. The same fashion transpose does. Right. Now, let's talk about probability. This is something you all know. Odds in favor, odds against. So the power not visible. Which part? So she didn't. This part are you talking about? I'll write it separately. Let's say if I'm given adjoint of A, then what do I do? Its determinant is needed to be taken. Let me write one more time so that it doesn't confuse you. Let's say adjoint of A. So 5 times I have written this, and then I take its determinant. Then what does it imply? First of all, calculate how many times is this adjoint appearing. So this adjoint is appearing 5 times. So this will be nothing but determinant of A to the power n minus 1. Now let's say matrix A is a 3 by 3 matrix. So matrix A is a 3 by 3 matrix, order is 3. So determinant A to the power 3 minus 1, that is 2, to the power m, that is 5. This is not determinant A to the power 2 whole to the power 5, no, this is 2 to the power 5, that is 32. Are you understanding this? Is it visible now? I hope this is more understandable now. Will you remember it? Now, from here, when I go ahead, this is something very basic and easy. Odds in favor and odds against. What does it mean? Let's say when I say odds in favor are 2:3. For an event, let's say odds in favor are 2:3, which means if there are 5 ways in which this can be done, 2 will be favorable for E and 3 will be non-favorable for E. So the probability of E will be given by favorable upon total. And that's how you do the other things as well, which is not a tough task. But odds in favor and odds against, are you understanding? Odds in favor means the number of ways it can be done in the favorable ways is 2. Number of ways in which it can be done in the non-favorable ways. Everybody listening and understanding this? Can I move ahead from here, all the participants? Then, Bayes theorem we all know. We'll take an example, and through an example I'll make you understand Bayes theorem. Don't worry about that. This particular principle of inclusion and exclusion also will understand through an example. This is something where you should pay attention. They mix statistics, binomial and probability together with probability distribution. So there is a variable x, happening of it once, 0 times, 1 times, 2 times, r times and n times is given by, first of all, NC1 if it is happening only 1 time. So success is given by P, non-success is given by Q. So out of n attempts, 1 attempt is chosen, and in that 1 attempt success should be there, and in the remaining n minus 1 trials it should be unsuccessful. So here if that table is given, 3 things are there, N, P and Q. So if I talk about NP, it is the mean. NPQ, it is the variance, I hope you remember that, and under root NPQ, that's your standard deviation. I hope you remember that. Any confusion on that? Please, please, please remember that. Don't forget that. If I could simply highlight this, remember this. Mean is always NP, where what is N? Number of trials. P is the success, probability of having 1 success. Then you have variance, sigma square, that is given by NPQ, and standard deviation is the square root of it. Sir, I'm 96.7 percentile in maths. That's brilliant. Want to push to 98 or 98.5, but the intense atmosphere in the panic and even 6 to 8 questions last time took hours to solve. What to do, sir? First of all, that's good. You're already doing great. Just keep solving previous year's questions. And with pressure, I don't see. I mean, I cannot say that don't be pressurized. How can you not be pressurized? This is such an important day. You'll be pressurized. Where is function and relations? That I covered in calculus, Aditya. And there I told that sets and relations are although part of algebra, but we covered that in calculus. Right? Now from here, these are few things which you all know. I need not cover them. This is something where, let's say, a domain and codomain is given. So number of 1-1 mappings, 1-1 onto, many 1 onto. Even if you don't remember these formulae, you can have that permutation and combination based logical approach, and that you can apply and get the answers. This is how you play cards. So related to cards, D arrangements, I think we have already discussed. Now let's talk about trigo. I think statistics I wouldn't teach, but we'll do questions of statistics. Will that be okay? Now, Trigo will very quickly revise. I think I need not tell you these identities, some very basic identities. We'll just go through them. The 3 basic identities which you have been studying since 9th and 10th standard. Sir, I have only one doubt in that. Please help me with that, sir. Which doubt? Please go ahead with that. I'll clarify. I think regarding quadrants, you know that. So Trigo, I think I need not cover. Domain and range. If you could remember simply the graphs of sine, cos and tan, I think the job will be done. With sine, we know 0, pi, 2 pi, it becomes 0. With pi by 2, 3 pi by 2, it is 1 and minus 1 depending on the multiples of pi by 2. With cos, at pi by 2, 3 pi by 2, it is 0 and 0 pi, there it is either 1 or minus 1 depending on the even or odd multiple of pi. With the 10, we know it is minus pi by 2 to pi by 2, minus infinity to infinity, and that same keeps on happening. Trigo and complex number is headache for me. Okay, no worries with that. So I think this is how you see these numbers. Now, these are some identities. I hope you remember that. Sin a plus b into sin a minus b, that's sin square a minus sin square b, or cos square b minus cos square a. But remember this, cos a plus b into cos a minus b is cos square a minus sin square b, or cos square b minus sin square a. Please remember that. These are product into sum into product. We all have been discussing them, so I think I need not make you revise these. These are also some things which you all know. I'll just simply make you go through few important ones, which means sin a plus sin b. This is simple, 2 sin cos a plus b by 2, a minus b by 2 will be there. For sin a minus sin b, first it will be cos then sin. I hope you know the logic as well. But if it is cos a plus cos b, it will be cos cos. And if it is cos a minus cos b, it will be sin sin with this slight change. I hope you remember this. We know these formula as well. Sin cos 3, sin 3a, cos 3a, tan 3a. For sin 3a, 3 sin a minus 4 sin cube a. One thing which students forget taking care of is this, that even in this year's January attempt, a question was asked on this straightforward identity. 4 sin 60 minus a sin 60 plus a is sin 3a. So a direct question was asked by even JEE Advanced as well way back, and this direct identity was being used. And if you could crack A, then you would have done the job. Aditya Chavana is saying in checking for 1 function, why can't we equate the function to a number of its range and try to check to find its solution for that particular range? As if we get 2 solutions, it will be many one. Yes. As far as I'm considering your concern, Aditya, you are saying that if I wish to check whether a function is 1 or many 1, so why can't we equate that function to a number of its range and then try to check to find a solution for that particular range number? No, Aditya, that's a bad idea. Why? Why is it a bad idea? Because let's say if I could show you with the simple mapping, how unfortunate we would be. Let's say this is a mapping ABC and this is DE. So A and B are mapped with D and C is mapped with E. So from range, let's say you have taken E fortunately, and for E pre-image is C. So you have verified it is 1, 1. As per your logic, this function is 1, 1. But unfortunately, you did not take D. Had you taken D, you would have called it many 1. So in that case, I cannot say, thank you so much, Akanksha, I will have. In that case, I cannot say, I mean, that's a bad approach. It's like, you know, it's a terrible idea. I hope you're understanding, sir. But in quadratic function, because in quadratic, except for one point, it is always many 1. Except for this point, it always gives you 2 values. Aditya, are you getting my point? Why are you generalizing these results? You cannot generalize this. Generalizations are always bad, Aditya. Right? Did you understand my point first of all? So take any equation for your concern, it will work. Just trust me, Aditya, it is not always about polynomials. Polynomials are always many 1. Except for linear, that is 1, 1. Then quadratic, cubic, biquadratic, they are always. We just have to check D greater than 0. No, that also you need not check. Polynomials are always many 1, except for linear. But apart from that, there are a lot of other functions as well. Log, exponential, modulus, piecewise functions, signum and all. There you need to be very, 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 very careful. You just cannot follow this approach. Am I answering your concern, Aditya? Because with polynomial, we see the graph will be either like this or something like that. And they are always many 1. There are always many 1. Are you getting it? Everybody with me on this? Now, here, I was highlighting this particular fact. Now again, sin 2a cos 2a, we remember it, but something which students still forget when I ask them, 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. Never forget that. This is very highly used. Tan 2 theta we all know. Tan 3 theta is what we know. Please remember these results. You can solve a lot of questions directly within seconds if you remember them. I'll show you today how with some questions. Now, with that, these are some which you got to remember. Before I talk about these half angle formulae, let's talk about this. A sin theta plus b cos theta always lies between minus of root over a square plus b square to root over a square plus b square. But when you talk about these, if I could highlight few, then sin 15 degree, cos 15 degree, you should memorize. 18 degree, you should memorize. And with that, I think with 15, 75 degree comes into picture automatically. So at least 15 degree and 80 degree you should have at your fingertips if you are preparing for JEE Mains as well. Because a lot many times you have to deal with sin 15 degree, cos 18 degree, and if you remember them, you can directly apply them. Everybody seeing and understanding this? Yes, great. Now from here, some general results which you all have been discussing or seeing. If sin theta is 0, we know theta is n pi. Through graphs you can generalize. What is this, sir? These all are compound angles. With the compound angle formulae, we derive them, and these values you should have. Right? These are some general results. Few results which you, although as per NTA's prescription, we can derive. No, it's not easy. It's not that easy. It's not that easy always. It's easy, but it's lengthy. So you cannot do that. Third thing which you need to understand here is that trigonometric equations is omitted, but it is still used. Especially these three ones you shouldn't forget. Sin theta is equals to sin alpha, cos theta is equals to cos alpha, tan theta is equals to tan alpha. If sin theta is equals to sin alpha, theta is n pi plus minus 1 to the power n alpha. If cos theta is cos alpha, theta is 2n pi plus minus alpha. And if tan theta is tan alpha, theta is n pi plus alpha. Few more results are there, but at least these many you should remember. And if you are comfortable with the graphs, you can crack them very easily. Great. Then these are the inverse. I hope you remember, we take their principal domain and through that we define them. So I think I need not explain them. You can see this table and it is understandable with that. There you need to pay attention. Sine inverse of sine theta is theta, but not for all x which are real. That's a mistake. It is theta only if theta is from minus pi by 2 to pi by 2. That you got to take care of, right? The same holds true for these results as well. Please don't forget it. Don't always say that, sir, sine inverse will nullify this sign. It will neutralize it and you will be left with theta. Not always it can be done. First of all, you need to ensure that this theta lies between this domain. If it doesn't, then you cannot do that. And in the question, they'll give you it in such a manner, they'll add some conditions to it so that you can get rid of it. And if you cannot, then bring this theta in that domain using cyclicity or periodicity of these periodic functions. Yes. Okay, from here, when I go ahead, this is something more important. Previously, it was sine inverse of sine theta. Now it is sine of sine inverse x. So previously it was angle, now it is value. So sine of sine inverse x will be x. Again, x should be from minus 1 to 1. Let's say if I say sine inverse of sine of sine inverse of 2, what will it be? If you say 2, then you are again wrong. Sine inverse 2 is not defined. 2 is not in the domain of sine inverse. So with that, you don't always say it is R. There was a question once asked by JEE Mains only, that if you have sine inverse x plus cos inverse x, and we are always in a rush to write it as pi by 2. No, that's wrong. It is pi by 2 only when x is from minus 1 to 1. If x is not between minus 1 to 1, it is not pi by 2. It is not even defined. Because then they don't exist. Are you understanding my statement very clearly? Right? With that, I hope all of these properties are understandable. Few more are generated. I personally remember it like this, that sine, tan and cosec go together. cos, sec and cot go together, which means they are odd functions, sine, tan and cosec. And for cosec, sec and cot, they become pi minus. Are you understanding my language? And the same is there with the reciprocal as well. But there, the principal domain comes into picture with this. Then you have sine inverse x plus cos inverse x. I hope we have just discussed it, but it should be minus 1 to 1. Tan inverse x plus cot inverse x is pi by 2 for all real x. Right? And there sec inverse x plus cos inverse x is also pi by 2, but then x should be either less than minus 1 or greater than 1. I hope you're understanding why. Similarly, tan inverse x plus tan inverse y, we often use this result only, but it has its own variants depending on the values of x and y. Similarly, sine inverse x plus sine inverse y, cos inverse x plus cos inverse y, but often we'll be talking about this result only, tan inverse x plus tan inverse y. We'll convert it into this, and with this one formula only, you will get the final answer. So are we clear on whatever we have studied so far? So we are done with the theory part. Now we'll begin with the questions part. So let's take another 10 minutes break and then we'll resume. Is that okay? So it is 6:35. We'll resume at 6:45. I hope that's perfect and fine. So let's have another 10 minutes break. You also stretch yourself. We'll resume. Is it visible here? We'll resume at 6:45. Okay? What is wrong here? Hello, hi, namaskar everyone. Just give me a quick update. Am I clearly visible and audible? Just write it in the comments so that we can resume with our discussion. Once we are done with the theory, now let's move towards the question. Now we'll be doing the questions. Shall we get started, everyone? All the participants, just give me a quick update. Can you all hear me? Can you all listen to me? Am I visible and audible to all the participants? Are you all there? Let me just refresh it. Yes, time over. Thank you so much for time over. Great. So we'll be solving these questions, right? So let's get started. So we did not discuss questions from relations and sets, so we'll be doing them here. We did not do them in the calculus, right? So here we are. Consider the following relations. So first relation is xy, pair is xy. Xy are real numbers such that x is wy for some rational number w. So if w is rational, I am told that w is rational, w can be represented x by y, where y should not be 0 and xy are real numbers. Now I need to, as per the options, I need to validate and verify. These all are previous year's questions, right? I need to verify whether R and S are equivalence relation or not. By the time I solve this, if you have done it before me, do write in the comment box which option do you feel is the correct. Otherwise, I'm also solving it. So here, I'll say the simple thing that if x upon y is given, it is of course reflexive because x upon x will be 1 and 1 is equal to w, which is a rational number, so it is reflexive. But is it symmetric? Symmetric here, pay attention to this part. Let's say 0, 1 is there. If I'm taking x as 0, y as 1, perfectly fine. So if it's symmetric x, y, then y, x should be there. So can I have 1, 0 as well? Can I have 1, 0 as well? If there is a pair 0, 1, then can I have a pair 1, 0 as well? I don't think so. Because for 1, 0, w is not defined. For 1, 0, w is not defined. I hope you're understanding. For 0, 1, it will be 0 upon 1. That is fine. But for 1, 0, it will be, w will be 1 by 0. That is not defined. But w was supposed to be a rational number, which is approaching infinity, which is not true. So it is clearly not symmetric. And if it is not symmetric, first of all, I know that R is not an equivalence relation. Did you all get that? Now let's talk about S. S is equivalence relation or not. Let's work on that. So m by n and p by q. What are we given? The pair contains m by n and p by q. M and p, q are integers, where of course n and q are not 0, and qm is equal to pm. Okay, there is a small correction. It is not qpm. qm is equal to pn. Sorry, I'm really sorry. It is n here. There is a small correction here. It should be n. I'm really sorry for this. There is a small slight correction here. It should be n. Now with that, if I wish to verify, first of all, I'll write like this only, where m by n and p by q, right? M by n comma p by q. So here I'll take this n away and q here. So I'll have m by n is equal to p by q. So first of all, let us begin with reflexive. Is it reflexive? So if I have m by n is equal to p by q, it is reflexive, which means what? If I have 1, 1, I think 1 by 1 is equal to 1 by 1. Are you understanding my language? So this is clearly reflexive. No doubt it is reflexive. Can it be symmetric? Sir, it is clearly symmetric because if m by n is equal to p by q, will you not say p by q will be equal to m by n? If there is a pair m by n comma p by q, there will be a pair p by q comma m by n, because m by n is equals to p by q, which means p by q will be equal to m by n. That means it is symmetrical as well. And if it is symmetrical, it is transitive. Why? Because let's say there is third number. Where should I write it? Let's say I write it here. Let's say you have m by n, then what? P by q, then let's say another number r by s. So if somebody says that m by n is equal to p by q, and if somebody says p by q is equals to r by s, then of course m by n will be equal to r by s. Are you all listening and understanding what I'm saying? All I'm saying is there is a pair m by n comma p by q. if there is a pair P by Q comma R by S, so there will be a pair M by N comma R by S. Are you understanding the language? So this is reflexive, symmetric, and transitive. Shall I give you better clarification, or have you understood this? So this relation S is clearly an equivalence relation, and based on that, S is equivalence, R is not, option C is needed to be marked. Everybody understood this? All the participants who are watching it right now? Everybody with me on this, or shall I give you better explanation? All are with me on this. Now, with this, let us try one more question and let's get more clarity on this one. Try and solve this particular one, students. Again, same set of questions, but this time you should be able to solve this. First relation, R to R, x comma y minus x is an integer. So first of all, will you not say that x minus x is 0? So it is clearly reflexive. If y minus x is an integer, then of course x minus y will also be an integer. This is symmetric. I hope undoubtedly it is. And the third result, if y minus x is there and if x minus z is there, then y minus z will also be an integer. Undoubtedly, because integer minus integer is integer. So if I am seeing y minus x to be there, I am seeing x minus z to be there, then I'll be seeing y minus z also be there to be an integer. This is an integer, right? Are you understanding this? Are you all understanding this? With that, can I not conclude, all the participants who are watching it right now, will I not say that, sir, this is clearly an equivalence relation because it is reflexive, symmetric, and transitive. So first of all, your statement 1, that is set A, is an equivalence relation. Everybody got this, or shall I re-explain this? All the students who are watching it right now, understanding it, can I move ahead from here? Now the next result, let's focus on that. Set B is given by x comma y, again R to R, where x is given by alpha y. If you could relate it with the same question which we did previously, first question, will you not say that this is same as that only? Because again, if I say x upon y is equals to x upon y x upon y is equals to alpha for some rational number alpha. So I need alpha to be a rational number. Now, if I want alpha to be a rational number, is an equivalence relation on R, it is said to be, then I'll say it could be reflexive, x upon x will be 1. But again, if x comma y is 1 comma 0, that is fine. But if y comma x if x comma y is 0 comma 1, that is great, that is fine. But if y comma x I think in that case I may have some trouble. It will not be symmetric anymore because it can have a pair 0 comma 1 for which alpha will be a rational number, but it cannot have 1 comma 0. So if x comma y 0 comma 1 is there, y comma x 1 comma 0 will not be there, and because of that we'll say that this is not a symmetric relation. Everybody understood that? And I need not check it for its transitivity. So which means this relation B was reflexive, but it is not symmetric, hence it is not equivalence. So statement 1 is an equivalence, statement 2 is an equivalence. So statement 2 is false, statement 1 is true. Option B needs to be marked. Everybody got that, or shall I re-explain this part? All the participants. Shall I move ahead from here? Everybody? Now, let's solve the next question from here, this one. It says there is a set X which contains 5 elements, 1, 2, 3, 4, 5. The number of different ordered pairs y comma z that can be formed such that y is a subset of x, z is a subset of x, and y intersection z is empty. How do I ensure this? All I'm trying to tell you is that there is the set X which has these 5 elements, 1, 2, 3, 4, 5. But it has 2 subsets y and z. So it has 2 subsets y and z. So it has 2 subsets y and z. But the challenge here is this, that y and x have nothing common in between them. That y and x have nothing common in between them. I repeat, y and x have nothing common in between them. First of all, are you understanding whatever I'm saying here? Or shall I re-explain this part? So this is your set y and this is your set z. Now, can you help me with this answer, students? What are we going to do here? I hope you're understanding. I have 5 choices, 5 elements. 1, 2, 3, 4, 5. I need to form ordered pair y comma z so that y and z should be from 1, 2, 3, 4, 5, but y and z should be 5. So if I approach this one and ask him how many choices do you have, so it will say I can belong to either y, or I can belong to either z, or I can belong to neither of them, which means I don't go in neither y. I go to neither y nor z, which means I stay out of it. I am still a part of x, but I'm not a part of y or z. Is my language understandable? So with each of these elements, I have 5 choices. With this one, I have 5 choices. With this 2, I have 5 choices. So which means 5 into 5, how many times? Sorry. With each of these elements, I have 3 choices. With second element also, I have 3 choices. So 3 into 3 into 3, how many times? 5 times. That is again clearly nothing but option A. That's good, Arpan. That's brilliant. I hope everybody is understanding and making sense out of it. All the participants, did you understand this part? Can I move ahead from here? Can we go ahead from here? Now let's solve the next question from here. Everybody with me on this? The product of all solutions of this equation, where x is said to be positive. Okay, let's try and solve this. All I'll suggest you to do is, first of all, for a while, if you ever get confused, take this log x as t. So this equation looks like e to the power 5 t square plus 3 is equal to x to the power 8. I hope you're comfortable with that. Everybody with me on this? Now if I take logarithm on both sides, where I'm considering that t is nothing but what? ln x. Everybody with me on this? Now if I'm taking logarithm on both sides, it is going to be 5t square plus 3. I repeat, it is 5t square plus 3, log I'm taking, is equal to 8 log x, 8 log x. Did you all get that part, or shall I repeat this part? It is 5t cube plus 3, it is 8 log x, the property I have used. Now, I hope again you would realize and see it clearly, ln x was taken as t, so it should be 5t square minus 8t plus 3 is equal to 0. Now some of you or a lot of you might be thinking that, sir, let us try and solve this quadratic and then find out the roots and then find the product of those solutions. Rather, what I am suggesting you to do is, can you not help me with the sum of the roots? Sir, why are you doing so? Have patience, you will realize how can you solve this question asked by JEE Mains in 10 seconds. Pay attention to this part. Of course, this quadratic is solvable. And when this quadratic can be solved, log can also be found. And of course, you're supposed to find the logarithm so that you can verify or validate the values exist or not. But for that to exist, what you need to verify here is, sir, I want to join your class and I have already studied 2-3 chapters from your Engage Mathematics class 11th. I appreciate with your teaching, but now I'm English medium student, what I do. Sir, Faraz, if you wish to join, we have already launched Arjuna, Laksh and Prayas. If you are in 11th, you can join Arjuna. If you are in 12th, you can join Laksh, and if you are a dropper, you can join Prayas. The links are given in the description. You can visit our website as well, where you can explore pw.live. There you can explore our courses, Laksh JEE in English, Arjuna JEE in English, and Prayas JEE in English. And there you can proceed with the enrollment. Now, if I get back to this, all I was suggesting is that can you help me with the sum of the roots? So if I ask you with this quadratic, the sum of the roots is going to be, let's say it has 2 roots, t1 and t2. Sum of the roots is going to be minus b upon a, that is 8 by 5. Now what is t1 plus t2? t1 plus t2, I hope you're understanding. If this equation originally has 2 roots, okay, in that case, brilliant, perfect. Then possibly I'll be teaching there. Here, if I get back to this, this has 2 roots, x1 and x2, t1 and t2, internally x1 and x2. So that I can write as ln x1 plus ln x2 is equal to what? 8 by 5. But we know log m plus log n is log mn. So that is ln x1, x2, that is 8 by 5. Now if I take NT log on both sides, I hope you know, x1, x2 will be e to the power 8 by 5. That's the product of all the solutions of this equation, which is e to the power 8 by 5, option D. Did you all realize, understand and see how easy this question was? Everybody got this? Can I move ahead from here, all the participants? Now let's solve this next one. The sum of all the real solutions of this equation. Sum of all the real solutions. So first of all, when I start solving, how do I begin with? I'll say log of, now base is given as x plus 3, that's fine. If I take 2 common from here, what am I now left with? I am left with 3x square plus 14x plus 15, correct me if I'm wrong. 2 I have taken common. And there on the right hand side, we are left with 5 minus 2 times log of. There also from 6x plus 10, if I take 2 common, or rather I'll keep it as 6x plus 10 only as of now. This x square plus 6x plus 9, if you could look at it, I hope you're realizing here, great, perfect, brilliant. So this should be a square plus b square plus 2ab, right students? So that is a plus b whole square. So this is clearly x plus 3 whole square. Give me a quick confirmation. Did you all get that, whatever I've done so far, all the participants? Now what I do next is log m to the power n, so that n can be brought here. But I need to take care of this thing in mind that x plus 3 is there in the base, x plus 3 is there here as well. So ultimately, whatever possible solutions or answers which I'm going to get finally, I should ensure that they don't violate that domain of this question, root gain, root loss. I hope you're understanding. So that I'll do later. In the end, I'll validate and verify. But right now I can bring this 2 to the front instead of introducing a mod and complicating it unnecessarily. So when this 2 is brought to the front, it becomes what? 2 into 2, 4. So I'll remove this 2 from here and make it 4. I hope you're comfortable with that. So this is 5 minus 4 times log of this. Everybody understanding this comfortably? Now let's try and factorize this. 3x square plus 14x plus 15. Can I do it separately? 3x square plus 14x plus 15. I hope this is 3x square plus 14x plus 15. So 15 into 3 is 45. 15 into 3 is 45. I hope I have taken it properly because 3x square plus 14x plus 15, right? So this is 45. 45 is what? 9 and 5 will do the job. So with this I'll have 3x square plus 9x plus 5x plus 15. Everybody getting it? So when I take 3x common from here, what I am left with? X plus 3. Are you understanding it? And what did I take common? I took 3x. If I want x plus 3 here, I'll take 5 common from here. So that when factorized looks like x plus 3 and 3x plus 5. So I'll write it as x plus 3 and 3x plus 5. So this I'm writing as x plus 3 and what? 3x plus 5. Correct me if I'm wrong. X plus 3 and 3x plus 5. Everybody with me on this? So far, whatever I've done, all the participants, no confusion on that. Now, what I do next is a very simple task which I perform is this, that here, I think I can do log m. How long will this session continue? Ramraj, I think we have done theory. Now we are left with questions. Few decent questions I have kept, not a very lengthy, heavy questions, just to make you revise the algebra and trigo part. So I think another 2 hours possibly, and then we'll be concluding it, possibly the next 2 hours, right? Now, if I get back to the discussion we were having here, this entire values logarithm we are taking, right? This 2 is also there, that 2 was taken common. So if I proceed with that, log m plus log n plus log o, but what will I do with this log 2 base x plus 3? Oh, that I'll do or deal with later, 6x plus 10. Yes, that I'll do here. So this 2, if I push with this 3x plus 5, this 2, if I multiply with this 3x plus 5, does it not become 6x plus 10? So I'll keep it written like this, 6x plus 10. I hope everybody is understanding this comfortably. No confusion on that, all the participants. Now, pay attention to this. Log mn is log m plus log n. So that part, if I introduce, it will be log x plus 3 at base log x plus 3, that is 1. It will be log of 6x plus 10 at base x plus 3. And there on the right hand side, it is 5 minus 4 log of x plus 3 at base 6x plus 10. Now to avoid confusion or writing this much, I'm making a substitution. What is that? Can I take this as t? So I'm taking t as log of 6x plus 10 at base x plus 3. I hope you're comfortable with that. And I hope you wouldn't hesitate in saying that we know that log of b base a is 1 upon log a base b. So if I use that property here, this is 1 by t. Because if it is log 6x plus 10 at base x plus 3, this is log x plus 3 at base x plus 10. So if this is considered to be t, it will be 1 by t. Do you all agree with this? So here, 5 minus 1 is going to be 4. So this will be, if I take that one there, so this is t, this is t. 5 minus 1 is 4, 4 minus 4 by t. This is 4 minus 4 by t. Give me a quick update on this. Did you all get that, or shall I repeat this? 1 goes there, it becomes 4. This is taken as t, and this is minus 4 by t. Are you all there with me? Now, when I move ahead or proceed further from here, what I do is, I multiply both the sides by t. So when I multiply both the sides by t, it becomes t square. Then it becomes 4t. It is brought here on the left hand side. It is left as minus 4. Minus 4 is brought here. It becomes plus 4 is equal to 0. Correct me if I'm wrong. Am I doing it correctly, students? I hope there is no calculation error so far. T square minus 4t plus 4, right? This clearly looks like a perfect square. A square plus b square minus 2ab. Can you all see that? A square plus b square minus 2ab, that is a minus b whole square. That is a minus b whole square. So if it is a minus b whole square, that is t minus 2 whole square. T minus 2 whole square means what? T is 2. First of all, pay attention to this. T is 2, but that's not the solution. We are not asked t, we are asked this, but this value is found to be 2. What is found to be 2? We have found log of 6x plus 10, log of 6x plus 10 at base x plus 3, and this value is found to be 2. Give me a quick confirmation on this. Everybody with me on this? Now, if I take anti-log, we can clearly see that 6x plus 10 will be equal to x plus 3 whole square. So x plus 3 whole square is x square plus what? 6x plus 9. I hope no confusion on that. Is equal to what? 6x plus 10. So there, if I see x square is going to be 9 subtracted from 10, that is 1. So x we receive as plus minus 1. X I receive as plus minus 1. But there I need to be more careful. Can I take both the values of x, plus 1 and minus 1? There we need to verify and validate it. Because with plus 1, do I see it getting satisfied? Is it there in its domain? And what do we see with minus 1? I think plus 1 is perfectly acceptable because it will not create any problem at all. Do I see any problem with minus 1? Well, let's verify and validate it. With minus 1, this is 3 minus 1, that is 2, perfectly fine. With minus 1, this is 10 minus 6, base 4, perfectly fine. With minus 1, this is 1 minus 6 plus 9, that is still positive, perfectly fine. With minus 1, this is minus 28 plus 30, that is positive, so this is also fine. So I think minus 1 and plus 1 both are acceptable values. I repeat, when I replace x by minus 1, there is no problem with its base, neither with the value. So I think minus 1 and 1 both are acceptable solutions. So sum of all the real solutions, 2 solutions, but they did not ask you the number of solutions. The trick or the catch here is sum of all the solutions. So sum of 1 and minus 1, sum of course you need to verify and validate it first. Let's say you say that solutions are 1 and minus 1, the answer will be 0. Sum of 1 and minus 1. But again, you need to verify and validate whether 1 and minus 1 both satisfy it or not. Since they are satisfying, their sum will be 0, and hence I'll say option C needs to be marked. Everybody understood that? All the participants who are watching it right now, have you all gotten this? Can I move ahead from here? Everybody? Now from here, when we solve the next question, what do we see next? This one. Pay attention to this. This equation has what kind of solutions? So again, I'll follow the simple strategy. I'll say that e to the power sin x for a while, I'll take as t. So this equation becomes what? T minus 1 by t minus 4 is equal to 0. Everybody listening and understanding this? If I multiply both the sides by t, I'll have t square minus 4t minus 1 is equal to 0. Give me a quick confirmation. Did you all get that? Are you all there? Now I don't think that the splitting the middle term will work here. So I'll use the Sridharacharya formula. So with that, I'll have t as minus b plus minus under root over b square minus 4ac. So b square is what? 16 minus 4ac, that is minus 1, that is plus 4 by 2a, that is 2. Correct me if I'm wrong. minus b plus minus b square minus 4ac upon 2a. Great, that's good, Arpan. So with that, what I'll say here is that here 16 plus 4 is what? 20. 20 is 4 into 5, right? 20 is 4 into 5. So 4 into 5 when square root is taken, that is 2 root 5. So if 2, 2, 2 are cancelled, what do I get? I hope you can see it clearly. I'll get 2 plus minus root 5. Now I'll tell you the challenge. I'll make you see the challenge. T is we received as 2 plus minus root 5, but what was T? T was e to the power sin x. T was e to the power sin x, and that we receive as 2 plus minus root 5. Let us forget this plus 5. Let us talk about minus root 5. E to the power sin x 2 minus root 5. We know minus root 5. Root 5 is 2.25 something. So 2 minus 2.2 is negative. And I am now told that e to the power sin x is negative. No matter whatever sin x is of course from minus 1 to 1. And if I raise it to the power of e, then e raised to the power anything is always positive. We know about the graph of e to the power something, it always goes like this. If it's taking values from minus 1 to 1 also, then also it is positive. So e to the power anything is never negative. So this solution is discarded. Are you all listening and understanding? So let's talk about this solution. Is this solution a possibility? Now can you verify and validate, is it a possibility? Now there are multiple ways. You can have your own approach. One of the ways is I take logarithm on both sides. So when you take log, it is sin x. I hope you're understanding. And this is log e, which is 1, log of 2 plus root 5 at base e. Now pay attention to this part. What is 2 plus root 5? So 2 plus root 5 is approximately, root 5 is 2.2. 2.2 plus 2 is approximately 4.2. And e is approximately 2.7. Now we can clearly see that log of 2 plus root 5 at base e will be greater than 1. I repeat, log of 2 plus root 5 at base e will be greater than 1 because log e base e is 1. So if I keep increasing these values, the value will also increase. I hope you are understanding it. So this value on the right hand side is greater than 1. But what I know is that sin x always lies between minus 1 and 1. So can it be greater than 1? We don't think so. And if we don't think or believe so, in that case, the solution is discarded. That means even this solution is not an acceptable solution. So both of these solutions which we have found are wrong, which means they are not acceptable solutions. They don't fall into the range of the solution it can have, which means it has no real roots. How many of you got this? Good, brilliant, that's perfect. Everybody understanding this? Can I move ahead from here, all the participants? Now, when we solve the next question, let me have some water. You try and solve this, then we'll discuss it together. Give me a moment, I'll have some water. Now here in this question, how many of you could crack the question or the logic? Anyone who is willing to answer this question? In the comment box, I'm waiting. Are you sure 3 is 2 is to 1, Arpan? Okay, let's try and discuss this together. Pay attention everyone. A very basic idea I'm trying to apply here. If the equation this and this, where ABC are real, have a common root. Okay, perfectly fine. So this equation, if I talk about this equation, what can be its roots? So sir, its root, if I talk about its discriminant first, so b square is what? 4 minus 4ac, so 4 into 3 is 12, and that is found to be negative. So the roots of this quadratic will be imaginary or complex. So they'll exist in pair, which means if one of the roots is alpha plus iota beta, or let's say one of the roots is p plus iota q, the other root will be p minus iota q. Everybody listening and understanding this? Everybody listening and understanding this? If one of the roots is p plus iota q, the other root will be p minus iota q. Now, here, if one of the roots is common with this quadratic, we know that if p plus iota q is a root of this quadratic, then the quadratic roots, the complex roots exist in pair. So this quadratic will also have the same roots, p plus iota q and p minus iota q. So if this had roots as p plus iota q and p minus iota q, this will also have the same roots p plus iota q and p minus iota q, which means they are the same quadratics. And if they are the same quadratics, that is possible only when they are proportional, which means A is to B is to C should be 1 is to 2 is to 3. Because if they are saying one root is common, but we can see that they have the both roots common. And if they have both roots common, we know the condition for both roots common, A1, A2, B1, B2 and C1, C2 are proportional. So A is to B is to C is 1 is to 2 is to 3. Everybody got that? And on the basis of that, I think option A was supposed to be marked. Everybody got that? Can I move ahead from here? All the participants. Now here, let alpha and beta be the roots of this equation. P, Q, R in AP. 1 by alpha and 1 by beta is given as 4. Then they are asking you the value of mod of alpha minus beta. How do we solve this one? I'll simply say that here, first of all, what are we told? This equation has two roots, alpha and beta. So what can I say about alpha plus beta? I'll always say that alpha plus beta is minus q by p. Everybody listening and understanding. What can you say about alpha beta, the product of the roots, that is r by p? Everybody listening and understanding this? I hope there is no confusion on that. Now, we are told PQR in AP. So if somebody says PQR in AP, I'll say 2Q is equal to P plus R. I repeat, when somebody says PQR in AP, I'll say 2Q is equals to P plus R. And one more thing we are given, that 1 upon alpha plus 1 upon beta is 4. From here, can I not say that alpha plus beta by alpha beta should be 4? I hope you all are there. And from here, if I take this alpha beta there, it will become 4 alpha beta. Are you all there? Now with that, if I substitute few values, alpha plus beta was minus q by p. So it is minus q by p. 4 times alpha beta, that is r by p. And we know p cannot be 0, so I can clearly get rid of it. So minus q we have cracked as 4r. Great, that's good, Arpan. So minus q we have cracked as 4r. This value of minus q, which we have cracked as minus 4r, this q, which is minus 4r, if I replace here, I'll get minus 8r. Q I'm replacing by minus 4r, so this becomes minus 8r is equal to p plus r. So there, p becomes minus 9r. So this result I have received and this result I have received. Now with these two results, if I now start working on what I am asked the value of mod of alpha minus beta. Now to define mod of alpha minus beta, what I do here is, let us define alpha minus beta whole square first. I hope you remember it. Alpha minus beta whole square is given by alpha plus beta whole square minus 4 alpha beta. Correct me if I'm wrong. Why? Because it will be alpha square plus beta square plus 2 alpha beta. Minus 4 alpha beta is minus 2 alpha beta. That is nothing but alpha minus beta whole square. Did you all get that? So this is what I'm trying to figure out, which will be alpha plus beta whole square. Alpha plus beta whole square is what? Minus q by p. As of now, two things I'm interested in. Which two things? Let me write them first. Alpha plus beta, that is minus q by p. Its square will be q square by p square. So can I write it as q by p whole square? Are you understanding this? Minus 4 alpha beta. Now what is alpha beta? Alpha beta we have just cracked as what? Hold on for a while, students. Just give me a second, everyone. Alpha beta we have just cracked as what? R by p. So this is minus 4 R by p, right? Now, can you help me with q by p and r by p? I think you can, because r by p from here can be found as r by p from here can be found as minus 1 by 9. Correct me if I'm wrong. R by p will be minus 9 by. But can I have q by p as well? So if I divide this by this, I think minus q by p I'll have on the left hand side. Are you all listening? Minus q by p, and on the right hand side it will be 4r by minus 9r. So minus 4 by 9, because r will get cancelled by r. So this positive and this positive is there. So q by p we receive as 4 by 9 and r by p we receive as minus 1 by 9. Everybody listening, watching and understanding this with utmost clarity. Can I move ahead from here, all the participants? So q by p, now if I substitute here, how much is that? 4 by 9. So can I write that here? I'll write it here. Hope it's okay. So q by p is 4 by 9. 4 by 9 square is? 4 by 9 square is what? 16 by 81. Comfortable with that? Minus what? 4r by p. r by p is minus 1 by 9. So minus minus plus. So that is 4 by 9. That is what? Plus 4 by 9. Everybody understanding this comfortably? But remember, this is not mod alpha minus beta. This is alpha minus beta whole square. Now from here, if I multiply it by 9, so 9 into 4 is 36. So it should be 36 by 81. Now 36 plus 16, how much is that? In the denominator is 81. 36 plus 6 is, I think, 42. 42 plus 10 is 52. Correct me if I'm wrong. Right, 36 plus 10 is 46. 46 plus 6 is 52. That is alpha minus beta. So mod of alpha minus beta will be square root of it, because mod is there. Plus minus need not be put. So 52 is what? 13 into 4. 13 into 4 means what? 2 root 13 divided by 99 should be mod of alpha minus beta. So 2 root 13 divided by 9, option B should be your answer. How many of you got this? That's good, Arpan. I think, yes. Everybody got this, or shall I re-explain this part? All the participants. I hope it was easy, understandable, and you all must have understood it. How many of you cracked the logic? How many of you could do it? How many of you could think that this is needed to be done? Now, very basic example where they are merging sequence and series with quadratic or theory of equations. Let's focus on the next question for the day. Here, focus on this one. Can you crack this question? Give it a try. I'm giving you 10 seconds time and then we'll discuss it together. By the time I finish my tea, you try and solve this one, all the participants. Anybody who is willing to answer this question, anyone who has cracked it? Our YouTube team is so creative, as I can see in the title. They have written Algebra and Trigonometry in gunshot, and they have created a gun as well. Good. Complete maths in just 3 days. Great. Okay, so now if we get back to this question, again an easy one, straightforward one, but how do we crack it? Let's work on that. Sum of first n terms of this series is given by this, but this is when n is even. This is when n is even. So what will be the sum of first n terms when n is odd? Now look at the logic. If you could crack the logic, the question is done. What do I mean by that? Pay attention to this. If you pay attention to this series, I hope you can see, you need not work on this series, nor you need not to find out its sum. That is already we are given. But let's say when n is even, this is sum. So let's say instead of n, I'll say n minus 1 is even. I'll say, because when I wish to say that when n is odd, n minus 1 will be even. I'll say n minus 1 will be even. So when n was even, the sum was this. So when n minus 1 is even, the sum will be this only, but just this n replaced by n minus 1. Give me a quick update on this. Are you able to crack this? So all I'm saying is that this n I'm replacing by n minus 1. So n minus 1 plus 1 is n. So that's square divided by 2. What is it? This is the sum of its n minus 1 terms, where n minus 1 is even. Everybody understanding this? Now, pay attention to this part. The next part is, look at the sequence. First term was 1 square, second term was 2 square into 2, third term was 3 square, fourth term was 4 square into 2. So 1 square, 2 square, 3 square, 4 square, 5 square is there. But with even terms, there is this 2. But with even terms, there is this 2. So to these n minus 1 terms, the n minus 1 terms, if I add the nth term, see n minus 1 is even, which means n will be odd. I hope you're understanding it. Yes, Venkat, that's brilliant. I'll also verify it with my approach. I hope you're okay with that. So with this, I hope you're okay that when n is odd, I hope you're understanding. Please understand. For the first term, first term was 1 square. The third term was 3 square. The fifth term was 5 square. For odd ones, I'm asking. So for the nth term, when it is odd, nth odd term is given by n square. So these are n minus 1 terms, where n minus 1 is even. If I add nth term to it, which is the odd term, I'll get the sum of n terms, where n is odd. So I'll say sum of n terms, where n is odd, will be given by sum of n minus 1 terms, where n minus 1 is even, which is n minus 1 into n square by 2 plus that next term, which is n square. I hope you all are getting it. So with this, what I do is, I think n square can be taken common. So when you take n square common, you're left with what? N minus 1 by 2 plus 1. And with that, this n square stays outside. You're left with what? N minus 1 plus 2. That is n plus 1 by 2. This is n plus 1 by 2. So n square times n plus 1 by 2. Option D is incorrect. Option C is also incorrect. Option A and B are same. I think there is a small correction here, students. Let me make that. Option B should be, let me just do that correction. I'm really sorry for this. Option B should be this, where it should be n square times n plus 1 by 2. I hope you're getting it. And with that, option B will be the correct option. Yes, none of these, Venkat, but now it will be option B. Everybody got this? Shall I explain this again? All the participants. Did you all get that? Can I move ahead from here? Did you all understand the logic? More importantly, how did we crack it? All these students. Now from here, great. N should be, I did not understand, Sushidharan. Can you reiterate what you are asking? From here, the next question says that let TR be the rth term of an AP, whose first term is A. Okay, that's fine. Hold on for a while, students. What are we told here? I am given that TR be the rth term of an AP whose first term is A. Okay, and common difference is the usual convention. N should be subtracted. No. I mean, I'm not getting Arpan and Shushidharan. What are you saying? Why are we subtracting N? No. Please understand. You did not read the question. The question was simple. This is the sum of n terms when n is even. But I need sum of n terms when n is odd. So of course, this cannot be the answer, because this would be the answer when n is even. Sir, why should we add n square when we take n minus 1? Because, Sushidharan, n minus 1, when I replaced here, see, whatever is n, whenever n is even, this is the sum of those n terms when n is even. So I am looking for n minus 1 terms, because with that n minus 1 plus 1, the next term, nth term, I'll get the n odd terms sum, because when n is odd. So when I substituted this n by n minus 1, when I replaced this n by n minus 1, I got the sum of n minus 1 terms only, where n minus 1 was even. So after these n minus 1 even terms, the next term, the nth term, would be the nth term would be the odd term. Are you understanding it? So to these sum of n minus 1 terms, where n minus 1 is even, the next term, the nth term is added, which is the odd term, which will be n square as per the pattern we have seen, because if the first term is 1 square, third term is 3 square, I hope you're understanding, fifth term is 5 square. So the nth term, as per the n is odd, nth term will be n square. Are you understanding it? So with that, to the sum of n minus 1 terms, if I add the nth term, I'll get the sum of n terms, where n is odd. Because n minus 1 is even. So if n is odd, n minus 1 will be even. So I hope you're understanding. That's why we are adding n square. Shall I re-explain this part? Or did you get that? Now from here, when I move ahead, what do we see next? This particular question. Can we solve this? Let TR be the rth term of an AP whose first term is A, common difference is D, if for some positive integers Mn, m not equal to n, Tm is 1 by n, Tn is 1 by m, then A minus D equals. Okay, let's try and solve this one. Everybody watching and understanding. So first of all, Tm. How do I define Tm? Tm for us will be given by A plus m minus 1 into what? D. But this is given as 1 by n. What is Tn? So Tn for us will be given by A plus n minus 1 into D. That we are given as 1 by m. First of all, remember this as a direct fact. Yes, that's good, Venkat. Whenever you're given mth term as 1 by n and nth term as 1 by m, few direct results you should remember. This is a generalized statement which I'm making you remember through a question. We'll talk about a lot of results through this question. What are going to be those results? Pay attention to that part. Here, if from what I need is A minus D. Yes. Now, what I'm trying to tell you is that let us try and work out A and D. Few results I want you to have. So first of all, when I subtract this equation from this, so I'll have A minus A, that's cancelled. MD minus ND, because minus D and minus D are cancelled. So MD minus ND means what? M minus N D. And on the right hand side, it will be 1 by N minus 1 by M. So that is M minus M by Mn. That is what? M minus N by Mn. With that, this m minus n and m minus n are cancelled, and you can see d to be 1 by mn. I repeat, m minus n are cancelled, and we receive d to be 1 by mn. Everybody got that? So first thing, when mth term is 1 by n and nth term is 1 by m for an AP, then do remember the common difference is 1 by mn. Do remember it as a result. Let's say in a question somebody says there is an AP, the fifth term is 1 by 13, and 13th term is 1 by 5, then the common difference will be 1 by 13 into 5. Did you listen to that part? Not just that, few more things you should remember related to this statement, because this is what they ask you in questions. Let us try and find out the first term as well. Yes, that's a very good observation, Venkat. If I try and figure out D, so I'll replace m by n here. So it will be A plus m minus 1 by mn is equal to 1 by n. So m by mn will be 1 by n, that 1 by n is cancelled, that will be left with minus 1 by n, and that minus 1 by n, when I bring on the right hand side, it gives me 1 by mn again. So that is again one other result, that its common difference and first term will be same. Everybody got this? Will you remember this as a result now? Let's say instead of this, there is a question. Question says this, that there is an AP where the fifth term is 1 by 13 and the 13th term is 1 by 5. Then what will be its first term? 1 upon 5 into 13. What will be its common difference? 1 upon 5 into 13. 1 by 65. And what am I asked? A minus D. Since A and D both are identical, will you not say A minus D will be 0, which means option D. How many of you cracked it? How many of you have understood this? Everybody with me on this? Did you all get this? Can we move ahead from here, all the participants? Are you all there, listening, watching, and understanding? Let us move ahead with the next question. Try and solve this by yourself, and then we'll discuss its solution together. Give it a try, participants. Everybody who's watching it right now, I'm giving you a minute's time. You try it by yourself, and then we shall discuss the solution together, all the participants. 1 by 2 factorial, 1 by 4 factorial, 1 by 6 factorial, and so on. Forget this question. Can we work on e to the power x? Can you help me with the expansion of e to the power x? We all know it is given by 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, and so on until infinity. I hope you do remember that. So if I ask you few things, if I ask you e to the power 1, where I'm replacing x by 1, it will be 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. So I think I'm getting something, but this is not exactly what I'm getting. So let's do one more thing. I'm replacing x by minus 1. So when I'm replacing x by minus 1, e to the power minus 1, what do I get here? 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on until infinity. Now what I do next is a very important, a very straightforward conclusion where I am adding both of these. I hope you are seeing why. So when I add both of these, e plus e to the power minus 1 is what I get, is equal to double of what? See, this 1 and 1 becomes 2. This and this are cancelled. This 1 by 2 factorial, 1 by 2 factorial, all of them are doubled. So that 2 I have taken common outside. I hope you're okay with that. So there it will be 1. So all these odd terms will get cancelled. Even terms will be doubled. So double I have taken outside and I'll write all the even terms. So 1, this one I have written. Then what I have? I have 1 by 2 factorial, then 1 by 4 factorial and so on until infinity. I hope everybody has gotten this. I think we have gotten closer to somewhere. Now I need to simplify this expression to get the final answer. So this expression, which expression, students? The expression which we are looking forward to have, let's call this expression as E. So this expression E will be given by E plus e to the power minus 1, E plus e to the power minus 1 whole divided by 2, whole divided by 2 minus 1, or rather can I directly take 2, that is minus 2 here. I hope that is also fine. So I could have taken directly minus 2 here. I repeat, all I'm saying is pay attention to this part. Pay attention to this part. This to this should be equal to e plus e to the power minus 1 minus 2. But that whole again needs to be divided by 2 because this 2, if pushed here, then this should be pushed here as well. So I think that previous version was better. So I'll write it as e, the expression as e plus e to the power minus 1 divided by 2 minus 1. Everybody getting this? E plus e to the power minus 1 by 2 minus 1. Are you all there without any confusion? Now with this, when you simplify this, it becomes e plus 1 by e minus 2 divided by 2. If you wish to multiply it by e, that is you take the LCM, or if you can see it very clearly, if you don't see it, I can make you see this by multiplying it by e, that is taking the LCM. So it gives me e square plus 1 minus 2e divided by 2e. I hope you are understanding it. Or in a simpler language, I'm multiplying numerator and denominator by e. So this is what you get. This is a square plus b square minus 2ab. So in the numerator, it is a minus b whole square. In the denominator, it is 2e. So e minus 1 whole square upon 2e. E minus 1 whole square upon 2e is what we are given in option B. Everybody got that? Shall I move ahead with the next question? All the participants listening, watching and understanding. How many of you cracked it? Do tell me. Next question. X is positive, then the first negative term in the expansion of 1 plus x to the power 27 by 5 will be the first negative term. How do you crack it? Sir, whenever we have a fractional index, the index is rational, it is not an integer, then how do we solve this? First of all, its rth term is r plus 1th term. If I could write, it is given by n minus 1, n minus 2 and so on until n minus r plus 1 divided by r factorial times x to the power n. I hope you remember it. Sorry, x to the power r here. I repeat, this is how you write its rth term. So let's say if I write first term, r will be 1. I hope you're understanding. Second term, r will be 2 and so on. Sorry, if I write its first term, r will be 0. For second term, r will be 1. For third term, r will be 2 and so on. What I need is that, sir, its first negative term. Its first negative term. So technically, this and this won't be negative because x is positive. So if x is positive, this is always positive. Even r factorial is always positive. So the first negative term which I'll be getting would be Because of this only. Right. So let's start delving now. N we know is 27 by 5. So N we know is 27 by 5. So 27 by 5 minus 1. See, the first term with this I'll have N which is 27 by 5. 27 by 5 minus 1 wouldn't give me a negative value because positive, because 27 minus 5 is still positive. Even with this 27 by 5 minus 2, 5 into 2 is 10, 27 minus 10 is positive. Even 27 by 5 minus 3, 5 into 3 is 15, 5 into 4 is 20, 5 into 5 is 25. So I think until 27 by 5 minus 5, I'm still not getting any negative value. But the moment you introduce 6, which term is it going to be? That I'll reveal later, but I am now going to write this. I hope you're understanding it very clearly. Now pay attention to this: n minus 1, n minus 2, n minus 3 until n minus 5, n minus 6. I hope you're understanding. This denominator will be positive, that x to the power r will be positive. The only thing will be, because of this I'll be getting a negative term. Because all of them are positive, when this becomes negative, this whole expression becomes negative. Now what I'm saying here is that where do you find r? I think we have gotten the r because general term is given by n minus r plus 1, the last factor. So I can write this n minus r plus 1 as n minus r minus 1. This is basically n minus r minus 1 first of all. Pay attention to this, n minus r plus 1. So this 6 is nothing but r minus 1. If 6 is r minus 1, so there r should be 7. And if r is 7, I wouldn't hesitate in saying that this is the 8th term, option D. Did you all get this? Did you all understand this? Venkat, there was a catch. It should not be 6, it should be 8. How 8? I have made you see this. If you have gotten confused, I'll again try and make you understand. R wasn't 6, R was 7 first of all. So this would be 7 factorial and this will be x to the power r, that is x to the power what? R was 7, so it is x to the power 7. But here you need to understand n minus 1, n minus 2, n minus 3 until n minus r minus 1, n minus whole of r minus 1. That's what you do. With this rational power, expansion goes like this. Everybody got this, or shall I re-explain this part? All the participants. Somebody is surprised. Who is that? Who is giving these surprised smileys? Everybody with me on this? So the answer will be 8th term, option D. Are you all getting it? Or shall I re-explain this part? All the participants. Give me a quick update on this. Can I move ahead from here? Let's solve the next question. This is what we tried understanding. I give you a formula. There are short techniques available on the internet. You can follow whichever, whatever feels you like. But here, I'll say a simpler approach would be that if you think logically, you can crack it within seconds. What is that straightforward approach? I need to figure out the number of integral terms. Now here, first of all, can you help me in writing its rth term here? If you could help me in writing its rth term, we'll be in a better position to crack the number of rational, irrational, integral, whatever kind of terms they are asking. Good, Shashidharan. Now here, if I write its r plus 1th term, it will be given by NCR, that is 256 CR. This root 3 to the power 256 minus r, and this 8th root of 5 to the power r. Everybody got this? Now I could have directly written it as the r plus 1th term as 256 CR. This root 3 means what? 3 to the power 1 by 2, that is 256 minus r whole divided by 2, and this 5 to the power r by 8. Everybody understanding this? Now if I want terms to be integrals, which means these powers should be not rational. Rational means something as 1 by 3, 2 by 3 kind of format, 1 by 8 or 7 by 8 kind of format. These irrational terms should get removed. And how do I get them removed? Whenever I see r to be a multiple of 8, this will become a rational term. It will become an integer. Similarly here as well, I want r to be even, because even minus even will be even and even will be divisible by 2. So when I said r is a multiple of 8, r was already even. So I need not bother about this. Are you listening and understanding my words? All I'm saying is that whenever R is even, that automatically ensures that this part is already resolved. So I'll ensure that R should be divisible by 8. R should be divisible by 8 because whenever R is divisible by 8, R will eventually become even. So this will also get resolved. So I'll not bother about it. So I'm ensuring that R is divisible by 8. What possible values are I'll take? Sir, R will begin with 0, 1, 2, 3 till 256. So first of all, if I divide 256 by 8 to calculate the number of R's I will have, I'll say this is clearly going to be 3 and then 1, that is 2. But if you think 32 is the answer, then you're again wrong. Can you tell me why is 32 incorrect answer? I just told you a hint. 32 means you are beginning with the value of R as 8, then 16, then 24 and so on. But you are missing one value of R which is 0. Because R being 0 is also an acceptable 256 by 2, perfectly divisible, 0 by 8, perfectly divisible. So one value of R 0 is needed to be considered. So answer will not be 32, answer will be 32 plus 1, that is 33. How many of you got this? How many of you have understood this? All the participants, everybody with me on this. That's good, Venkat. Brilliant, everyone. From here, let's try and solve the next question. Can you help me with this? Give it a try, students. Then we'll be solving this question together. Everybody give it a try. Then we'll discuss its solution together. All the participants who are watching and listening and understanding it right now. Everybody, just give me a quick response. What do you think could be the correct answer to the question which you are seeing right now on the screen there right in front of you? Okay, so pay attention to this part. I'll first of all say that let's define this Tn, right? This Tn for us is given by summation R is from 0 to n. There we have R, where we have R NCR. Now all I'm asking you to do is, we did discuss when we were revising the theory of PNC that NCR is NCn minus R. So first of all, if I make any change here, that if I replace NCR by NCn minus R, am I making a mistake? Yes. In that case, this R is creating some problem. This R should also be in n minus R. But sir, in that case, you have changed the entire expression. It wasn't n minus R by NCn minus R. It was R by NCR. But trust me, is it and this are not still same? Because when you replace n by n minus R, it is still same, only the order has reversed. And summation, if you do from beginning to end or from end to beginning, it is always same. If you didn't get my point, all I'm suggesting is you try and expand this. When you put R as 0 or when you let's say put R as 1, it will be 1 by NC1. Then R when you put as 2, it is 2 by NC2 and so on. And here also when you begin with R as 1, n minus 1, NC n minus 1 and the same value. So it is starting from ending and it is starting from beginning. So both are first of all same. So in this Tn, if I substitute R by n minus R, this still remains same. Everybody give me a quick confirmation. Did you understand that part? Can I move ahead from here? Now when you do that, I think one thing which we can do now is that with n minus R, I can split this summation. So I can write this Tn as summation of n upon nc n minus R and minus summation of R upon nc n minus R. Give me a quick confirmation on that. This is the Tn, where of course I need not write this. R is ranging from 0 to n. That part I'm not writing time and again. Everybody comfortably understanding this without any confusion or hesitation. Now, one thing I'll be using that in PNC we did discuss that NCR is NC n minus R. That change I'll use here. So with that NC n minus R, I can write as NCR. Here as well, NC n minus R, I can substitute by NCR. Are you all listening and understanding whatever I'm doing here? So with that, this is our Tn. This is our Tn, where R is starting from 0 to n. R is starting from 0 to n. Give me a quick update on this. Are you all there? Listening, watching and understanding all what I'm doing. I hope it isn't getting confusing. Now from here, when I move further, This is your Tn on the left hand side. On the right hand side, there the variable is r. So n becomes constant, stays outside. So this n comes outside. Summation where r is ranging from 0 to n. This is 1 by n cr. Everybody getting it? Minus, this is summation, r is ranging from 0 to n. This is r by ncr, r by ncr. But here I want you all to pay attention to this result, that here, are we not given, that summation of 1 upon ncr, summation of 1 upon ncr where r is from 0 to n is Sn. So can I not directly substitute this entire expression by Sn? So this is n into Sn. Are you all listening to this? Minus summation of r upon ncr. Summation of r upon ncr is nothing but Tn. So can I not substitute this entire by Tn? So this whole thing is nothing but what? Tn. So this here is your Tn. First of all, give me a quick update on whatever I've done so far. Is it understandable? Everybody got that? Now from here, if this Tn is pushed here, this becomes 2 times Tn is equal to n Sn. This is 2 times Tn is equal to n Sn. Now what are we asked? We were asked Tn upon Sn. So here Tn upon Sn will be n by 2. Tn upon Sn will be n by 2. And based on that, I think option D. That's good, Venkat. What about the other participants? Did you all understand this? Good, Sushidharan. Everybody with me on this? Everybody understood the logic? Interesting it was. Good question it was. Some arrangement was needed to be done. If you were able to think of the right arrangement, you could crack it within seconds. All the participants, are you all there? Great, perfect, brilliant. Now with this, when I move ahead, something easy, something really simple, just to make you understand the binomial expansion here. 1 plus x when multiplied to this. When I talk about this expansion, its general term will be given by what? Its general term, not 1 plus x. The general term of 1 minus x to the power n, it will be given by ncr, and of course minus x to the power r. Can I write that as minus 1 to the power r into x to the power r like this? Right. Now what are we asked? We were asked the coefficient of x to the power n. So when 1 multiplies to this, so I need the coefficient of x to the power n from here. But when x multiplies to this, I need coefficient of x to the power n minus 1, because x to the power n minus 1 into x will be x to the power n. So I am looking for two things, x to the power n and x to the power n minus 1. Coefficient of x to the power n and coefficient of x to the power n minus 1 will be added, and that will be my coefficient. First of all, did you understand that, everybody? So here, x to the power n will be ncr minus 1 to the power n x to the power n plus coefficient of x to the power n minus 1, that will be nc n minus 1. First of all, give me an update on this nc n minus 1. I'm really sorry, this is not ncr, this should be nc n because it is x to the power n. This is nc n minus 1 minus 1 to the power n minus 1 x to the power n minus 1. Yes, brilliant. Now from here, all I'll suggest you to do is, can I say minus 1 to the power n minus 1 can be written as minus 1 to the power n into minus 1. Did you get this? Because minus 1 to the power n upon minus 1, so that minus 1 can be brought here as well. And that minus, if I remove from here, can be introduced here. I hope you are comfortably understanding it. No confusion on that. So minus 1 to the power n, minus 1 to the power n, I'm taking common. So minus 1 to the power n stays outside, and then what am I left with? Ncn minus Ncn minus 1. Can you help me with Ncn? Ncn is Nc0, which is 1. I hope you're understanding it. So it should be 1 minus Ncn minus 1, that is n. How? It is Ncn minus 1, which I can write as Ncn minus n plus 1. That is Nc1, and Nc1 is n. So this should be minus 1 to the power n, 1 minus n. Option B is needed to be marked. Okay, so somebody is saying it's Eid tomorrow. So I think they have seen the Chand. So I don't know when is it, how is it, or on the basis of what it is celebrated. But congratulations. I think we wish you all a very happy Eid. If it is Eid tomorrow, and if he is giving me the right data, with that, congratulations, or whatever wishes you are supposed to take based on that. I wish you all the very best. But right now, let's focus on the questions. Why are these comments getting scrolled? I hope we can continue further. Here, now, when I go ahead further, what do we see next? The next question. Everybody understood the solution, all the participants? Here, the coefficient of the middle term in the binomial expansion in the powers of x of this and this is same. If alpha, then alpha is what? Okay. So here the power is 4. That means the number of terms will be 5. So if there are 5 terms, the middle term will be the third term. 2 terms from the beginning, 2 terms from the end are skipped. Then I need to talk about the third term. Third term means t2 plus 1 I'll find from here. If the power is 6 here, there will be 7 terms. There will be 7 terms. Venkat is saying this series will be ending on 24th March. Maybe it will be ending on 24th March. I'm not aware of it. But once this revision in 3 days gets over, we'll be revising, we'll be bringing sessions for 11th, marathons for 11th, marathons for 12th. That means all the chapters of 11th will be revised through a marathon, all the chapters of 12th will be revised through a marathon. Then we'll bring again another complete marathon to make you revise entire maths, entire physics, entire chemistry. So before April attempt, we'll be conducting these kind of marathons. Okay. So here, if the power is 6, there will be 7 terms. So 3 terms from the beginning, 3 terms from the end. 4th term will be the middle term. So here I'll be finding the 4th term. 4th term means 3, 3 plus 1. Everybody got that? Everybody with me on this? So T2 plus 1 if I define here, T2 plus 1. So NCR, so 4C2, alpha x to the power, I hope you're understanding R, which is alpha square x square. Are you all there? Similarly here, T3 plus 1 if I define, it will be NCR, that is 6C3, alpha, okay, this is minus, so this is minus alpha x whole raised to the power 3, so minus alpha x whole raised to the power 3. First of all, give me a quick update. Everybody understood this part? Now what are we told? That the middle term, the coefficients are same, so x square and x cube you can forget. The coefficients are same, which means 4C2. 4C2 is what? 4 into 3 divided by 2 into alpha square is equal to what? 6C3. That is 6 into 5 into 4 divided by 3 into 2 into 1 into minus alpha cube. So minus I introduce here and I write it as alpha cube. Everybody with me on this? No confusion on that. And this is given as equal. Now I can cancel this alpha square by that alpha cube because root loss will not happen because alpha cannot be 0. So if this alpha square nullifies this alpha cube, I'll be left with an alpha here. And I think with that you have gotten the answer, because with that this 2 and this 2 are cancelled. This 4 and this 4 are also cancelled. This 3 makes it 2 times. So it should be what? Minus 3 by 10. So alpha should be minus 3 by 10. That gives you option C as the correct answer. How many of you got this? I hope this was easy, understandable and doable. Everybody who's with me has understood this one. Can I move ahead from here? All the participants. Now from here, when we solve this question, what does it say? Consider the system of linear equations and where we need to define what kind of solutions it have. So don't go for Kramer directly, think logically. Define delta, then delta 1. I think with that, you'll be in a better position. So let me find delta first. So with the delta, what do we have? 1, 2, 1. This is 2, 3, 1. And this is 3, 5, 2. Correct me if I'm wrong. 1, 2, 1, 2, 3, 1 and 3, 5, 2. And here, if I ask you a very simple thing, that add first 2 rows. Let's say in row 1, if I add row 1 and row 2, what will I have? I hope you are understanding. It will be 1 plus 2, that's 3. 2 plus 3, that's 5. And 1 plus 1, that's 2. So this is 2, 3, 1. And this is 3, 5, 2. So I can clearly see that 2 rows are identical. And if 2 rows are identical, which means its determinant is 0. So first of all, delta is 0. When delta is 0, the possibility of unique solution is discarded. So now it will have either infinite solutions or no solutions. So now let us find out delta 1, right? So let me define delta 1. What is wrong here? Give me a second, students. I will now define delta 1. So can I define delta 1 here? Delta 1 means what? The coefficient of x1 will be replaced by the constant terms. So it will be 3, 3, 1, then 2, 3, 5. then 2, 3, 5, and then 1, 1, 2. It is 1, 1, 2. Let us find its value. Delta 1 I'm finding. Can I use Sarus rule directly? So when I use Sarus rule, 3, 2, 1 and 3, 3, 1. I hope you remember that. So Sarus rule says 3 into 3 into 2, that is 9 into 2, 18, plus 3 into 5 into 1, that is 15, plus 1 into 2 into 1, that is 2, minus 3 into 1 into 1, that is 3, plus 3 into 5 into 1, that is 15, plus 3 into 2 into 2, that is 4 into 3. How much is that? 12. Correct me if I'm wrong. So I think this is not 0 because 15 and 15 are cancelled. 20 and this is 15, that is 5, which is not 0. Which means if delta 1, delta 2, delta 3 all are 0, then it gives you infinite solutions when delta is 0. But delta is 0 and delta 1 is not 0, which means it is a case of no solutions. Option C is needed to be marked. Do you remember these kind of scenarios where you solve questions in this manner? All the participants. Can I move ahead from here? Everybody. Now with that, when I go ahead here, let's solve this one. What does it say? A is given by a 2 by 2 matrix which has non-zero entries. No, it is not giving you a unique solution. It is case of no solutions. So here it has non-zero entries. So A is a 2 by 2 matrix and A square we are given as an identity matrix. So first of all, let me take A as, let's say, alpha, beta, gamma and delta. And here we are taking this, that alpha, beta, gamma and delta, none of them is 0. They are non-zero entries, mind you students. Now from here, what I do next is that A square is given as I. So A square, if I try and find out alpha, beta, gamma and delta multiplied with the same alpha, beta, gamma and delta, right? So this will be what? Row and column. So alpha, beta, alpha, gamma. Alpha square, beta, gamma. I hope you are understanding. Alpha square plus beta, gamma. Everybody with me on this? Now here, alpha, beta, beta, delta. So alpha, beta, I hope you are understanding. Alpha, beta, beta, delta. So it should be alpha, beta plus beta, delta, I think. Correct me if I'm wrong. Then gamma, delta, alpha, gamma. So gamma, alpha, delta, gamma. I repeat, gamma, alpha plus delta, gamma. Then gamma, delta, beta, delta. So gamma, beta plus delta square. So it should be gamma, beta plus delta square. Correct me if I'm wrong. That's your A square. But what are we given? We are told that A square is an identity matrix. We are given that A square is an identity matrix. That means this is 1, 0, 0, 1. Now if we are told that this was an identity matrix, then corresponding elements should be same, which means these entries here, this should be this, this should be this, this should be this, and this should be this. I hope you remember that. So with that, when I go ahead, alpha square plus beta gamma will be 1. First conclusion. Second conclusion, alpha, beta plus beta, delta. When I take beta common, alpha plus delta should be 0. Third conclusion, when I take gamma common, alpha plus delta should be 0. And when I take this gamma, beta plus what? Delta square, that should be again 1. One thing is sure, that if I put it equal to 0, beta cannot be 0. We already know they are non-zero entries. So alpha plus delta should be 0. That is validated by here as well, because here also gamma cannot be 0. So one thing I have cracked, that alpha plus delta will be 0. One conclusion we have, that alpha plus delta will be 0. First conclusion. Everybody with me on this? Second conclusion will be this, that alpha square plus beta gamma or beta gamma plus delta square will be 1. That is the second conclusion. This is also going to be true. Either this or this, or rather both. Now let us look at the options. Define. So trace of A is sum of diagonal elements, determinant is there. Statement 1, trace of A is 0. What was A? I think our matrix A was alpha, beta, gamma and delta. So here trace of A will be alpha plus delta, and I think alpha plus delta we have cracked as 0. That means trace of A is 0. Statement 1 is correct. Let us find determinant of A. What will be the determinant of A? Determinant of A will be alpha delta plus beta gamma. I repeat, determinant of A will be alpha delta plus beta gamma, right? I hope there is no confusion on that. Now here, if I do one thing, that alpha, if I substitute by minus delta, okay, Sarfaraz, if I substitute alpha by minus delta, what I get is, if I substitute alpha by minus delta, I'll get minus delta square plus beta gamma. Minus delta square plus beta gamma. I think minus delta square plus beta gamma is not what we have. We have delta square plus, correct me if I'm wrong, are we going great? Because alpha is minus delta. I'm really sorry, how can I make such silly errors? It is alpha delta minus beta gamma, right? So it should be minus delta square minus beta gamma. And when I take minus sign common, it is delta square plus beta gamma. And we know that delta square plus beta gamma is 1. So the determinant is found to be minus 1. But what are we given? That determinant is 1. No, statement 2 is false. So statement 1 is true, statement 2 is false. Option B will be the correct answer. Everybody got this? Everybody understood this? All the participants. How many of you cracked it? How many of you got this answer? Right? Great. Now with this, when I move ahead, let's solve the next question from here. The number of 3 by 3 non-singular matrices. Do you remember non-singular? Non-singular means their determinant should be not 0. Non-singular. With 4 entries as 1 and all the other entries as 0. Okay. I am saying that let's say there is a matrix A whose diagonal elements I'm keeping as 1. All the other entries will be 0 and one more element I can keep as 1 because 4 elements should be 1 and the other element should be 0. So I am keeping this like this. This is clearly a triangular matrix, and for triangular lower or upper and diagonal matrix, the value of the determinant is given by product of the diagonal elements. So if I'm ensuring that here on the diagonal, if I have kept 1, 1, 1, if I have kept 1, 1, 1, then its determinant will be 1, which is 1 into 1 into 1. Do you remember that? Now this is one such possibility where I have kept this 1 here. The other possibility would have been this, that I keep this 1 here or here or here or here or here. So total there are 6 possibilities. So there are total 6 possibilities in that case. Are you understanding that? Apart from that, if I assume this A in some different manner where I keep them non-principal diagonal elements like this 1, 1, 1 and all the other elements as 0, 0, 0, 0, 0 and just 1 again I keep at one of the positions. Again in this matrix. Again when you find this again gives you its value of the determinant to be 1. Non-zero at least. I hope you're understanding it. I hope you're understanding. When you expand it along with the first, I hope whichever row or column you expand it, let's say I expanded with the first row, I think with this 1, I'll have what? 0 minus 1, so it is again non-zero. It is again non-zero. So I'll say determinant of A is again non-zero. And with this, one more thing is for sure, that this one gives me the liberty that now I can again keep this one here, 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 here or here. So I have again 6 choices. These are 6 other choices or possibilities. So 6 plus 6, 12 possibilities we have already discovered or explored where the determinant is non-zero, where the matrix is non-singular, where 4 of the elements are 1, other are 0 for a 3 by 3 matrix. Now what are they asking? How many such matrices are possible? 5, 6, less than 4, I think this option are incorrect. At least 7. Why? Because 6 and 6, 12 we have already calculated. There could be more, which we haven't explored so far. But I hope you're understanding. At least 7, yes, because 12 we have already calculated. Everybody got that? Everybody understood this? Can I move ahead from here? All the participants. Now let's try and solve the next question. Here, a lot of students have many times asked about the rank of a word in a dictionary when the letters are repeating. Then what happens to the short technique? Nothing happens to the short technique. It still remains same with a slight change. Now what is that change? Let's work that out. Let's say the word is small, right? So S, M, A, double L. Now what you do is pay attention to this part. All I'm saying is very simple result here, that again do the indexing. So how 12? So Sridharan, 6 in the first case, 6 in the other case, so 12, minimum 12. Did you not get it? Because this one has 6 choices, this. Even this one can appear at 6 places, either here. So 6 here, 6 here. So 12 cases will get created. Now, with this small, if I do the indexing, I know that A will be the first, A, B, C, D, E, F, G, H, I, J, K, L. So L will be second, so both L will be 2, 2. L, M, so M will be third, and S comes in the end, so it is fourth. Now do one thing, look on the right of 4, how many numbers you see which are less than 4. So I see 1, 2, 3. I hope we are not saying 4, it is 1, 2, 3. So write that 3 here. Are you understanding it? I'm really sorry. I repeat, less than 4, how many numbers you see? So 1, 2, 3, 4, because this 2 and this 2 are 2 numbers, so they are 4. Right, so this is 4. Less than 3, how many numbers do you see which are less than 3? So 1, 2, 3. There are 3 numbers which are less than 3. Everybody understanding it? So this is giving me 3. I repeat, less than 4, I can see 1, 2, 3, 4 numbers. So I wrote 4. On the right of 3, I can see 1, 2, 3 numbers which are less than 3. So I wrote this 3. On the right of 1, there is no number which is less than 1. On the right of 2, there is no number which is less than 2. And here, there will be no number on the right of 2. Now do one thing. Of this 4, how many numbers do you see are getting repeated, including this 4? So on the right of 4, including this 4, I see 2 numbers to be getting repeated. So divide this by a 2 factorial here. Are you learning that short technique? On the right of this 3, including this 3, how many numbers do you see which are getting repeated, and how many numbers, how many times are they getting repeated? So this 2 is getting repeated, and that is repeating 2 times. Here also I should have written 2 factorial and 2 factorial, but since it is 0, so it doesn't matter. So I need not write that. It does not make any sense. Now what we do is, I hope you remember, the next thing is I write 0, then I write 1. I hope you remember 0 factorial, 1 factorial, then 2 factorial, then 3 factorial, and then 4 factorial. I hope you do remember it very clearly. Everybody, all the participants. Then from here, what do we do next is, I hope very simple conclusion or result, that we multiply this to this, we multiply this to this, we multiply this to this, which we need not, this to this, and this to this, and we add all these results. We add all these results to get our final answer. I hope these expressions are understandable. So 0, 0, 0 doesn't matter. These two will be counted and calculated. So finally, what we receive is 4 by 2 factorial into what? 4 factorial, that is 4 into 3 into 2 factorial, plus 3 by 2 factorial into 3 factorial, which is how much? 3 into 2 factorial, plus 0 plus 0 plus 0 plus 1, because these many letters will appear before small, and plus 1 will be its rank. I hope you remember that. I hope you haven't forgotten that. So with that, when I simplify this, what I get here is, this 2 and this 2 are cancelled, this 2 and this 2 are cancelled. So 16 into 3, 48, plus 9 plus 1, that is 10. So 48 plus 10 is 58. That's your option D. Did you understand the short technique? So whenever you are given letters of a word where letters are getting repeated, then also the trick remains same. The only thing you do is you divide this, introduce this 2 factorial. Regarding what, Sarfaraz? I think we are having 2 things going on YouTube currently. PCM, marathons. So if it is M today, tomorrow it will be P, then C, then M. And in between, on every Wednesday and Saturday, we are having rank booster analysis. So this is how the things are going on, right, Sarfaraz? Now from here, let us focus on the next question for the day. If the 4-letter word need not be meaningful, are to be formed using the letters Mediterranean, such that the first letter is R and the 4th letter is E, then 4 letter word is needed to be found. Okay, so 4 letter, 1, 2, 3, 4, where first letter should be R and fourth letter should be E. So I have already taken an R and an E. Okay, now how many letters am I still left with? Right. Okay, great. Let me talk about the single ones. So I think M is a single one. Right. E is appearing how many times? 1, 2, correct me if I'm wrong. So E is appearing 2 times. Then what about D? I think D is appearing 1 time. Then what about I? I think I is also appearing 1 time. What about T? Sir, T is appearing 1 time. Then what about R? R, since we have already used, now it is appearing only once. What about A? A is appearing twice. So A is appearing twice. What about N? N is also appearing twice. So these are the letters I am now left with. Yes, E is thrice, but one E I have already placed as per the condition of the question, because they told us that R should be the first one and fourth letter should be E. So one E I have already utilized here. Do you get that? Now from here, what I do next is very simple observation. Now these two places can be filled by either any of these, which means double E, double A, double N, or any of these, or any one from this or any one from this. Did you understand what I'm saying here? Everybody getting what I'm saying here? I repeat my part. I repeat my part. All I'm saying is 1, 2, 3, 4, 5, 6, 7, 8. 8 unique letters I'm having. So if I wish to position them with unique letters here, these two places should be unique. So out of these 8 letters, 2 places can be chosen in 8C 2 ways, and then they can be arranged in 2 factorial ways, or means addition. I hope you're understanding it. Now unique means they are used. It could be MD or ME or MA or MI. All those unique, both those two distinct combinations we have already chosen, and they are arranged into factorials, because R and E are fixed, so they don't make any sense. There is only one way with that. Or if I keep both of them same, so both of them same can be kept in either as EE, AA or NN, so that is 3C1, because you choose either EE or A or NN, so 3C1, which means what? 3 ways. Are you understanding this, or shall I repeat this part? How many of you got this? And with that, I think you can mark the correct option. Can you do that by yourself? Shall I do it? 8C2 is going to be how much? I hope you are understanding. 8C2 will be 8 into 7 divided by 2 into 2 plus 3. I hope you are understanding it. So 2 and 2 are cancelled. 56. 56 plus 3 is 59. Are you all there, listening, watching and understanding? Everybody got this, or shall I re-explain this question? Easy, simple and decent question it was. Nothing much was needed to be done. Again, a simple question, and we did discuss that for this I'll be asking you a formula which we did discuss while discussing the theory of PNC. Do you remember that? Even if you forget that formula, you can still derive it. You can still derive it. How? Let me try and help you with that derivation fast. Let me say that we are given NCR upon NCR minus 1. NCR minus 1. So if you know the expansion of this, you can crack it. Why? Because NCR is given by what? N factorial upon R factorial into N minus R factorial whole divided by again N factorial upon R minus 1 factorial into N minus R plus 1 factorial. Correct me if I'm wrong. Correct me if I'm wrong. I hope you're getting it. How did I write it? And I think with that our job is done. Why? Because first of all this and this are cancelled. I'll first of all rewrite it, then I'll cancel, otherwise you'll get confused. So this part goes to the numerator, this stays in the denominator. So this is N minus R plus 1 factorial into N minus R factorial divided by, correct me if I'm wrong. Sorry, why am I writing N minus R? This should be R minus 1 factorial divided by N minus R factorial into R factorial. From here, I hope you all are clearly seeing it getting formed, that R factorial can be written as R into R minus 1 factorial. So this and this are cancelled. And N minus R plus 1 factorial can be written as N minus R plus 1 into n minus r factorial, this is cancelled by this. So it is n minus r plus 1 by r. I repeat, it is n minus r plus 1 by r. That's exactly what we discussed while revising the theory of PNC. So I hope this is how you can always derive these kind of results. Now, if I have this result, n minus r plus 1 by r, right? Here, forget this entire expression, let's work out this result. 15 CR by 15 CR minus 1. So we just discussed that NCR upon NCR minus 1 is n minus r plus 1 by r, right? So what is n? 15 minus r plus 1 by r. That's how you can simply replace it. Are you all getting it? This whole is getting multiplied by r square. Okay, that's fine. And then we need to take its what? Summation, where r is from 1 to 15. That I'll do later. But can I simplify this first? Yes, no worries with that, Sushindran. You all can do it by yourself. It is something really simple and easy. You can always crack them. With that, now if I go ahead with this, I think this r cancels this r. 15 plus 1 is 16. So it is r times 16 minus r. It is r times 16 minus r, which when simplified further gives you 16r minus r square. So this becomes summation of 16r minus r square. Now this summation can be splitted over addition or subtraction. So this becomes 16 summation r minus summation r square. And there you know the formulae of sequence and series, right? How many terms are there? 1 to 15. So first 15 natural numbers. So it is n plus 1 divided by 2. Square of first 15 natural numbers, that is n plus 1, 2n plus 1, 15 into 2 is 30 divided by 6. From here, will you do the calculation? Can I skip that part? Will you do that and find out the correct answer? I hope it's not difficult now. But did you understand that part, that how should you simplify this? Instead of getting worried by this, how do you deal with these kind of expressions? All the participants, everybody with me. Can I move ahead from here? Right. When I move ahead from here, let me see. Can we have a 10 minutes break? Then we'll resume with this discussion. 15 minutes break I need, because I need water and some rest, at least some water first. So 15 minutes break we are taking. It is 8:25. We'll resume at 8:40. Will that be okay? 8:40 is when we'll be resuming it at. So we will resume at 8:40. Right? So there is a break for the next 15 minutes. I hope that's okay. क्या सब लोग माइक में म्यूट करा है, बदल लेना. Alright students, just give me a quick confirmation. I hope I'm clearly audible and visible. Let's get started with our discussion, right? Okay, so anyone who has done this question, all the participants who are watching it? Okay, let's begin with this part. Okay, I hope you all are there, listening, watching and understanding. Let's solve this particular one. How many of you have done this? Anyone? I'll say that here r squared plus 1, if I could split into something, what do I mean by that? Telescoping I'll introduce here, but how? Pay attention to that part. R squared plus 1 for a while, let's say if I write as r plus 1 whole square, then it will be r squared plus 1 plus 2r. So from this, if I subtract 2r, I think it will be balanced. So this, if I write as this summation, r is 1 from 10, that I'm not writing time and again. So it is r plus 1 whole square minus 2r, right? This whole is multiplied by what? R factorial. Pay attention to this part. Everybody with me on this? That's good, Arpan. Now from here, what I do next is r factorial I'll push inside, right, with that summation. So what I do is, okay. So first of all, r plus 1 square, right? So I'll write it as r plus 1 into r plus 1. That r factorial also comes here. This 2r, I write as minus r minus r. I hope I can do that. Good, Arpan, that's brilliant. So this 2r, I write as minus r minus r. So minus r into r factorial will be there, and then minus r into r factorial will be there. First of all, give me a quick update whether you are able to understand this or not. I repeat my part. R plus 1 square, I have deliberately written as r plus 1 into r plus 1. That is getting multiplied by this r factorial. Getting it? Then this 2r I'm writing as r in r, which means minus 2r, which is minus r and minus r. That minus r and minus r are also multiplied by r factorial and r factorial. Got this part comfortably, everyone? Now, from here, what I do next is, if I rearrange this, right? One of the methods is you do hit and trial with some values of r1 and 2. You do its generalization and check it. That I'll definitely share with you. Don't worry about that. That short technique also I'll share. But here, if I do what? See, I am thinking of doing something. This is r plus 1 square, right? R plus 1 square multiplied with r factorial. So what does it become? Okay, great. So here, I am dealing with this part, this part, right? So this is summation outside, and then pay attention to this part. R plus 1 into r, that is r plus 1 factorial into r plus 1. Comfortable, everyone? Minus r factorial, or I can write it as r factorial into r. That I'm keeping aside. And this summation I'm keeping on these two, and this summation I'm separating on this r factorial. Give me a quick update on this. Did you all understand this, whatever I've done so far? All I did was, this summation I have kept limited to these two, and then summation I have kept additionally or separately on this one. So when I keep this summation limited to this r plus 1 into r, that is r plus 1 factorial, r plus 1 is there, and this is r factorial into r minus summation of r into r factorial. Everybody got this? Can I move ahead from here? Then, when you proceed further, what you see next is, pay attention to this part, students. Here, if you could see this, is it not something matching with telescoping sum? Why? Because r is from 1 to 10. I'll show it. R is from 1 to 10. So when you put 1, 2 factorial into 2. When you look at this part, this is 2 factorial into 2 minus r is 1, which means 1 factorial into 1. Then plus when r is 2, it is 3 factorial into 3 minus 2 factorial into 2. So I hope you must have started seeing the pattern. The last term will be 11 factorial into 11 minus 10 factorial into 10, and you must be seeing that for the first part, you are clearly seeing that these things are getting cancelled in this fashion. So you'll be left with this minus this. This is 1, this is 11 factorial into 11. So I'll be left with 11 factorial into 11 minus 1. But I am not done yet. This is the first part. I am still dealing with the second part. We are still left with this part, r into r factorial. So let's solve that part now. So from this, we were subtracting summation r into r factorial. That can I write as r plus 1 minus 1 into r factorial. Are you comfortably getting this? which further can be written as, I hope that part I'm doing separately, and in the end I'll subtract that. So this I'm writing as summation r plus 1 into r factorial minus r factorial. I hope you are comfortable with that. And again this becomes what? Summation r plus 1 factorial minus r factorial. Again r is ranging from 1 to 10. R is ranging from 1 to 10. This is the second part of your question, right? So here, if R is from 1 to 10 means what? I hope again telescoping, you all can see it. If you cannot, I'll show you here. 2 factorial minus 1 factorial, then 3 factorial minus 2 factorial, and so on until you will have 11 factorial minus 10 factorial, and again you will see it getting cancelled like this. So there will be left with 11 factorial minus 1 factorial. Now, so this result gives you 11 factorial minus 1 factorial, but that was needed to be subtracted. So that will be minus 11 factorial plus 1. That will be minus 11 factorial plus 1, the final result. This when clubbed with that. So I think 1 and 1 are cancelled. 1 and 1 are cancelled. So what am I now left with? This 1 and this 1 are cancelled. 11 factorial, 11 factorial. So 11 factorial, 11 factorial common. 11 minus 1 is 10. So it should be 10 into 11 factorial. 10 into 11 factorial is given in option B. Everybody got this, or shall I re-explain this? All the participants. That's brilliant, that's good. I hope you all can understand this very clearly. I need not explain it again. From here, let's solve the next question. N plus 2 C6 upon N minus 2 P12 is equal to 11. So first one is C, second one is P. Okay. Then N satisfies the equation. Formula based question, direct question. If you know the basic, you can crack it. So first of all, what do we know? We know few things. I hope there is no confusion on the formula NCR and NPR, right? R and N are same? No, they are not same. So with that, NCR, I hope you remember N factorial upon R factorial into N minus R factorial, and NPR you remember N factorial upon N minus R factorial. I hope you do remember that without any confusion. So with that, when I simplify this, what is it? It is N plus 2 C6, N plus 2 C6 divided by N minus 2 P2. It is N minus 2 P2. So when I simplify this, what do I finally get? Pay attention to this. N plus 2 C6, C, right? So it will be N plus 2 factorial divided by what? 6 factorial into N minus R. So N plus 2 minus 6, that is N minus 4 factorial. Give me a quick update on this. Did you all get that? I repeat, this is C. So N, R, N minus R. So N plus 2, 6, and N minus 4. Now here N minus 2 P, 2, that is N minus R. So it should be N minus 2 factorial divided by what? N minus 2 minus 2, that is N minus 4 factorial. Give me a quick update on this. Everybody got this? Now from here, what I do next is, sir, N minus 4 are cancelled first of all. Are you all getting it? Now what are we given it as? We are given it as 11. Perfect, great. Now here, I hope you can see N minus 2 factorial can be brought here. So from writing it here, I am writing it here. I hope you are comfortable with that, N minus 2 factorial. Now N plus 2 factorial, can I write that as N plus 2, N plus 1, N minus 1 into N minus 2 factorial, and this are cancelled. And there I'm having 6 factorial. Pay attention to this. This is 6 factorial. And this entire expression we were given as 11, I think. It was given as 11. Great. So if it was given as 11, I have N plus 2, N plus 1, N minus 1. Right. We have N plus 2 into N plus 1 into N minus 1. 4 consecutive numbers are there. R 11 into 6 factorial. I think R 11 into what? 6 factorial. Now what is 6 factorial? 6 factorial is 6, 5, 4, 3, 2, 1. Now can I write this product also as a product of 4 consecutive, natural numbers? Now how do I break it? If I could begin with this, I think 11 I have gotten. Anything which is close to 11, because 11 will be there. 11 is a prime, so you cannot do anything with this 11. So I think with 11, I can see a 10 coming into picture. I can see a lot of things come into picture. This 6 we can see as 2 into 3, right? So with that, I think the job is done because 11 is there. See, 5 into 2 is 10, so there will be a 10. Then this 3 into this 3, that will be 9. And this 2 into this 4, that will be 8. And that is clearly seen as n plus 2, n plus 1, n. Don't start solving this by quadratic. Compare it and with that, get it. Yes, that's good, Deepak Bharadwaj. With that, when you compare it, I hope you can see n is found to be 9, right? I hope you can clearly see it. So n should be 9. Now, out of these equations, which quadratic give you n as 9? So let's try and satisfy it. So if I put n as 9 here, so 9 square is 81, plus 9 into 3 is 27, minus 108. I think 81 plus 27 is 108, 108, 108 is 0. Option 1 is answer. All of these options will not be satisfied by taking n as 9. Good, great, that's brilliant. Everybody understood this? Can I move towards the next question? All of you are there, listening, understanding, and clearly grasping. Now from here, when I go ahead, what do we see next? Events A, B, C are mutually exclusive events. Okay, they are mutually exclusive such that PA, PB, and PC are defined. Set of possible values of X are in what interval? First of all, we know that probabilities are never negative. So they are always non-negative. So first conclusion will be that this 3x plus 1 by 3 should be positive or at least non-negative. This 1 minus x by 4 should be non-negative. And the third one, 1 minus 2x by 2 should also be non-negative. These three conclusions should be there. Then I'll talk further. Let me simplify these. So here I get 3x plus 1 to be greater than 0. That means 3x should be greater than equal to minus 1, which means x should be greater than equal to minus 1 by 3. I hope I can directly write it like this. Here, this 4 vanishes. So x is less than 1. So from here we get x should be less than 1. And from here, what do we get? This 2 vanishes. So 2x is less than 1. I hope you're understanding. 2x is taken to the other side. So x is less than 1 by 2. I repeat, this is 1 minus 2x greater than equal to 0, which means 1 is greater than 2x. So which means x should be less than 1 by 2. So x is less than 1, and when it says x should be less than 1 by 2, I think this is better. So from these three, the conclusion comes here is that x should be from minus 1 by 3 to 1 plus 1 by 2. But that's not all. One more thing is there. One more detail was there. What was that? They are mutually exclusive. They are mutually exclusive. So if they are mutually exclusive, we know if three events are mutually exclusive, probability of A, union B, union C. For mutually exclusive events, it should be probability of A plus probability of B plus probability of C. Do you remember that? And this is the whole probability, the doodle probability. So it should always be less than 1, which means PA plus PB plus PC should be less than 1, which means their sum should be less than 1. Sum means 3x plus 1 by 3, 3x plus 1 by 3, then 1 minus x by 4, 1 minus x by 4, and 1 minus 2x by 2. 1 minus 2x by 2. This sum should be less than equal to 1. Everybody got that? I think LCM will be 12. Yes, good, Deepak. It should not be equal to it should not be equal to 1. This is the A union B union C. So it should be less than equal to 1. It should be maximum 1. I hope you're understanding. They are mutually exclusive, but they are not mutually exclusive and exhaustive. Exhaustive they haven't used. That's why it should not be 1. It should be less than equal to 1. Now with that, if I get back to this discussion, the LCM we are saying 12. So if I multiply this by 4 and divide it by 4, if I multiply this by 3 and divide it by 3, if I multiply this by 6 and divide it by 6, I think I have the complete clarity. So this is what? 12x plus 4. This is 3 minus 3x, and this is 6 minus 12x whole divided by 12. That 12 goes to the other side. Give me a quick confirmation. 12x plus 4, 3 minus 3x, 6 minus 12x whole divided by 12 goes to the other side. So 12x and 12x are cancelled. You're left with minus 3x. Then 4 plus 3 is 7. 7 plus 6 is 13. 13, that is minus 1. Correct me if I'm wrong. If I take minus sign, it is 3x greater than equal to 1. So x should be greater than equal to 1 by 3. X should be greater than equal to 1 by 3. That's our Another conclusion. So this and should also be there. That means intersection with this. X should be greater than equal to 1 by 3. X was greater than minus 1 by 3, but I think it is greater than 1 by 3. So my final answer will be X should be greater than 1 by 3 to 1 by 2, because 1 by 3 is less than 1 by 2. I hope you are listening and understanding that. So my answer will be 1 by 3 to 1 by 2, option B. Did you all get that, or shall I repeat this? Everybody with me on this? From here, the next question will be solving the mean and variance of a random variable x having binomial distribution. I hope you remember mean we discussed NP is given by 2 and variance NPQ is given by 4 in this question. So I hope you remember this particular part, no confusion on that. So if NPQ is divided by NP, I'll get Q. Am I correct? Sorry, I have written it opposite. Mean just give me a second, students. Mean we are given as mean and variance. So mean we are given as 4 and variance is given as 2, right? So if I divide this by 2, NP and NP are cancelled. 2 by 4 is 1 by 2. So Q is 1 by 2. So P is 1 minus Q. 1 minus Q means 1 minus 1 by 2, that is 1 by 2. Now if I put this P here, which is 1 by 2, 2 goes there, 4 into 2. So N is found to be 8. Now we are asked probability when the random variable is 1. So this is NC1. N is what? 8. So it is 8C1. Probability of one success, that is P to the power 1 by 2. Sorry. P to the power 1, that is 1 by 2 to the power 1, into Q to the power 8 minus 1, that is 7. So 1 by 2 to the power 7. I hope you're understanding it. So 8C1 is 8 into, it is 1 by 2 to the power 8. And with that you can mark the correct option. I am skipping that calculation. It is 2 cube. This is 2 to the power 8, 2 to the power 5. That is 1 by 32. Option B. I hope it was easy, understandable. Everybody must have seen such questions, done such questions. Now let us move towards the next question. Again, same question with slight change. Let us revise it one more time. Mean and the variance. So this time mean is 4. Mean is 4 means what? NP is 4 and variance means NPQ is 2. So again I have the same data. Same data means what? If I divide this by this, so Q will be 1 by 2. So P is 1 minus Q. So P is also 1 by 2. And if I put this P here, 4 into 2, that is 8. So N is 8. So same data was there. The question has changed. What is the question now? Probability of 2 success. So this time probability of 2 success. So X is 2. So previously X was 1. This is X is equal to 2. No change is there in the question. So it is given by NC 8C2 1 by 2. P to the power 2 success. Q to the power 8 minus 2, that is 6. Again, I hope you know 8C2 is 8 into 7 divided by 2 into 1. That is 1 by 2 to the power 8. And I hope you can do the calculation again. It is not a tough task. You can crack the question. Will you do the calculation by yourself? Everybody understanding how do you deal questions based on this concept? Everybody with me on this? Now, this question says probability that A speaks truth is 4 by 5, while probability that B speaks truth is 3 by 4. Then probability that they contradict each other when asked to speak on a fact. So when they are speaking on a fact, which means facts are facts, so they are either true or false. And contradiction means what? So if A speaks truth, B contradicts, which means B does not speak truth, B speaks false. Or when A doesn't speak truth, B speaks truth, because when B speaks the fact, A contradicts it. Or when A speaks that fact, B contradicts it. Are you getting it? Are you getting it? How did I create it? And if we can create it like this, I think the probability of A speaking truth is 4 by 5 and B not speaking. So B speaking is 3 by 4. B not speaking truth is 1 by 4 plus A not speaking truth is 1 minus 4 by 5, that is 1 by 5. And B speaking truth is 3 by 4. I hope from here you can do the calculation. 20 and 7. So answer should be option C. Was it not easy, simple, decent, straightforward? That's good, Deepak. That's brilliant, students. From here, let's move towards the next question. Z is not 1. So complex number Z is not 1. Okay, cool. And we are told Z square upon Z minus 1 is real. Do you remember whenever we are told that a complex number is real, it is equal to its conjugate. Just apply that. So we are told z square upon z minus 1. Z square upon z minus 1 is purely real, so it should be equal to its conjugate. Its conjugate should be what? This is how you write the conjugate, because conjugate can be distributed over addition, subtraction, multiplication, division. Do you remember that? And here when I proceed further, let me do the cross multiplication. So it becomes z square z bar minus z square is equal to z bar square minus z bar square. If I bring everything on one side, it is z square z bar, right? It is z square z bar, then minus z bar square. Correct me if I'm wrong. Sorry, it should be plus z bar square, then minus z square minus z bar square should be 0. I repeat, z square z bar plus z bar square minus z square minus z bar square is equal to 0. Now what I do is, if I take z bar common, I think, what should I take common to make it better? I am trying to factorize it, so let me think for a while. Give me a second, students. I think z bar can be taken common, but when I take z bar common, I think yes, that will do. So I am taking z bar common from here and here. So when you take z bar common, what are you left with? Z bar when taken common, z is what you're left with, and here minus z bar. Comfortable with that? And this is looking like a square minus b square. So that I can write as a plus b, a minus b, a square minus b square. So a plus b means what? Z plus z bar. I hope you're understanding. Z bar plus z I should have written actually. And this should be z bar minus z. This should be z bar minus z. So a plus b, a minus b should be equal to 0. But z minus z bar it is. I'm really sorry. What am I doing here? It should be z bar minus z. So it should be z bar minus z, right? A plus b into a minus b, but it is z minus z bar. So to make a z minus z bar, I'll take a negative sign common here and it becomes z minus z bar. I hope that part is understandable. That part made complete sense here. So it is geometrical representation of complex therefore means yes, it is there. Good. Prabha Oris, good. When will be the break? Break is finished. Sonia, great. So this is z minus z bar. Everybody with me on this? Now z minus z bar when I take common, z minus z bar when you take common, what are you left with? You're left with z bar. Z minus z bar I have taken common. Z bar, right? Z minus z bar I have taken common. I'm not making any mistake. And there you have this z plus z bar with a minus sign. So this is z plus z bar is equal to 0. Correct me if I'm wrong. I hope there is nothing wrong here. You all are getting it very clearly. Everyone with me on this? Now, are we given something here? I don't think we are given. Now we are asked the complex number z lies where? Okay, so let's talk about this complex number z here. Pay attention to this part. Is it going great? Z plus z bar. I am taking a negative sign here, right? So it should be written like this. Am I making any mistake here? Let me check this part. Z bar I have taken common. So it will be z minus z bar. Then I wrote it as z bar plus z and z bar minus z, but I took negative sign common. Then z minus z bar I have taken common. So I am left with z bar minus of whole of z plus z bar is equal to 0. Correct? No confusion in that. Now from here, when I go ahead, what do we see? Although Deepak, it is not specified directly, but questions are asked, and even if it is not given directly, question can be done with the complex number and its geometry so that you can get the answer very quickly. Right. Now, here, if I now talk about this particular result, z minus z bar. Now, if pay attention to this part. Z minus z bar will be 0 or this will be 0. Everybody getting this part comfortably. So if this is 0, that gives you that z is equal to z bar, or z bar minus z bar is equal to 0. I hope you're understanding it. So first conclusion, if I go ahead, that when I say that z is equals to z bar, what does it mean? So when z is equals to z bar, it means that here x plus, I hope you remember it, we started our discussion with this fact only. If z is equals to z bar, that means x plus iota y is equals to x minus iota y. X and x are cancelled, that means y is equal to 0. So if y is 0, that means its imaginary part is 0, which means it is purely real. So this gives you the conclusion that z is purely real complex number. First of all, did you get that? Or what else could be there? This is an equation. Now what does this equation imply? If you didn't get that part, simply replace z by x plus iota y. So z bar is mod z square. I hope you remember that. Mod z square means what? X square plus y square. If let's say I take z as x plus iota y and there minus z bar. Again, if I take minus sign common, even if I take minus sign common, it is x plus iota y. X minus iota y cancelled. So x plus x is what? 2x. So plus 2x is equal to 0. Everybody understanding this? Now from this circle, I hope we can deduce a lot, which means I can talk about its center and radius. Center is going to be what? Of course, it is passing through origin first of all. If I talk about its center will be minus 1 comma 0, negative half of the coefficient of x and y, and its radius will be g square plus f square minus c. So its radius will also be, this is its center and its radius will also be 1. Everybody getting it? So it is going to be either a purely real complex number or a circle centered at minus 1 comma 0 having radius 1 passing through origin. Now let's check the options. Either on the real axis, so yes, that's true, circle passing through the origin. I think option A should be the correct one. I hope you're understanding. Center at the origin, no, option B is wrong. Either on circle not passing, no, option C is also correct. Don't the imaginary axis. Do not lie. I think it do not lie, so that is also false. Option 1 is the correct one. So did you all understand this explanation? Can I move ahead from here, all the participants? Now let's focus on the next question. I hope everybody is comfortable with this. If z is a complex number of unit modulus, so we are told that z is a complex number which is a unimodular complex number. So from here we know that mod z square will also be 1. So if mod z square is 1, mod z square can be replaced by z bar, that is 1. So from here we know that z and z bar are the reciprocal of each other. Always remember this direct result now. Whenever somebody says that a complex number is unimodular, you can say that the complex number and its conjugate are reciprocal of each other. Remember that fact. Now from here, what I am saying or trying to make you understand is argument of, see, we are given argument of z, so argument of z is said to be theta. Okay, now we need to find out argument of 1 plus z upon 1 plus z bar. Now this z bar, can I substitute by 1 by z? I hope you're understanding it. So I think it will be what? It will be argument of 1 plus z upon z plus 1 upon z, and that z goes to the numerator. So this z plus 1 and 1 plus z are cancelled and it is argument of z, which is theta. Theta we are given in option C. Was it not simple and easy? Absolutely doable. Did you or were you able to think like this? I hope you must have cracked it. Something really simple and decent. Are you all there? Good. Now from here, let's solve the next question. x1, x2, x3, xn be n observations such that summation xi square is 400, summation xi is 80, then a possible value of n among the following. N means the number of observations. So let me talk about variance because this somewhere matches with the variance. So we know variance is always non-negative. Variance is a quantity which is always non-negative. So if variance is non-negative, what can I deduce from here? I'll say that it will be summation xi square by n minus summation xi by n whole square, and this is always non-negative, right? From here summation xi is what? 400 by n. This can be pushed there, so this is greater than or equal to summation xi, that is 80 by n whole square, so 80 square by n square. Now I can do this cross multiplication of n because n, good Sushidharan, because n is a positive value. N is number of observations, so it is going to be a positive value. So I can multiply both the sides by n square. So I'm multiplying both the sides by n square. I hope you can see this is how things will happen. So now 400 when taken to the other side, what you get is n is greater than equal to 80 into 80 divided by what? 400, correct me if I'm wrong. So I think 4 into 2, that is 16. So n is greater than equal to 16. So number of observations are going to be greater than 16 if that's the case. So greater than 16, I don't see these options to be greater than 16. So answer option A. How many of you cracked it? Do tell me. I hope it was easy, simple, decent. And questions on statistics are always simple. You should be able to crack them here. In a frequency distribution, mean, median and mod. So I hope you remember that median always divides your mod and mean in the ratio 2:1. Do you remember that? This is a fact. This is a fact. Remember it as a fact. And whenever you see a question involving mean, mod and median, then always think like this. So with that, what do I have? Can I not say that, sir, median is going to be equal to 2 times mean plus mod, I'm really sorry, it is 1:2. Correct me if I'm wrong. What is it? 1:2 or 2:1? Because I'm forgetting this formula. Because it is what? Let me go ahead with this. Correct me if I'm wrong. You just Google it. Am I writing it correctly or is it 1:2? I'm just forgetting it. Mod is to mean is 2:1 or 1:2? Just give me a correct data here. If it is correct, then I'll go ahead with this. So it is 2 times mean minus what? Minus mod. Just check it on Google, somebody who all are watching it online, whether it will be 2:1 or 1:2. I'm forgetting it right now. Why am I using minus? It should be plus. And here it should be 2 plus 1, 3. So 3 times median, what are we asked? It's mod, right? So 3 times median minus 2 times mean should be the mod. Let me also check it once again. Is anyone checking it? All these students online. I'll also get it checked in a while. Just give me a second, students. Okay, so this is mean, mod and mean, right? Yes, we are going great. So I actually got confused, but this is correct, right? So with this, when I go ahead with this, what do we have here? I think we are going great. Now, what do we know? I think mean is given to be 21. Median is 22, right? So mean is 21. So this is 2 into 21. This is 2 into 21. And that is median. Median is 22. So 3 into 22. That should be mod. So I think from here you can calculate and get the correct answer. Thank you so much for that correction, Sushidharan. Prabharas. Great. Thank you so much for that correction. So I hope you all can see this. This is how you can work it out. Something decent and simple. But this is what you got to remember. Even I forgot this because not very often we use them, but you should develop some method to crack it, right? So median always divides mod is to mean into the ratio 2:1, right? Now from there, let's solve questions based on Trigo. We are told that A is equal to sin square x plus cos to the power 4x. Then for all real x, we are asked the range of A. So let's try and crack this. Okay, give me a second, students. Here, if I now begin with this, I think some simplification should be done first. So sin square x I write as sin square x only, but cos to the power 4x can I write as 1 minus sin square x whole square, because I'm writing it as cos square x whole square. So that cos square x I'm writing as 1 minus sin square x. That is your A, right? So when this is simplified, it is what? Sin square x plus sin x to the power 4 minus what? 2. 2 times what? 2 times sin square x plus 1. Correct me if I'm wrong. If for a while I take, let's say for a while assume sin square x as t, so the expression A becomes t square, sin x to the power 4 becomes t square. This is minus t plus 1. And there I know that sin square x is t, which means I know for t that t will lie between 0 and 1. T will lie between 0 and 1. Are you getting it? T will lie between 0 and 1. Are you getting this statement? Because sin square x is t. Now, if I wish to figure out its maxima or minima, the best thing is, let us quickly find out its minima. So it will be an upward facing parabola and it will have its minimum value here. And if you simply, let's say AOD is what we are using. So if I use AOD, it will be what? 2t minus 1 is equal to 0. That gives you t as 1 by 2. So I'll have its minima at 1 by 2 and minimum value will be what? 1 by 2 square is what? 1 by 4 minus 1 by 2 plus 1 minus b by 2a comma minus d by 4a, or differentiate it, find the critical point, that is where its minima will lie, that is 1 by 2. 1 by 2 you put here, you will find its minimum value. So 1 by 4 minus 1 by 2 plus 1. This 1 by 4 minus 1 by 2, I hope you are understanding, this is 2 by 4, that is minus 1 by 4, that is 3 by 4. So this is 3 by 4. I hope there is no confusion on that. If this is 1 by 2, if this is 1 by 2, 0 and 1 will be equidistant. So whether you take 0, at 0 it will be 1. I hope you are understanding. Even at 1, it will be 1. So if I am finding its minimum and maximum value, the minimum and maximum of A, I hope you can see, the minimum and maximum of A is here found to be 3 by 4 to 1, whichever one you take. So A is going to be from 3 by 4 to 1. I hope it is given in one of the options, option D. Everybody understood that, all the participants? Are you all there, listening, watching and understanding? Can I move ahead from here? The next conclusion, tan A upon 1 minus cot A upon 1 minus tan A can be written as, let's try and simplify this. A lot of methods can be utilized. One of the methods can be, you can directly do the cross multiplication. Through that you'll get something decent out of it. Or you can convert it into sine and cos as well. Let's use that method. So tan A, I'm writing as sine A by cos A. I hope you are okay with that. Divided by 1 minus. In the exam, if you wish to save time, instead of cos and sine, you can write them or replace them by C and S as well, so that you can save some time. But you should be used to with that practice. Cot A, I am writing as cos A by sine A whole divided by 1 minus sine A by cos A. Give me a quick confirmation. Sine A by cos A, 1 minus cos A by sine A, cos A by sine A, 1 minus sine A by cos A. Great. Now, when I go further, what I see is this sine A by cos A stays there. This becomes sine A minus cos A. And in the denominator I'll have. So I'm writing it directly here. It is sine A minus cos A whole divided by sine A. It will be cos A minus sine A. It will be cos A minus sine A whole divided by cos A. Everyone comfortable with this? The next thing which we do is, I hope you can see, I will swap this, flip this. So sine A becomes what? Sine square in the numerator whole divided by, what's wrong here? Whole divided by cos A times sine A minus cos A. Correct me if I'm wrong. And here, instead of again writing it as sine and cos, you can replace it by S and C, so that you can save some time. And here, it will be cos square A divided by what? Divided by sine A times cos A minus sine A. Can I replace by sine A minus cos A? If I take minus sign common, so it is sine A minus cos A, so that I can keep the denominator same, so that LCM remains simple. I hope you all are getting that. No confusion with that. One of the methods you can apply here is that you can replace a value as well, but that value should match. So let's say you take A as pi by 4. So it should give me some value, and that value should be generated by these values as well. But if two options give me the same value, let's say for a while, then I'll get stuck. So it's better that we use this. I hope you're understanding it. So here the next thing which I do is, if I multiply the numerator by sine A, so the denominator will also have a sine A. If I multiply the numerator by cos A, so the denominator will also have a cos A. So I think now the LCM can be taken. So sine A minus sine cube A minus cos cube A, right? Sine cube A minus cos cube A in the numerator divided by sine cos sine minus cos, right? Sine cos and sine minus cos. I hope you are okay with that if I write it like this. Now A cube minus B cube, how do we write it? We write it as A minus B into A square plus B square minus AB whole divided by SC, S minus C. So this and this are cancelled. Sine square theta plus cos square theta is 1. So it is 1 minus sine A cos A upon sine A cos A. So 1 upon sine A cos A. 1 upon sine A cos A is what? Cosec A sec A, and sin A cos A upon sin A cos A is 1. So cosec A sec A minus 1. Why am I getting plus 1? Am I making any mistake? Yes, I'm making a mistake. I'm really sorry. This should be plus because A minus B, A square plus B square plus AB. So with that, this is plus, and with that option, B will be the correct option. Everybody got that? All the participants. Was it simple, easy, decent, doable? Are you all there? From here, when we go ahead, let's solve the next question. Sum of all the solutions of this equation, 8 cos x, cos pi by 6 plus x, cos pi by 6 minus x, minus 1 by 2 is equals to 1. Okay, let's talk about this result. I hope you remember this result, that cos A plus B into cos A minus B has two variants. I can write it as either cos square A minus sin square B or cos square B minus sin square A, whichever you wish to take. So let's take this one. Where am I using this? Here. I hope you are comfortably understanding it. So the question for us becomes 8 cos x times whole of cos A plus B cos A minus B. I'm substituting it by cos square B minus sin square A. Cos square B means what? Cos square x minus sin square A. So sin square A means what? Sin square pi by 6. And there you have minus 1 by 2. Correct me if I'm wrong, is equal to 1. Let me check it. 8 cos x cos square B minus sin square A. Comfortable? Sin square pi by 6. How long will the session go on? Or sir? I think for another, let me check the number of questions. Few more questions are left, then it will be done. I think 10 to 15 more minutes, it will be done. Before quarter to 10, will be done. I hope that's okay. Now, here, if I get back to the discussion we all were having, where were we? So I think it is, so we were discussing sin 30, right? Sin 30 is 1 by 2, but it is 1 by 2 square, which is 1 by 4. So it should be minus 1 by, minus is already there, so it is 1 by 4. I hope you are understanding. This is also 2 by 4. So this whole should be minus 3 by 4. This whole should be minus 3 by 4 is equal to 1. Correct me if I'm wrong. Now, what I do is, if I multiply this 4 here, then this 3 stays there. So this 3 if stays there, then 4 comes out and makes this 8 as 2. And that 2, if I push here, it becomes 1 by 2. I hope you're understanding what I'm doing here. And I hope you can see this is something which is what? 4 cos cube x minus 3 cos x. I hope you can see it to be cos 3x. 4 cos cube theta minus 3 cos theta. So this is cos 3x is equal to what? 1 by 2. Any confusions on that? Are you all there with me on this? Now 1 by 2 we all know is clearly cos 60 degree. I hope you remember it. Cos 60 means cos pi by 3. If cos theta is equals to cos alpha, the general solutions we have discussed were that theta should be 2n pi plus minus alpha. I hope you remember that. So from there, I'll be concluding that x is going to be 2n pi by 3 plus minus pi by 9. Correct me if I'm making any calculation based error. 2n pi by 3 plus pi by 9. Now, between 0 to pi I need to check. So I'll start putting some values and checking it. If I put n as 0, so this whole becomes 0. This is plus minus pi by 9. Minus pi by 9 will not be there. But pi by 9 is an acceptable value because it is less than pi. Now if I take n as 1, so if I take n as 1, it will be 2 pi by 3 plus pi by 9 and 2 pi by 3 minus pi by 9, right? So this will be 6 by 9. This will be 6 by 9. So 6 pi plus 1, that is 7 pi by 9, and that is still less than pi. 6 pi minus 1, that is 5 pi by 9. That is still less than pi. That is perfect. Now moving ahead, the next conclusion, if I take n as 2, so it is 4 pi by 3. 4 pi by 3 plus pi by 9 and 4 pi by 3 minus pi by 9. So if I multiply both the sides by 3, it is 12 pi by 9. It is 12 pi by 9. So what was 12? 12 plus 1 is 13. No, it is greater than pi. 12 minus 1, 11. 11 pi by 9, that is again greater than pi. So these are the three values I'm getting. So 7 plus 5 is 12. 12 plus 1 is 13. So the sum of all the solutions will be 13 pi by 9. We were given k pi. So 13 by 9, option C will be our final answer. Everybody understood this, the entire solution, or shall I repeat this? All the participants. Now from here, the number of solutions of this equation, sin 3x is equals to cos 2x in the interval pi by 2 to pi. The interval is open. I will do one thing. You can do a lot of things. You can apply sin 3x, cos 2x identity and you can explore, but I'll do the basic idea that sin 3x can I write as sin 90 minus 2x, because sin 90 minus theta is cos theta. Now we know sin theta is sin alpha, then theta is n pi plus minus 1 to the power n alpha. What is alpha? Pay attention to this part, pi by 2 minus 2x. Now there are two possibilities. This n could be either even or odd. This n could be either even or odd. So I'll take these two possibilities. When n is even, which means I'm taking n as 2m. I hope you're getting it. So when n is even, this is 3x, this is 2m pi. Even means minus 1, that means plus 1, plus pi by 2 minus 2x. Minus 2x I can bring here. So that makes it what? 5x. So this is 5x. Even I can take this 5 there. So it is 2m pi by 5 plus pi by 10. Right. Now m can be any integer. We can solve using graphs and taking values. Yes, Deepak Bhardwaj, that is also a good method. I did not notice it. Brilliant. A very good approach you have suggested. Slight transformation of graphs will be applied, but through that also, because number of solutions they are asking, they are not asking the exact value. So you need not do all this. Brilliant. Very good idea. Very good suggestion. I did not think of this. Brilliant. Perfect. That is also what you can do. Very good idea. Now here, if I take n to be odd, which means I am taking n as 2m minus 1. In that case, what will I have? 3x is equal to 2m minus 1 pi plus, it will be minus because n is odd in this case, so minus pi by 2 plus 2x. So when this 2x goes to the other side, it makes it x. So this becomes x, and there it becomes what? X is equal to 2m pi minus pi by 2. That is how much? I think minus 3 pi by 2. Correct me if I'm wrong. I hope I'm not making any mistake. So these are the values of x. Now I got to try certain values of m so that I can keep that solution between pi by 2 to pi. So if I try m to be 0, in that case it will be pi by 10. Pi by 10 is less than pi by 2. It is not an acceptable. M minus 1 if I take, it will again give me a lot lesser values. So those I should avoid taking. If I take m as 2, it will be 4 pi by 5 plus pi by 10, right? So it should be 8 pi by 10, that is 9 pi by 10, and 9 pi by 10 is slightly less than pi, so that is an acceptable value. So 9 pi by 10 is an acceptable value. If I take m as 3, that is 6 pi by 5, 6 pi by 5 plus what? Pi by 10. If I again do this 12 by 10, that is 13 pi by 10. 13 pi by 10 is greater than pi. So I think I have crossed the values. Now here if I try some values, if I try m as 0, I'll get a negative value, discarded. If I take m as 1, I'll get 2 pi. 2 pi minus 3 pi by 2 will be pi by 2, but I am not supposed to include pi by 2, open interval. If I take m as 2, 4 pi, right? If I take m as 2, 4 pi. And 4 pi minus 3 pi by 2 will be greater than pi. I hope you're understanding it. So that is also discarded. So the only solution is 9 pi by 10. And that is the one solution. Everybody got this? Are you all clear? Can I move ahead from here? If x, y, z are in AP, and tan inverse x, tan inverse y, tan inverse z are also in AP. So if x, y, z are in AP, I'll say that y should be the arithmetic mean. So 2y should be equal to x plus z. Everybody understanding this? And we are told that tan inverse x, tan inverse y, tan inverse z are also in AP, which means 2 times tan inverse y should be equal to tan inverse x plus tan inverse z. Are you understanding this? Here I say that 2 times tan inverse y. I hope you know the formula. Tan inverse of 2y upon 1 minus y square. 2 tan inverse x is tan inverse 2x by 1 minus x square. That identity I'm using. Tan inverse x minus tan inverse y is tan inverse x plus y upon 1 minus xy. I hope you do remember that. Now if I take tan ratio on both the sides, so here it will be 2y upon 1 minus y square is equals to x plus z. X plus z can be replaced by 2y, so it is 2y upon 1 minus xz. So from here I can reach to the conclusion that 1 minus y square is equals to 1 minus xz, where I'm reaching to the conclusion that y square is equals to xz. That tells me that x, y, z are in GP. So it's said that x, y, z are in AP. I got the conclusion that x, y, z are in GP. If x, y, z are in AP as well as in GP, that means they cannot be both. If they are both, that means they are same. So that is the possibility only when all of them are equal. Did you all get that? Everybody understood this? Can I move ahead from here, all the participants? Now, when you solve the next question, it says tan inverse y is equals to tan inverse x plus tan inverse this. We just discussed it, that tan inverse y is equals to tan inverse x plus, this is tan inverse, I hope you remember, 2x by 1 minus x square, that is 2 tan inverse x. And we are told mod x from 1 by root 3. We did discuss that, ensure that the principal domain is intact to apply the formulae. So it is from that range minus 30 degree to 30 degree. So if triple is also done, it will be from minus 9 to 90. So I need not bother about that formula and I can directly apply that. So it is going to be 3 tan inverse x, and for 3 tan inverse x, we do remember the formula tan inverse. I hope you remember tan a plus tan b plus tan c. So I hope you remember it should be 3x minus, I hope you remember, tan a into tan b into tan c. I am talking about the formula of tan a plus b plus c. So that is x cube, I hope you remember, upon 1 minus tan a tan b tan b tan c tan c tan a. So that is x square in this sense. So that should be 3x square. And if it is what we are given as tan inverse y, this value we are given as tan inverse y. So from here we can clearly see y is going to be 3x minus x cube upon 1 minus 3x square, option C. I hope you can see this result can directly be matched or compared with this. Yes, tan 3x. It was a decent question based on tan 3x formula. Nothing much was needed. And you do not bother about that principal domain because they ensured that it is from minus 1 by root 3 to 1 by root 3. That is from minus 30 degree to plus 30 degree. So if triple is also done, then also it will be from minus pi by 2 to pi by 2. So principal domain stays intact. You can apply this direct formula. Everybody got that? So with this, I think we are done. So what did we do today? We revised two things. We revised algebra and then we revised trigo. First of all, we did theory and then we solved previous year's questions to revise that theory. Now, in the next marathon session of mathematics, we will revise coordinate geometry with vectors and three-dimensional geometry. Again, a very important chunk. So we'll do that. What I will suggest you now is that now, since you have done a lot of theory, solve as many PYQs as you can. Any other queries or concerns or doubts you have, you can ask. Otherwise, we can call it a day. Any queries, concerns, any problems, issues you have, please post. Otherwise, I'm calling it a day. So with that, let's call it a day. Thank you so much. You have been a great audience. Take a good care of yourselves, students.